Hello everyone. Intellipaat presents a full course video on blockchain. As the name suggests, blockchain is nothing but a linear chain of blocks that holds information of transactions taking place over the web. Every block contains data in the form of coding that is organized in a chronological manner. This information is packaged into blocks which link to form a chain with other blocks of a similar information. Every business runs on information. The faster it is received and the more accurate it is, the better. Before we begin, make sure to subscribe to our YouTube channel and also hit on the bell icon so that you never miss an update from us. Now, let's see the agenda. Firstly, we'll see what is blockchain. After that, transaction distributed network. Later on, we'll see how blockchain has evolved in recent time. Then we'll move on to what is distributed ledger technology. After that, we'll see what is Bitcoin. From there, we'll move on to various transaction forms in Bitcoin. After that, we'll understand what is data mining and hashing. Then we'll see how to use Bitminter. After that, we'll see what is Ethereum. From there, we'll move on to various transactions in Ethereum. After that, a quick hands-on demo on how to set up Ethereum blockchain. And lastly, Solidity in blockchain. Now, let's begin the session.
Hi all. So as we know, the blockchain term has arrived and become very popular in past few years. What is actually it is? What blockchain exists for? As the name suggests, it is a chain of blocks. What blocks? A block of information, maybe financial, maybe educational, maybe your scientific information, or maybe things you are thinking. So commonly we say blockchain is a chain of blocks that may have any kind of information for which they are developed and designed to. Every block in a blockchain has information about the transaction happening in the network. A block can have more than one transaction grouped into a block, and it is again complete in itself. So you can refer anytime in a blockchain to any block, and you can see from where and when it was generated and what pieces of information it has. So before moving into details, we will first see what is our agenda for this whole course, what points or what learnings we'll be doing during this whole session in form of sequential recordings. So we'll be discussing about introduction about cryptocurrency and blockchain. When we say cryptocurrency, we know it is a virtual money that can be used exactly similar way like we do our hard or physical money, but it has much more additional features that our physical money do not have. Virtual money or virtual currency can be used anytime without interference of any third party, or can be used over internet, over shopping websites, or over other payment mode enabled websites or windows that where we can shop and pay to the items that we are shopping. So virtual currencies, when these are made secure through certain cryptographic mechanisms, are called cryptocurrencies. Okay, how this happens? May we all know that what cryptography is and how it helps securing information over the internet or even the data offline from getting leaked to someone that is not authorized to read that information or read that currency. How it happens, we'll be discussing later. So, the second thing that we'll be discussing is delving into blockchain, then what Bitcoin is, and how it is related to blockchain, or vice versa. Because in today's scenario, most of us understand Bitcoin is blockchain, or blockchain. If we discuss, then they understand blockchain is Bitcoin. But that is not the case. We will see how they differ and what comprises the elements into other or vice versa. Then we will discuss and learn how Bitcoin mining happens. In blockchain term, mining is creation of a new block. How new blocks are generated and made as a part of existing blockchain network. Then we will learn how to set up our blockchain environments, private blockchain environments actually, which we call permission blockchain as well. Okay, so let me clarify here. When we discuss about blockchain, there are two kind of blockchains, permission and public. So permissions are permissions are private blockchains that are controlled and are made available within organization with certain permissions, and so that no everyone can access and make changes or impact creation of new blocks. Bitcoin is a public blockchain where everyone can participate and do purchase and participate in the transaction happening inside the Bitcoin network. The major two platforms that we'll be discussing here will be Ethereum and Hyperledger. We will see how we can set up our local environment and start building local transactions over Hyperledger and Ethereum networks. Then we will also see creation and deployment of our private blockchain on multi-chain networks, and we will also discuss about prospects of blockchain, what power blockchain has to do our diverse tasks, that whatever we can think of, starting from daily things, that is financial transactions, withdrawing money, sending money to other parties, doing purchases, buying stocks in markets, recording educational informations like degrees, mark sheets, etc., to recording your land transaction as well. So this is a course outline of this whole session that you can find one after the other. Okay, so let's see what cryptocurrency and blockchain are and how they are related with each other. At the end of this session, we should be able to understand the drawbacks in current financial system and infer how a spectrum of finance can be secured using distributed system, induce the key concepts which constitutes the distributed system, infer various type of currencies, and deduce various uses of cryptocurrencies. So when we say blockchain, the similar term distributed comes in parallel. So why we call blockchain a distributed system? So when we discuss about blockchain, these are termed as distributed ledgers also. Why distributed ledgers? Because informations are stored in distributed manner, and the same copy of information is stored on all the ledgers at the same time, and all ledgers need to be in sync. So that's how blockchain constitutes our distributed ledger system. We'll see how it all happens when we work on the blockchain. So before moving to that, we should know how our trading units transform from past to current modern exchange systems. We are well aware of barter system, okay, where utility things were used to make sell or purchase of items. Then it then came era of subjective ledgers, mental accounting, where things were recorded on ledgers for making sale and purchase of items. Then came physical objects, where we started exchanging the things that we have in return of the things that we do not have from each other without interference of third parties. Then gold and other assets were part of currency system or trading system for long, where golds or other assets were used to sell and purchase of items, and these were used even nowadays also. These are used as universal ledgers and form a basis of currencies of many countries, or you can say form a basis of economy of many countries. Then the current era came where paper money or fiat money system was used primarily to sell or exchange items among each other. Then we know we advanced in trading systems and we started using virtual money, using online banking, cards, debit cards, ATMs, and other e-wallets also exist in current days that make our transactions very much easier. Then corporates also use their inbuilt token system, or you can say their own kind of exchange systems inside their organizations for buying like meal, their certain facilities, maybe their shopping carts and other things that again constitutes a trading system where they record their transactions and their values in form of corporate tokens that are specifically allowed and designed for that corporate or organization. Then the future, or you can say modern era, comes where Bitcoin or decentralized digital money is being used to transactions, purchases, or sell over the network using virtual money. Bitcoin in current scenario, if we discuss, exists equivalent to our dollars, pounds and other standard currencies and is very well recognized to do online transactions. And it has very much good value as compared to your dollar that makes the whole currency system workable. So let's see what Bitcoin is. Bitcoin was derived from your computer's smallest unit, your information system's smallest unit, bits. And how it was named as a Bitcoin? Because it was a programmable money or programmable currency. So that's how it got a name called Bitcoin. And when we try to define it, it is a type of cryptocurrency which is nothing but a digital money. And the underlying technology that enables moving of digital coins or assets among individuals is blockchain. And Bitcoin was the first ever implementation of blockchain. And that time people thought that only cryptocurrencies can be built and run over blockchain. But as the things moved year by year, people started understanding that blockchain can be used as a universal network where all kind of information can be stored, exchanged in a distributed manner in form of distributed ledgers which are immutable, secure, non-hackable and easily auditable whenever required, which give huge level of transparency that our current system do not have. It removes mediators that are present and impacting badly our current financial or other kind of systems. So these all benefits came when people started understanding what blockchain actually is. I will continue from our last topic that we were discussing about cryptocurrencies and blockchain. So let's see what blockchain is. As we already discussed, the blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions but virtually everything of value. So what does this definition means? Does blockchain stand for only financial transactions? No. You can store and propagate any kind of information that you want to store and use on your blockchain network. So your blockchain network is not really limited to financial transactions such as Bitcoin or maybe other cryptocurrencies. So if we say in broader terms, blockchain is simply a data structure where each block is linked to another block in a time-stamped chronological manner. Each block has its timestamp of creation and the transactions that constitute this block. These blocks again stored in a chronological manner according to their according to their creation time. Second point, it is a distributed ledger, digital ledger of an immutable public record of digital transactions. This means the information is stored in multiple digital ledgers, distributed digital ledgers, which have same copy of information stored and immutable and cannot be changed once recorded. Every new record is validated across the distributed network before it is stored in a block. So when we say a blockchain is a self-sustained, self-validating network, so validation becomes an important and integrated part of any blockchain network. Every block that is going to be written in the existing blockchain should have gone through a standard validation process before getting recorded in a block. During this validation process, your validators decide and record only good blocks. The bad blocks are discarded, and that's how your blockchain kept safe and secure. All information once stored on the ledger is verifiable and auditable. You can anytime go and check your blockchain network. You can traverse through it and verify and audit any information that is recorded. Each block is identified by its cryptographic signature. We know that all blockchains have distributed ledgers which are owned by different nodes. So the information is not available in a plain format. Everything in a blockchain is stored and saved using cryptographic signature, or in other words we can say in form of encrypted information only. The first block in any blockchain that you develop or produce is called Genesis block. The Genesis block is the very first block that you have to create, and at position 0 if we talk about length, and that should be the point where your whole blockchain starts and other blocks in that blockchain start following that Genesis block. So definition of blockchain, as we already discussed, Genesis block will always be your first block in any blockchain network when you are designing it, developing it and start using it. So the other blocks in the network follow this Genesis block, and every block in the chain identifies the previous block using its block ID, or you can say hash of that block. So this way, every next block is aware which block to follow or which block is following itself. So to access data of the very first block created, you have decussate from the last block created to the first block.
Okay, guys, a quick info. If you're looking for an end to end blockchain training, we at Intellipaat provide that. And you can check those details in the description below.
Okay, so at any point of time, if you want to traverse the blockchain network, you can start from the last block and you will be, if you follow that, you will be successfully able to get your genesis block and the length of the blockchain. Sounds good? Yes, so this is one of the interesting feature of blockchain where it know what there is. Every block knows who is their ancestor following him. Then how blockchain tectonic shift happened? Sorry, how blockchain tectonic shift or roadmap we can assume from now. The 2017 started as a golden period of blockchain where venture capital flows $10 billion has been invested into Bitcoin. Everyone started recognizing the power of the blockchain. They started using it, and now everyone thinking how they can utilize the features, immutability, securability, your non-hackability of and the other features like removal of mediators, peer-to-peer transactions. These are all very good features that everyone in industry want to use blockchain for their businesses. And then to everyone started investing into the Bitcoin and blockchain, and the amount of the invested into the blockchain, so Bitcoin in 2017 was $10 billion. That started moving it at very faster pace in the market. If blockchain grows with this pace, that we are really sure. So by 2023, we can, which we can say a development phase of blockchain, age of consortium, alliance, and governance, Gen X platforms can come on the blockchain network and start leveraging the features and services of blockchain. Again, by 2024, the blockchain inflection point can attain critical masses, can become integrated part of many organizations. By 2025, point of no return, we see that most of the organizations have already moved to the market and already moved to the blockchain, and they are not in mood to return from the blockchain. Okay, so just to summarize, you can take a scenarios like by 2023, your government may start collecting tax on blockchains. 1 trillion IoT sensors could be connected to the internet. Digital transformation of outreach of 80% of population. Your your masses and population shall start receiving things digitally. 80% of the population should start leveraging the features of digital technologies. By 2025, sharing economy 2.0, P2P economy, and can become peer-to-peer economy can become very famous and can become integrated part of the sharing. You may have smart city fully operational based on the blockchains by 2026, and by 2027, 10% of the world GDP will be on blockchain technology. So this is the assumption based on the current growth rate of blockchain and the awareness that people are trying to invest and utilize the features of blockchain in their businesses and to make the world and their countries a good place to live. Before we know how blockchain benefits us, we should know the current system. Why we need blockchain when we already have successful running current system behind all required needs and services. The current system works that we use in our day-to-day life is for trading, for selling and buying items that are recorded in offline ledgers where transaction details are stored. Bookkeeping is isolated and closed to public. The public do not have direct access to the books, and for this reason, we need a trusted third parties or middlemen that we trust and they help facilitating the services, whether it is library, whether it is trading, whether it is shopping, buying over networks, maybe Amazon, maybe Flipkart, maybe other shopping sites that really requires a middleman to shop and purchase over the network in current scenario. So if we see, most of our services require a middleman to be utilized. So on and on, we see below challenges with the current systems. Banks and other parties, or you can say other third parties, take fees for transferring money. Nothing is free. If you involve a third party, they will not work for free. They are going to charge, they are already charging a good amount of money. That is an overhead on the system. Mediating cost, again, increasing the cost of transactions. Things are becoming costly for us. In any ways, end user has to pay for any services they are utilizing.
Okay, guys, a quick info. If you're looking for an end to end blockchain training, we at Intellipaat provide that. And you can check those details in the description below.
It's not their organization is going to pay. So ultimately, things are becoming costlier for us, the consumers. Minimum practical transaction size is limited, cutting off the possibility of small casual transactions. Financial exchanges are slow, checking and low-cost wire services take days to complete. International cross-border transactions really require good amount of time for any transaction to complete because of current existing systems of middlemen or mediators. System is opaque and lack transparency and fairness. We don't know what is happening behind us, what is happening with our money that we are spending in banks. We are investing in banks, we are investing in stock markets, and that's how system is completely non-transparent to us. Also, the central authorities that are controlling the system, currencies, maybe from banking, maybe from stock markets, maybe from other institutions, are have completely have chances to overuse the power they have and can create money as per their own will. Even every country's currency system is being managed by their own head banking institute. Okay, so these are some of the current problems. There are more, but these are few major issues with the current systems that are motivational factor behind use and utilization of blockchain. Because your blockchain helps overcoming all these problems. What could be possible solutions? We need a system which eliminates the need of middlemen or third parties, thereby making transaction cost nil or negligible, right? If there's no middleman, we don't need to pay him. We can save that money and make things cheaper. Enhance transaction execution speeds and can facilitate instant reconciliation. Again, is transparent and tamper resistant in order to avoid manipulation or misuse. If things are transparent, no one with or without authority can tamper the information and do false transactions for their own benefits. Currency creation is not in control of any central authority. If you see, we are on a blockchain or similar network, there is no central authority who can impact the system or example currency generation for their own benefit. This can also help regulating and maintaining the value of currency. Things in current system sometimes go beyond control. Inflation cost may go very high. That is something unexpected with the current system. Things are not predictable as they should be. So using a system like blockchain will help regulating the currency, money, economy in a very expected and time-bound manner. So how distributed system solve this problem? Distributed system enables a network of computers to maintain a collective bookkeeping via the internet. This is open and is not in control of one party. It is available in one ledger which is fully distributed across the network. So there will not be any single authority controlling the information and things are available in distributed ledgers, say computers or nodes. So how distributed system looks like? You see, it is a environment or you can say network of connected nodes, say computers, servers, peers, or you can use any term that have their own computational power, storage, and logic to do transaction in a distributed system. So all in all, we can say a system where two or more nodes work with each other in a coordinated fashion in order to achieve a common outcome is called distributed system. All nodes, all computers in the network should be serving a common goal. If they are blockchain system, cryptocurrency system, they have to be meant for financial transactions. It's modeled in such a way that end users see it as a single logical platform. For end users, the what matters will be the outcome from the network. What they want to do, they should be able to do without any middleman. What is a node in the distributed system? A node can be defined as an individual processing unit in a distributed system. All nodes are capable of sending and receiving messages to and from each other. Nodes in a distributed system need to be connected with each other. Some may be directly connected, some may be connected through other nodes. So the whole purpose is whatever information is flowing in a network should be able to propagate to every node without any specific delay or any tampering. So let's start topic cryptocurrencies and blockchain. So during the last session, we discussed about what blockchain is, what distributed ledger is, distributed chess system, and the basic idea on Bitcoin. So let's see what kind of distributed ledger technologies are available nowadays. The picture on the screen elaborate many things about the platform used, the technologies, the consensus mechanisms, the application use cases, industry outcomes, consortiums about the distributed ledger technologies available nowadays. So major player in as part of infrastructure and technology providers are cloud vendors like AWS, Azure, Google, IBM Bluemix, etc. play an important role in providing infrastructure to distributed ledger technologies. Then they are needed to run blockchain infrastructure, providing sufficient and good amount of resources to run your blockchain transactions with a good speed and high accuracy. Platform technologies and providers are or can be divided into private and proprietary, private consortium, and open sources. Few are open to the market and can be utilized for as per the individual needs. Example of private and proprietary providers are Digital Asset, Nasdaq, Chain, Tendermint, Casper, etc. etc. Then your private consortium constitutes Corda R3, CEV, Sentinel, and then comes your open source available blockchain networks or distributed ledgers you can say called multi-chain and Hyperledger V1.0. Then there are multiple open providers like Ethereum, Stellar, BBFT, Bitcoin, Consensus, Paxos, etc. So on the top of the platform technologies and providers, there runs consensus mechanism to finally run your transactions and commit them into a new block. So there are various kind of consensus mechanism evolved with the evolution of blockchain technologies. Few are leader based, few are proprietary distributed ledger consensus based, few are federated consensus based, few require your very generic algorithms like proof of work, proof of stake, proof of elapsed time, and other mechanism to allow your validators or miners to create new blocks and give them chances equally to commit their transactions and write them into a new blocks. So all the consensus mechanism you see here, some or other way, helping validators to validate their transaction, record their new blocks in fair manner to the blockchain network. What actually consensus mechanism is, we will be learning in coming slides. Then what could be the application and use cases of blockchain networks? You can use them in trading finances, cross-border payments, commercial paper trading, digital identities, asset security tracking, document digitization, accounting and assurances, cryptocurrencies, tokenization, swap reporting, smart contracts, blah blah blah. So there are ample of use cases where people are doing their blockchain involvements and writing their programs to use them to use their use cases in blockchain network that can inherit all the said features of blockchain. There are various industry consortiums supporting this all development. One is Hyperledger V1.0, there is R3CEV, PTDL Group. These are some example of consortiums supporting this whole development and taking the blockchain to the industries and other required destinations. Now, let's discuss about transaction in distributed network. How a transaction happens. So, suppose James wants to transfer some money to his friend Kevin. How it will go now? Now, since there is no central authority in the system, there can be certain questions that might come to your mind like who will be validating the transaction? Who will validate if James already has sufficient money? If during the transaction on the fly, the money was not lost. The transaction initiated was from James only. There should not be any chance of repudiation. When Kevin receives the money, it actually received the money. He cannot repudiate that he did not receive the money. So how these kind of scenario you're going to manage in distributed transactions? So as we already told, the term that consensus and you can simply say the validation algorithms help maintaining the consistency and the validity of any transaction that are happening inside a distributed network. So when James start any transaction to send money to Kevin, it goes through various validator nodes. They see, they run the logic and check the recipient and sender's address using their public key or other methods available that the sender is genuine, he has the required balance, and the recipient where the money is going to is existing in the network and is able to receive the money successfully. Also, there is no any duplicacy or loss of transaction while or before committing it inside the network.
Okay, guys, a quick info. If you're looking for an end to end blockchain training, we at Intellipaat provide that. And you can check those details in the description below.
And while committing all these transactions and validating them, each participant will record the transactions once it is successfully published inside the network. So, whenever you go to a blockchain network and validate or audit the ledgers, you will find same copy of information stored at every node. And if any node differs from other nodes inside the network, then it will not be allowed to be part of the network anymore until it recovers and becomes in sync with the other nodes. Now there will be certain questions in your mind. How to verify from where the transaction is initiated and what to and to whom it is sent. How is the transaction faster than the present system? Who validates the transaction as there is no central authority? And how is currency generated? There is no one funding the network. So how the new currencies are generated and how people are increasing their balances. So to satisfy your curiosities, first let's see how a transaction is initiated in a distributed network. Every participant in the network has their two pieces of information called public and private key. And those who are aware of public and private key know well that these are root items or root contributors of any cryptography mechanism or system. So, while sending the money, James will encrypt or sign the information that he is paying money to $500 to Kevin, will encrypt the information and sign it using his private key. That will go in form of a cryptographic information, encrypted information over the network, and then when Kevin receives the money, he will use the public key of James and decrypt the money and have the amount. So this is how a transaction initiated. There are multiple steps and phases through which a transaction is successfully committed to the network that we will be learning when we will see and discuss in more details. So just because we are discussing about cryptography and public and private key, I will just like to elaborate here on public key cryptography mechanisms that we use and those have become industry standard nowadays to keep our information secure over the open internet because everything is online and we and programmers are continuously starving to derive day to day in even day, on daily basis they are continuously fighting and trying to derive new technologies that can cryptographic technologies that can help keeping your information more secure because hackers again trying to break your network and use your information without your authority and they again try to weaken the network and the weaken the security system of any organization for their own benefits and own needs. So when public key cryptography is used, this can be of two kind: symmetric key cryptography or asymmetric key cryptography. So symmetric cryptography is not very much secure. So everyone uses asymmetric key where you will be given where every user will be given two keys, pair of keys in terms of private and public key. So out of the both keys, one is purposely kept private, the other is provided to the other parties, and that is called public. If you use private key to encrypt the information, then public key can be used to decrypt it. So if you use the public key to encrypt, then you can use public private key to decrypt, vice versa. Because two different keys are used for encryption and decryption, this is called asymmetric key in algorithm. So using this information, the person who is having your public key, and receiving the information encrypted by your private key will be in a situation to decrypt the information and ensure that it is you that has sent the information. This helps to maintain and identify the sender by using and decrypting the information using their public key. How these keys are stored? These keys are stored in form of wallet. These wallets could be a folder on your system, on your drive, online, or maybe a flat file you are storing the details. So wallets could be of multiple types for storing the keys used for the encryption and decryption. So every user or every node in a blockchain network will have their own wallet to store their keys called key store. And this is not with the blockchain only. This is true for all cases where encryption and decryption are used. Your SSL, your TSL, your digital signatures, your Kerberos mechanisms, everywhere you need a wallet to store your keys called key store. So Bitcoin addresses and wallet. How Bitcoin addresses are maintained along with the wallet. So an identifier of 26 to 35 alphanumeric characters beginning with the number 1 or 3 represents a possible destination for a Bitcoin payment. So if you see any string that is starting from 1 or 3 and length 2635 will specify a Bitcoin address. Any user that is holding a node in a Bitcoin network will have a Bitcoin address where from where or to he will start any transaction and participate in the Bitcoin network to earn coin and do transactions. Bitcoin wallet. A wallet is basically the Bitcoin equivalent of a balance or bank account. So when we talk about wallet in Bitcoin, it is equivalent to your bank account where you keep your whole money. So it allows you to receive Bitcoins, store them, and then send them to others. So like your normal bank account, you can store money and send the money whenever required to the other person. Once a wallet is installed on your computer or mobile device, it will generate your first Bitcoin address that you need to remember. Each address has its own balance of Bitcoins that it maintains and updates along with the transactions occurring. However, the addresses can be changed whenever you want to. These addresses cannot need to be unique. You can change when you want to change your system or place. There are various kind of Bitcoin wallets available in the market. There are software wallets available, like Bitcoin Armory is the most popular, stable, and secure software wallet that is used nowadays. There are web wallets available. Web wallets add a level of convenience that software wallets can't, such as being able to access your funds from any device. So using web wallets, you can access your funds anywhere and do transactions inside the Bitcoin. Cold wallets. Cold wallets are simply any kind of Bitcoin wallet that isn't connected to the internet and that can be used to do the transactions. Then comes your paper wallet, USB drive that can be used again on the go. You can take them with you and participate in the network whenever needed. Then there are brain wallets available when you don't want to keep any wallet and keep the passphrase in your brain. You can use them and remember in your memory to do the Bitcoin transactions. Then comes hardware wallets that can only be accessible with the physical contact to the wallet and have hit the scene this year only. So considering the requirements, Bitcoin has given the facility of hardware wallets that can be used and kept with you like physical identity like cards and then can be used to do the transaction inside the network. Now let's know what transaction is. A transaction is a piece of information that you want to share in order to update the existing items or generate a new items in form of transactions and block inside the network. So while sending a transaction, your system or network follow a mechanism of modifying the information or generating encrypted entities in order to keep your information safe. The transaction is broadcasted in the form of a digital message, as you can see in the picture, and just like your signatures provide the proof of ownership on the document, similarly, digital signatures provide the proof that is transaction is genuine. Unlike a handwritten password, digital signature is unique for every transaction. So what it means actually, whenever you are sending information, transaction details are hashed using your private key. And these are treated as a signed message authorized by you and sent over the network. The recipient knows your public key, gets your message, your public key and decrypts it further to get the hash value of the data information sent over the network. Now, this hash value is regenerated at the receiver end using your key and checked if it is same for the data or hash value that you already sent with your information. So this is how sender and receiver maintains the integrity of message by hashing the data they are sending over the network, by signing with their private and deciphering with their public key, and then guaranteeing the information by using the hash of information. Because has the property that for any certain given string, it will always generate a unique value that can never be changed until provided string is changed. This is how hash is used to guarantee the information is not tampered or changed while transmission. Even if a dot is changing the information, your hash value will change completely. So how transactions are propagated over the distributed network? How are the transactions are faster than the present system inside distributed ones? What happens When you do transaction in current system, you may be connected at a significant distance with your recipient. So the network delay will cause the whole delay on your transaction, and that can be a significant amount of time. But when you transact in a distributed network, in a distributed architecture, transaction is transmitted peer-to-peer. Transmission of the transaction across the network takes around 1 and 2 seconds only. So every peer node helps you propagating the transaction over the whole network and collectively help passing the information to each and every node inside the network so that every node has updated information inside the ledger. This way, information travel faster than the current existing system. For example, take a scenario where a node in the network finds a transaction that Kevin pays 5 coins to James. So now what it does, it passes that information to the very nearby B and C nodes that are connected to it. Now, B and C will pass the information further to other nodes that are connected to it directly. And similarly, other nodes will do until all nodes are covered. Hence, this way it is faster and cost efficient as there is no middleman and the propagation takes lesser time than the existing system. Now, when a transaction is submitted, who takes the responsibility of validation of the transaction because there is no middleman? So now the question will arise in your mind. When there is no middleman, there is no authority to validate your transactions, how transactions are being committed in the blockchain? Who will take the responsibility? Or if there's no one, how developers or blockchainers are writing the codes to make it automatically done? Let's see. There are some special nodes in the network who verify the transactions and maintain the ledgers. They are called miners. So miners are basically responsible for keeping your data validated before recording into them in a new block. So these validators helps creating new blocks based on all the conditions met as per the logic written. So they also helps to find good transactions and bad transactions. They remove immediately whenever they find a transaction is bad and not following the standard. Since there are multiple nodes participating inside a network, there will be multiple transactions to be validated every time. So what validators do, they keep checking for the transactions, they group them in the new block and then validate all the transactions and then try to generate a new block and put it into the network, and that increases every time they do, that increases the length of the blockchain by one block. So when you write logic for your blockchain validation, new block validation, you need to be careful that it should include all logics that you want your validators to perform during the validation check automatically. So your algorithm or your code should be smart enough to do this all without any human or physical intervention. So miners are what miners are called. Miners are special nodes which hold the copy of the ledger and verify the transaction happening in the network. Using state-of-art cryptographic algorithm, miners validate the transaction across the network. They are responsible for creating and committing new blocks in the existing blockchain. In order for our digital monetary system to work, the miners must be able to confirm that the originator of the transaction possesses the fund being transferred. The originator of the transaction has obtained the funds by one of the means commonly recognized as valid. So they perform all the required check. If this is a financial transaction, they are responsible to validate if the request is coming from a genuine node, which is actually part of the network. And how they do? They use a public key to validate the sender. Same way they do for the recipient if the recipient exists by using the information shared by the each node inside the network. So they also inquire about the funds that to be transferred, that they are sufficient and available in the wallet of the sender node. So once they find all situations satisfactory, they run to create a new block inside the network. Verification. How to verify whether transaction is initiated and to whom it is sent. So as already told, that digital signature is used in transaction verification. Every node that is initiating the transaction uses his private key to encrypt the information he is sending over the network, and that information majorly includes the details of the transaction, what he is doing, to whom he is, if he is sending a money or bitcoins, to whom he is sending, and that those all information are kept in a block, in form of data, and that is being signed by the sender with its private key to make a digitally signed signature. Then this information is propagated from the sender node to other peer nodes, and then the validators use the public key of the sender James, say, to decrypt the information and defy if it is being sent from James only. This way, they authenticate the transaction and the sender and recipient of the corresponding transactions. So, once transaction is validated, how it is stored onto the network? Let's see. Once the transaction is verified, it is stored in a shared ledger across the network. How it does that? It keeps appending the informations to the existing network in the form of blocks. And if you see from the figure, each node should have same copy of the information, and any node that is having different information and not concurrent with the existing blocks nodes will be removed from the network. So each block of information is appended and replicated across each node inside the distributed ledger. Here in the example you can see James, there are three transactions. James sends $5 to Kevin, and that is be recorded in the ledger of each node. James, Kevin, Robert and Paul. Then Kevin transferred $3 to Paul. That is also you can see recorded, and then similarly other transactions will also be recorded in each ledger, or you can say nodes ledger. Now, ordering of transactions. Since transactions are passed from node to node, there is no guarantee that the order in which you receive them represents the order in which they are created. Quite possible, because there are multiple nodes participating in the blockchain, and there may be any number of nodes initiating the transaction in the network. Then, no one can guarantee that they are maintaining the order while being received by the validators without creating a strong logic. To agree about the transactions order is a challenge in a decentralized system. Therefore, the cryptocurrency system orders transactions by placing them in groups called blocks and then links them in a chain. How they do it? They group the transactions on the basis of their timestamp of generation in a group. They call it a block, and then they create a new block and commit it into the blockchain network. So since we know now how transaction is initiated, how it is recorded, validated, and then stored in each node's register, we need to understand how miners group the transaction into a block and how they commit them into the existing blockchain. From the figure, you can see that there are multiple unconfirmed transactions. You can see new transactions that are not already committed to the block or blockchain that constitutes. For example, here Lisa sends Sandra 7 Bitcoin. Mary sends John 10 Bitcoin. James sends 5 Bitcoin to Kevin. Now, there comes a validator node which picks all these transactions in a group. He writes a block like you can see here, and then they form a new block with the information of previous block, creating the new ID for this current block, and then start committing them into the Bitcoin network. One more important thing is that you should observe from the diagram is every block has a number attached to it that corresponds to the length of the blockchain and block ID of every block created in the network. And the most important, the relational thing is every block has is maintaining the hash of the or ID of the previous block in it. And this way it really helps to maintaining the integrity of the blockchain, and since every block remembers the address of the previous block, no one can inject a new block between any block in the network. This helps keeping your blockchain immutable and unhackable, you can say. Now, there is a chance, and this happens practically, like when your miners are creating a block in the network, they will not be alone participating for creation of or mining of a new block. There will be multiple miners working to create a new block. And that is where you need to write logic, or you should need to have mechanism where various miners are constructing blocks. There could be several options to choose from. How does the network decides which block should be the next in the chain? How you'll be deciding which validators block the network should choose. So again, there is a logic in Bitcoin, existing one, and while you are writing your hyperledger, you need to be when you're writing a logic for your blockchain, you need to be very conscious while writing this logic, like how miners will behave and how their work will be picked against others while writing new blocks. So there can be number of miners constructing a block that we already know. Now we need to see which miners blockchain should pick and write. So for the sake of this, for the sake of the integrity and the selection of a new block, there are certain mechanisms defined by every blockchain technology provider, whether it is Ethereum, whether it is Hyperledger, whether it is Sawtooth, or any available blockchain network or blockchain platform nowadays. So few are like proof of work, proof of stake, proof of elapsed time, and PBFT. These are certain mechanism, or you can say algorithms, that helps the blockchain deciding new upcoming block in the network. So let's see one example of proof of work, how it helps deciding the and selecting the work of a validator in form of a new block. Proof of work is a piece of data which is difficult, costly, time consuming to produce, but easy for others to verify, and which satisfies certain requirements. To keep the coin distribution predictable, puzzles become increasingly difficult to solve when more people work on them. Part of Bitcoin solution is that each block must contain the answer to a specific math solution. So, since we are concerned about how new blocks are picked, so proof of work is an example of doing so. More we will be learning in the next video. Now we'll be discussing how out of multiple validators, blocks will be selected and added as a new blocks in the blockchain. So, in our last lecture, we saw that proof of work is one mechanism using which Bitcoin and some other blockchain platforms decide out of multiple validators which node to select for new block creation. So, let's discuss proof of work in detail now. What proof of work is? Every validator node must say, given a task, given a work to find some value, said nonce, in order to calculate and solve the problem or algorithm given by the blockchain network. The winner node is given a chance to create his own block and add it to the existing network, and then publish to all other nodes that the block creation has been done successfully by him. So every node has been given the same problem to solve, and then they start working on the solution of the problem, and depending on their resources and processing power, they try to solve the problem first. The winner node gets a chance to add his block to the blockchain and becomes the winner and get awarded by the Bitcoin or other mechanism in the different blockchain networks. So how it works actually? This algorithm, or you must say a puzzle that has been given to the nodes, varies in terms of complexity depending on the size of the blockchain. If there are more validators competing to perform the calculation and solve the problem, then the puzzle becomes more complicated, and it becomes increasingly difficult to solve when more people work on them. To describe in more detail, we will take an example of some sort of problem that may be given to the nodes, validator nodes, in order to solve and create their node. Suppose the problem is to solve is there is a string, say hello string, and how it works, each validator need to calculate a nonce, say n, that should generate a string where the hash value of it should be less or equal to 2 to the power 240. This is just a number. We are just trying to analyze a problem that can be given, and how proof of work actually works in order to decide the winning node. So the string and other things may simply vary, but the problem lies similar to this. Each node now need to guess the n value in order to win the puzzle, and for which the value of hash of this whole hello plus n should be lesser than 240. They start calculating it, say from 0. N is again integer, so they should be starting from 0. So the whole string becomes hello 0, and the hash of it may come around 2 to the power 252, say. So this is not the right choice. We need a value less than 2 to the power 240. So now the node will do, what they will do, they will try on value 1 of n. So they do the hash of it, and that may become maybe 2 to the power 272, somewhat. This is again not true. We need a value lesser than 2 to the power 240. Suppose it goes on now, and at certain point they get a value n, say 98. By hashing to that, we get a value, say 2 to the power 239. Now this satisfied the situation where the n is equal to 98 gives you a value that is less than the required condition given. Okay, so this is how the node that gets the value n first will be the winning node and will be allowed to create the new block in the blockchain. This is an example of proof of work. There may be other puzzles, complicated puzzles might be given to validators in order to solve the puzzle and become winner. So as we discussed, as we saw in the example, there are three components which help in achieving the proof of work solution. One was nonce, that was the value that we had to guess in order to get the required solution. In technical terms, if we say a random number whose value is set so that the hash of the block will contain a run of leading zeros, the rest of the fields may not be changed as they have a defined meaning, right? So the fields or the string was given hello in our example, and we kept calculating the value for which a given criteria is met. Second important thing is hash, a fixed length number which result in large unchanged data when read. Okay, so that was the value of the nonce plus string that we calculated a hash upon and tried to find the result. Third is transaction, authentic transfer of Bitcoin ownership collected and recorded in the blockchain. So this is how proof of work actually help creation of new blocks by deciding the winner out of the multiple nodes, validator nodes in short. Now, how a blockchain network decides on the puzzle? Why is it hard? The moment you keep increasing your network, your validator nodes keep increasing. So, how you do it? The SHA-256 is a one-way function. Hence, the brute force is the only way to a particular output value, meaning it is having combination of 256 keys where it becomes really very difficult for a attacker to find a solution or find or encrypt the function value and get the actual data. On an average, it makes many random guesses to find a solution, and thus the challenge is tough. It takes around 10 minutes on an average for someone to find the special key for the solution. So, since it is having 256 key combination, so it takes much time, resource, computation power in order to find the result. Hence, a new block in Bitcoin example generated every 10 minutes, not before that. So this is how your proof of work actually helps. But if we analyze in detail, the proof of work becomes a very resource extensive and time consuming problem process. And in this way, this really requires huge computing power, and obviously a node which with high computing power will get a chance to win again and again over other low computing nodes that are available in the network. How this can be overcome, we will see later on. But this is again, despite of few limitations, this is again a strong solution that exists in blockchain like Bitcoin and others to be used to decide the new block creation. Security problems of hash functions. Now, how hash functions help deciding the security of the data. First of all, it is collision free. What it means, if you are given a string, even a character A suppose, then hash of A will always be unique. Means if you have been given a hash of value A, then you cannot get another value B or C or anything which can generate the same hash value. That means to generate the same hash value of anything, it has to be that thing only. That means hash of A can be equal to hash of A only. It cannot be hash of B. Second, hiding. A hash function is hiding if when a secret value R is chosen from a probability distribution that has high entropy. Then high Rx, so it becomes infeasible to find X, means concatenation of two strings. Means if you're concatenating two strings, then the value again, the hashing value becomes different, and it is really difficult to find the value of X that is changing that string. Third, it is puzzle friendly. For all probable value output value B, if M is chosen from a very high spread probability distribution, then it is not feasible to find the hash value of any given function, say w plus dz equal to a. So hash is very frequently used for creating puzzles and to solve them in blockchain networks. Now the bigger question comes, why when validator nodes required to invest high amount of energy, computation power and time, then why do they participate in mining of the new blocks? This is why because they are given incentive in return to the creation of successful block. So, example in Bitcoin, every winner block is a winner block node is awarded with the Bitcoin. In other blockchain also, there are mechanisms to award the validator nodes and result to the creation of new blocks. Minus reward. What do they get to do? What do they do to get this? Minus tries to find the key to the complex puzzle as we have already seen, right? Search for this key is random, hence the miner needs to invest huge computational power and energy. The miners are repeatedly guessing new keys until the first key is found that matches the puzzle, that is the nonce. The miner who finds the key publishes the block to the network. All this happens and we have seen already. Other miners stop creating the blocks and will take the published block, validate it and add it to the ledger. So the published new block will be added to all will be published first to the network and all nodes will take it, validate it and add it to their ledgers. In the diagram you can clearly see new blocks are appended at the end of the blockchain network. Now the reward. Since miners use their valuable resources to validate the block, they are given monetary award. In case of Bitcoin, they get some newly created Bitcoins as award. So every new generation of block creates Bitcoin and the validators of the nodes get rewarded in terms of Bitcoin, and this is the reason they take interest and help and participate in creating new blocks. Exhausting resources to solve the puzzle means the miner has actually solved the puzzle proof of work. That is why it is called proof of work. They are spending time, they are spending resources and getting the solution that proves their work. The diagram you can say the amount of electricity and computational work they do is equal to the monetary award they receive. Now we will see how new currencies are generated in a blockchain network, say Bitcoin. So we know the generation of transaction inside a blockchain network and their validation by the validators and the winning blocks. This whole process helps creating new blocks, and in return the new currency or new coin is generated and awarded to the winning node. So how this all happens? Currency generation. As a result of incentive to miners, new bitcoins are generated and sent to the miner's address, that is, their wallet. A predefined schedule limits the number of bitcoins so that they gradually approach a total of 21 millions. So, if we talk about Bitcoin, only 21 millions Bitcoin can be generated as per the current hard-coded value in the Bitcoin blockchain network. So, this value is hardwired in the protocol, and in current scenario, it cannot reach above 21 millions until the value is changed by the in the protocol itself. So currencies are generated as a result of winning and creating a new block in the blockchain and in form of reward. Now we have already seen how proof of work actually helps creation of new blocks and result of generation of new reward money. So what happens? There's another scenario. There may be more than one validators that may be able to solve the problem at the same time. And in this way, more than one block may get solved in the same time. So, what's the problem here? I have understood that the first miner to provide proof of work will get the reward. What happens in the case when more than one block gets solved in the same time? Yes, this is possible. Maybe two nodes have same computational power and luckily they get to solve the problem in the same time. And if the such scenarios result, then these can be solved by consensus rules. Now, what is consensus? How it is built? Now, in layman term, if we talk, consensus is something where all nodes reach to a point of agreement and agree to submit only one node as a result of new block generation. How consensus algorithm should be written? Consensus algorithms are central to the functioning of any blockchain because when multiple blocks working, becomes very common that multiple nodes may be able to solve the problem at the same time and you get multiple new blocks to be added to the network. Now that time you need to decide which node you give the preference. If there is a contradiction among the nodes about the blocks in the network, such a contradiction is solved by the consensus rules. Now these could be consensus is the task of getting all processes in a group to agree on some specific value based on the votes of each process. With a consensus algorithm, we need to give unanimous agreement from all nodes to submit and decide a winning node. Any algorithm that relies on multiple processes maintaining common state relies on attaining a consensus. Okay, so how it happens? Every node have to be agreed on a value by a voting system or by some similar ways to reach on a consensus and decide which node will be writing his block to the new blockchain. And if this scenario arises, there will be several branches participating to create the block. Although the problem is tough, however, there are chances that more than one block will be solved. Several branches in the blockchain are possible in such cases. Right, like if you see in the picture, these three nodes may be solved at the same time and may try to add their block at the end of the blockchain. And if some other nodes are also generating at the same time, so they may consider the generated new blocks as the last branch of the last block of the blockchain. And they may again start adding their nodes behind the new ambiguous blocks. So what happens? Everyone should simply build the blocks on top of the first block that they receive, and that creates branches in the blockchain. So other nodes may have received the blocks in different order. They will be building on the block they first receive. This keeps happening, and the blocks may get added to all three branches. Now, what algorithm will do? Say from the example, you see Paul received a green block first, hence he builds the next block on top of the green. What Robert does? He added orange block first, and then he keeps building his new blocks behind that orange node. Then what Lisa does? She got new blue block, and hence she will start building the new blocks behind that blue block. Now, what happens if blockchain consensus tries to solve the problem? It will try to solve the problem by finding the longest branch. What statement says? The trie gets broken when someone solves the next block becomes because it is very rare for this solution situation to happen multiple times in a row, right? What it does, it will find the longest branch, and then in order to stabilize the situation, it will use the longest chain available as the main branch of the blockchain network and discard other blocks to try again and get added to the network. If you see from the diagram, Paul's, Robert and Lisa have to be agreed on the longest blockchain that Robert created. Now blockchain quickly stabilizes. Every node is in agreement with the current state of the ledger. Everyone writes their ledger with the current blocks details that are newly added to the system. Now what happens to the transactions in shorter branches because they were valid transactions? They were formed from the winner blocks, winner nodes. So how they will be, whether they will be kept or discarded, let's see. Such transactions go back to the pool of unconfirmed transactions and will be picked later in the block by the miners in order to commit, and hence these won't be discarded from the network. If you see from the picture, it says transaction in the shorter branch lose its place in the longer chain, and transaction then go back to the pool of unconfirmed transactions and will be included later in the block. In this way, none of the valid transaction will be lost from the network, maintaining the integrity of the system. Again, now, since everything is automated, there is no mediator, no authority. There are chances that some of the miners, in order to get awarded, try to cheat the system. How blockchain prevents cheating inside the network? Since there is a reward for solving a block, there are chances that miner might give a wrong solution to the block. What happens in such cases? After creating a block, miner has to publish the block within the proof of the work to the network. Other miners now start validating the block to ensure the authenticity. Means the winner block will not be simply submitted to the chain. It will be validated by other miners who were participating and lose during that time. If the proof of work provided is wrong, the block is considered to be invalid. As a result of which the miner end up exhausting their resources without getting any award. So if miner tries to do that, tries to cheat the system, he will fail, and if he fails, he will not get any reward. That will lose all his effort and energy that he invested in cheating the system or creating a new block or wrong solution. Once he did not get anything, he will never try to work again and give a wrong solution. This way, none of the validators try to cheat the system, and therefore the consensus algorithm does not allow anyone to cheat the system. This way, you can say here blockchain is cheat proof. Since now we have learned how mining happens, This is a just glimpse of whole process take place during the mining of a new block. Select the header of the most transaction recent block and insert into the new block as a hash. Now, what is happening? Here comes a miner which bundles all the transactions in a block and then verify if the transactions are valid. Once it finds the transactions are valid, it will select the header of the most recent block and insert it into the new block as a hash. Now, it will solve the problem by using the proof of work, and if when the solution is found, the new block is added to the blockchain and propagated to the network to be aware of everyone's knowledge. Now, second problem, how blockchain saves from the hacking. What if someone tries to alter the transaction in the block? Once a block is solved, the cryptographic hash output becomes the identifier of that block. And even if someone tries to hack, it will get. The block contents actually contains the previous block ID and transactions random guess. This way, it will give you a hash output. If someone tries to alter any transaction in any of the block, the hash of the block changes. And you're already aware now, if someone tries to, even a dot is changed in the given string, the hash value completely changes. And this way, the attempt to change the value of the node or block will be failed and no one can hack the system. And this way, if someone tries to hack the system and tries to alter the block, he need to change significant number of blocks in the system and arrive to a consensus of a certain decided amount, say 50%, in order to commit all his changes to the network. And this way it requires a lot of energy and time, and this becomes almost impossible by any hackers or any intruders to change the data of all the nodes or even 50% of the nodes to reach any consensus, and hence fraud can easily be detected. The validators will not allow any hacker intruder to change the data of the nodes or blocks. Even if someone tries to do that, he needs to have huge computational power that is not possible in current scenario and needs only quantum calculation can help doing this. That is not possible in nowadays even. So if you see by this way, since quantum computational power is not yet available, it's under research phase, so there's no way to alter the system. If you want to alter any transaction in a block, you have to outrun the whole network. You have to make the changes in the whole ledgers, whole nodes, and it becomes really difficult, impossible actually to change the data or transaction data inside the blockchain network. Now question arises, is it possible for someone with an extremely fast computer to outpace every other node? It is highly unlikely that someone can do that even with 1,000 of computers. Why? It would require more than 50% of the total computational power of the entire system to have a probability of solving 50% of the blocks faster than someone else. And that's, again, as I told, not possible in current scenario. It is highly unlikely to have a computing power stronger versus Earth and human. In order to sum up, the blockchain in a distributed system transaction is encrypted by asymmetric cryptography, propagates peer-to-peer, are stored in a public ledger, is authenticated by miners or validator nodes, is secured by consensus algorithm. So these all 6 pointers sum up your blockchain technology and are significant pillars of any blockchain design and network, making it unhackable, immutable, secure, transparent, and distributed. Now, what are the benefits of blockchain? For now, we should be able to understand why we need blockchain to implement our solutions and get the and overcome the problems with the current setup and current system of the problems that we already discussed, like middleman, like cost, like latency, like cross-boundary problems, and other things that we really want to avoid by using blockchains. How it helps? What are the benefits? Removing the reliance on a trusted third party to maintain a central ledger has the following benefits: settlement in real time, cost saving, security and resilience, immutability, user pseudonymity. We will see how these all benefits come from blockchain. So, in a nutshell, the use of mathematics to create a secure ledger enables transaction without the need of a third parties and hence access to shared single source of truth. There is no authority or control person to manipulate with your data side your organization by using the blockchain. What is anonymity and pseudonymity in cryptocurrency? Because your cryptocurrencies do not use their direct identity. Here comes the way they utilizes your identity in form of anonymity and pseudonymity, and how they do it. Let's see. There are two kinds of cryptocurrencies by going these identity terms. anonymous and pseudonymous. When we say anonymous, the state or quality of being anonymous, lacking a name, lacking individuality, an anonymous person is non-identifiable, unreachable, and untraceable. You don't know who the person is, where he resides, what's his address, and from where he is doing his transactions. So this whole property makes him anonymous to the whole network. So again, he will not bound to or link to any entity. Now, example, for anonymous dealings, unidentified individual telephonic an APP entity to inquire generally about its goods or services, and an individual completing a retail transaction and paying for goods in cash. Means a person using telephoning using an APP entity to inquire generally about goods and services, and then an individual completing a retail transaction and paying for goods in cash. So the person using telephoning will you not be able to identify, he will just order and get the services. There are some examples of anonymous blockchains or identities, Spring and others, Omegle, blogging and other applications you can see from the slides. And how it happens, how it helps being anonymous on cryptocurrency network. Being anonymous has its own rewards. It also adds value, but invisible exchange of values is a double-edged sword because you never know what other person is doing and who is the person does that. Extremely valuable how examples some form of truly anonymous communication such as political speech are considered valuable. Electronic harassment into trades and business, this form of anonymity has exceptional potential for illegal acts because the message senders cannot be held accountable for their actions, and being anonymous makes it harder to trace transactions and giving higher level of privacy. So you can see here, being anonymous has advantages and disadvantages both, but for some currencies and some Bitcoin cryptocurrencies, it becomes valuable, and like Bitcoin and others, Zcash, these are building blocks and used for transaction as anonymous identities. So Zcash is again an example of anonymous cryptocurrency. First, totally anonymous cryptocurrency it was, provides completely anonymity solution, hiding all knowledge about the transaction. No one knows who is doing the transaction and what is the content of the transaction. It is a concealed value exchange, provides user with private access control to their financial information, and it is an application of zk-SNARK's cryptography that uses anonymous identity. Only those with the correct view key can see the content. So to view the contents of the transactions, you need to have a public key of that sender. Users can provide view at their own discretion. Zcash is a very interesting technology, provided the security is not being compromised. So, as an anonymous cryptocurrency, Zcash has its own advantages and useful in certain areas. Then other kind of identity comes is pseudonymity. What pseudonymity stands for? It uses your identity, but not your real identity, but some pseudo identity given to you. Using a pseudonym to establish a long-term relationship with some other entity without disclosing personal identity to that entity. Example, your ID number or your employee ID in an organization is your pseudo identity. Hence, a pseudonym is a unique identifier, example a nickname, credit card number, student number, bank account number, etc. that can be used to identify yourself. Using pseudonym, entity links different messages from same person, and pseudonyms are widely used in social networks and other virtual communication. Okay, like in Facebook and other social platforms, you use your nicknames to communicate with your friends and your networking peers. Importance of pseudonymity in cryptocurrency. All the transactions in pseudonymous network are open and visible to all, and thus it is widely acceptable. No financial organization or none of organization never want to do transactions and messages exchange with anonymous persons. So pseudonymity stands very popular in cryptocurrency network, blockchain network, and the transactions have origin and destination address, and hence the flow of money can be observed transparently. Illegal use of cryptocurrency can be tracked by careful analysis of metadata. So in this way, if you see from the diagram, A sends 4 bitcoins to B using his address. Okay, it currently has 6 bitcoin, and the A's address is pseudonym identity for A. It is not sending A on the network. It is sending his address as his pseudonym entity, and then network verifies the transaction using the keys and other things available with them, And then once confirmed, validated, B will receive the 4 Bitcoin from A to his payment address. That is again B's pseudonym identity. So this way, whole thing works inside a pseudonym blockchain cryptocurrency network. Second thing is your cryptocurrency is programmable money, right? All Bitcoins or other cryptocurrencies are generated by programming, by the result of transaction inside the blockchain network. Each unit is individually identifiable and programmable. Users can assign properties to each unit. Users can program a unit to represent a euro cent or a share in a company, a kilowatt hour of energy, or digital certificate of ownership, because of which the cryptocurrency is much more than supply than simple money and payment. It has vast application in number of areas that make them more useful than simple currency or payment system. Example of how cryptocurrency can be programmed. For a single transaction between two parties, programmable money can give the pair and pay a vastly greater range of parameters to use when exchanging value. You can always program your cryptocurrency as you desire, and you can add as many number of features that makes your programmable money or cryptocurrency more useful as per your need. It also enables a huge array of different valuables to be exchanged, far more than a conventional money. Time, contracts, expertise, goods, services, and more can all be traded. Okay. So since it is programmable, you can add as number of modules, functionalities as you want. As an example, say Alice buy a car online from Bob. The payment will only be executed after the car has been delivered and passes an emission test. The term verification is completed by shipping agent and the emission test agent. When both are complete, then only transaction is authorized and the money change hands. It is very clear now, right? Until all the checks, all the tests are passed, transfer of fund will not happen. So these all conditions you can write in your currency in order to propagate with validation and required checks. So apart from Bitcoin, is there any other implementation or cryptocurrency? Apart from cryptocurrency, is there any other implementation of blockchain? Yes. Affirmatively, there are various ways in which blockchain can be implemented. What are these? Although Bitcoin was the first implementation of blockchain, blockchains was named or was recognized from Bitcoin only. The underlying technology behind Bitcoin was blockchain, and everyone recognized it after the popularity of Bitcoin itself. So many people even now understand Bitcoin is a blockchain, and blockchain is Bitcoin. Those who lack knowledge in this area consider both things as the same. However, if you want to utilize blockchain, we can utilize it anywhere. However, we need to think the cost consideration and the complexities before choosing blockchain for any implementation. Monetary aspect is just a tip of the iceberg of blockchain technology. Blockchain is a ground-breaking technology for which money is merely one of the possible applications. You can use wherever you want. For finance, stock market, education, storing qualification data, industry flows, smart contracts, identity, asset, anything you want, you think you can use blockchain to implement. Like for industry flows, you can use blockchain for settlements, change of supplier, meter data, real-time capacity matching, etc. etc. Then for asset management, you have autonomous network configuration. You can use it for self-serve maintenance. You can use asset and inventory tracking, cross-asset industry data sharing. Then for entity management, you can use it for eligibility of social traffic, safety authorizations, permit to work, fraud detection, loyalty schemes, blah blah blah. So whatever you want, you can bring it on blockchain. Same for goes for smart contracts like EV charging, peer-to-peer trading, demand side management, network services, whatever you think you can implement as per your need. Blockchain gives you a platform. It's a concept actually, which you can use to drive the products by in your own language, known language that you want to develop and design the whole network. Database overview. What if we don't have databases? Databases, everyone knows. These are whatever transactions we do over the internet, in our applications, offline, online, some or other way they are getting stored in databases if they need to be stored. Databases are being widely used for emails, for storing of emails, for caching reports, generating reports, exchange email sent and received via SMTP, IMAP and SMTP, response manager. Then one or other way, the single source of information storage is your databases. Nowadays, we have advanced database systems with no SQL, and that is again a backbone of our calculation in blockchains that we'll see how, but in later slides. What if we don't have databases? Did you know there exists an immutable and non-tamperable database that is called blockchain, and it is also called distributed ledger, distributed database also you can say. How blockchain started? In 2008, Satoshi Nakamoto, an anonymous person or persons, can say group of persons, first gestated and implemented the first blockchain database as an infrastructure for the Bitcoin, the first cryptocurrency ever created and most successful of all the time. So, we already know Bitcoin was the first implementation or use case of blockchain. How blockchain started? Satoshi Nakamoto used block and chain separately in his paper in 2008 October. Later with the time, it became a single word blockchain, and that was meaningful also. How blockchains were evolved? Blockchain started in 2008 by Satoshi Nakamoto was the initial stage. In 2009, blockchain 1.0 evolved in form of cryptocurrencies and payment network. Then in 2012 to 2014, blockchain 2.0 evolved in form of assets and smart contract management. Later in 2016 to 17, blockchain 2.5 and 3.0 evolved. Blockchain 2.5 evolved as vehicle currencies, distributed ledgers, data layers blockchain, while your 3.0 evolved as programmable smart contract. Smart contracts are unable to access external data or events based on time or market conditions. Calling code or data outside of the smart contracts or blockchain breaks the general trust barrier and authenticity of transactions. Means smart contracts interact with the internal data only. They work on internal inputs and in order to maintain the trust and authenticity of transactions. What is a smart contract? This is just a name you have heard now, and later slides will explain you how and what are smart contracts. Blockchain, the flow diagram. You can see from here, individual transaction events occur on blockchain. The form of it, new block of transactions include a security hash of previous block that we already know, and blockchain new blocks are added approximately every 10 minutes in Bitcoin, and multiple computers mining servers check the validity of blocks in the chain. The quickest to check the latest block gets payment. That is called proof of work. You know that? And those who have not attended previous sessions, proof of work is a mechanism to allow one of the nodes, validator nodes, to win and to solve the problem, maybe mathematical problem or some other kind. And if it wants, it will be eligible and given a chance to create the new block in the blockchain system. So in return, it will get awarded and thus a new Bitcoin is generated in order to award the winner node. For successful transactions, that block is added at the end of the blockchain, and the other blocks that are not passing the transaction checks will be rejected and will not be stored in the database. So this whole diagram depicts the scenario of new transaction as a part of block generation, block addition or rejection by the validators, and then their application to the peer systems. This slide depicts the blockchain innovations. Bitcoin, that was first implementation of blockchain application in 2008, and blockchain as application was the second innovation. First was your cryptocurrency, and then second was as application was for the second blockchain innovation. And third was the most smart contract embedded in a blockchain 2.0 system with introduction to Ethereum. Ethereum helped taking the and bringing the smart contract system in the blockchain 2.0 system that helped computer programs directly built into the blockchain that allowed financial instruments. Now, developers and users were able to write logics in smart contracts that were helping them to regulate financial transactions and use blockchain as financial instrument. The fourth critical innovation was proof of stake. Current generation is secured by proof of work, the new system replacing them with complex financial instruments for similar high degree of security is proof of stake. Now, blockchain and distributed ledger technology, how they differ from traditional databases. Let's understand more about blockchain and see how it differs from traditional databases. Later we will discuss about the distributed ledger technology as well. This whole table compares blockchain versus traditional databases in terms of various properties or you can say areas or features. First is data ownership. Maintained through in blockchain, it is maintained through cryptographic key pairs and native cryptographic algorithms using public and private key pairs for encryption and decryption the information sent over the network. Legacy databases, how it happens? It happens via central authority, the database administrator, who is responsible for maintaining the data and access controls apart from other required activities. Privacy and security. It is again maintained in blockchain using cryptographic authentication. Private and public keys are used to identify the sender, the initiator of the transaction, and other properties of the data block. In legacy database, it is again configuring each row based on enforcement from a central authority. Your again database administrator is responsible for maintaining the privacy and security of the databases. Access control. Inherently identical for all permission nodes and maintained through given permissions in permission blockchains. In databases, it is actually centrally administered and applied by the database administrator again. Trust. Native via immutable records. So this is coming as part of the blockchain concept only. Since records are immutable, you can trust the blockchain that no alteration or change to data will happen without valid transactions. In legacy databases, you had to trust on central authority only for your database integrity and security. Now comes data quality. Immutable records in blockchain with automatic conflict resolution through consensus for transaction. Blockchain, the logics are written in a way that the records become immutable, and while registering new blocks, the conflicts are resolved using consensus between participating nodes. In databases, complex conflict resolution process requires manual intervention, sometimes to resolve the conflict and maintain data quality. Database validity. In blockchain, it is continuous. All databases ledgers remain in sync and store same copy of information and always update it for each and every new block added. In legacy databases, provided for single instance in time. Data propagation. Quick propagation across all network nodes and every time a new block added and a new transaction initiated. In legacy databases, it is managed through multi-version currency control and through custom synchronization. That is again done by database administrators. Enforcing data transformation built into data layer logic only. So your data layer logic itself keeps this data transformation handy. In legacy databases, there's no provision for enforcing data transformation. Currency and synchronization. In blockchain, we already seen that consensus always commits only a one block, new block at a time, and hence maintains identical copies of data. In databases, it involves complex checking between central DB and users DB to ensure agreement. Reliability and availability. Peer-to-peer networking for distributed data replication across all nodes. Because peers are and nodes are connected in network forms, so reliability and availability is already maintained through replication between all ledgers at the same time of new block generation. In legacy databases, there is always a chance of single point of failure, and availability is again always a question. Stored procedures are smart contracts, while in database not available. Transaction creation is available to all permission parties. They can start transaction and help generating the new nodes. In legacy database, again maintained via central authority. Fraudulent or malicious changes. Immutability through reliance on previous block helps ensuring there is no alteration to data or deletion of data happens inside the blockchain network. In legacy databases, not available where current keys and check constraints remain insufficient. So it's again a question in current databases that fraudulent or malicious changes cannot happen. There is always a chance and risk of changing the existing data. So that was a brief introduction about differences between blockchain and legacy databases. So now we will see what distributed ledger technology is and how it helps overcoming the problem of traditional databases, legacy databases. People think of blockchain technology and distributed ledger technology as one and the same. Interestingly enough, that is not the case. Let me show you the difference. These are the properties of digital ledger technology. Programmable, distributed. When we say distributed, all network participants have a full copy of the ledger for full transparency. Anonymous, the identity of participant is either pseudonymous or anonymous. Direct identities are never used in blockchain. Timestamp. Transaction timestamp is recorded in every block. Unanimous, all network participants agree to the validity of each of the records. Whenever a new block is generated, Each validator participates to validate the block and then help to add into the blockchain. Programmable. As we already discussed, blockchain is programmable. You can write your own logic and conditions to be met to help serving your business logic using the blockchain platform. Secure. All records are individually encrypted. Immutable. Any validated records are irreversible and cannot be changed. In short, all blockchains are distributed ledgers, but not all distributed ledgers are blockchain. Means blockchain is a subset of distributed ledgers. Hope it clarifies the difference between blockchain and distributed ledgers. So this pictorial presentation represents the various uses of blockchain. This is globally distributed with almost zero barrier to transacting goods and services. It provides online payments and digital currencies use cases, and that was the first use case in form of a Bitcoin. A range of industry use cases across banking, automotive, insurance, healthcare, life science, manufacturing, retail, and telecom are available, possible, and under research. Highly secure cryptographic implementation makes it really secure. All transactions being encrypted and decrypted using public key pair provides additional security on all the data being transmitted. The blockchain changes the game in IoT, Internet of Things. Blockchain has emerged as a game changer in the other widely being growing area, that is Internet of Things, and really make it feasible to derive the application on basis of Internet of Things when used with blockchain. Peer-to-peer with no central authority. That constitutes a major benefit of blockchain, removing intermediate nodes or mediators from the network. Completely transparent and auditability. You can come anytime, traverse through the blockchain, and you will be able to find each and every detail in the form of consecutive blocks, recorded transactions that are really coherent and related to each other, and easily show you that there is no alteration or change happened to the recorded data in the database. This slide depicts comparison between popular blockchain frameworks. We are comparing here Ethereum, Hyperledger Fabric, and R3 Corda. Before moving with the comparison, I must tell you about these three terms. These are three kind of blockchain platforms available in the market that differ in characteristics but inherit all the properties of blockchain that make them part of secure blockchain technology. Description of platform. The first characteristics where Ethereum uses generic blockchain platform, Hyperledger Fabric uses modular blockchain platform, and R3 Corda uses a specialized distributed ledger platform for financial industry. Governance. Ethereum is owned by Ethereum developers, while Hyperledger Fabric is being managed by Linux Foundation and R3 Corda is being managed by R3. Mode of operation. Permissionless, public or private. So Ethereum can be permissionless, public or private, means restriction or restrictionless, both. While Hyperledger Fabric is permission and private only. This is meant for enterprise users and hence provide more security by restricting the access. R3 Coda is again permission and private, having more secure implementation. Consensus. Mining of new blocks is based on proof of work in Ethereum and at ledger level. Broad understanding of consensus that allows multiple approaches. In Hyperledger Fabric, you can use PBFT, proof of work, proof of time, and other approaches as per your requirement and the way your resources allow. Then consensus occurs at transaction level in Hyperledger Fabric. In R3 Coda, specific understanding of consensus that denotes required to design and the consensus is given on transaction level. Smart contracts. Smart contract codes are written in programming language mostly called Java called Solidity that is similar to JavaScript. In Hyperledger Fabric, smart contract code example Go and Java are used to write the programs for smart contracts. For R3 Coda, wherever Kotlin and Java languages are used, and smart legal contract uses legal prose. Currency produced by the Ethereum is Ether and tokens via smart contract. In Hyperledger Fabric, there is no currency produced, while currency and tokens are generated via chain code. There is no inherent currency in Hyperledger Fabric. You can design the situations and tokens as per your business logic in Hyperledger Fabric. R3 Coda has no currency, and this is basically used for financial industry. This pictorial diagram represents centralized difference between centralized and distributed ledgers. The first picture, you can see that in centralized ledger, all the clearing of funds is being done by central authority, while in distributed ledger, fund clearance is being done by each node and they need to agree on the transactions. Blockchain structure. Since we have learned enough about blockchain theoretically, we should be learning on blockchain structure now. How a blockchain structure is derived and designed. Let's see what goes inside the block of Bitcoin blockchain. What component constitutes the block of Bitcoin or any other blockchain? We'll try to understand using Bitcoin example. A Bitcoin blockchain structure is consisting of three components: header, Merkle, and list of records. When we say header, header contains version info, nonce, previous block ID, and timestamp, while Merkle is a hash built from blocks transaction identifier. What is Merkle? We will be looking into detail in coming slides. List of records identification hashes that was included into blocks Merkle tree. So your Merkle is built from blocks transaction identifiers, and those transactions list of record is contained in the transaction ID list. Diagram also depicts it clearly. The first portion is header, which contains version number, nonce, previous block hash, timestamp. Middle one has Merkle, that is the hash of blocks IDs, transaction IDs, while the last block section says Merkle tree hash of all transactions that is present in the middle block is contained from this list of transactions. So you could see that these various properties help to identify the relative block in the blockchain, and no one can touch and alter the sequence of blocks or data inside the blocks. The structure of the Bitcoin block header. Continuation of the same, it consists of three sets of block metadata, reference to a previous block hash, the difficulty, timestamp and nonce, and Merkle root. Below is the table that depicts the size of each item inside the blockchain header. Your version is 4 bytes. That could be a version number to track software protocol upgrades, 32 bytes, previous hash block, that is could be of 32 bytes length, a reference to the hash of the previous block in the chain. This is 32 bytes, Merkle root, a hash of the root of the Merkle tree of this block, and 4 bytes again timestamp takes, and that is the creation time of the block. Then 4 bytes difficulty target, the proof of work algorithm difficulty target of the block, that is set by these 4 bytes. Then nonce. Nonce is the value we already discussed. That was the winning number from proof of while solving the proof of work puzzle by the validators. Block identifiers, block headers hash and height. Your block header hash is the primary identifier of a block is its cryptographic hash. So any block, newly created block, has its cryptographic hash as the primary identifier of the block. Then a digital fingerprint made by hashing the block header twice results in 32-byte hash. The block hash identifies a block uniquely. These are the properties of block header hash. The block hash is not included inside the block's data structure also. Block site. It is the position of the block in the blockchain. So every blockchain, first ever block, the genesis block starts from 0 position. Each block added on the top has one position higher in the blockchain. That means n plus 1. If the current blockchain length was n, newly blockchain length will be n plus 1. Each block added on top has one position higher in the blockchain. So it is also not a part of blockchain's data structure. Each node dynamically identifies a blockchain's height in the blockchain. So blockchain's height is again a part of every block's field. So this was few items about your blockchain data structure. Merkle trees are important part of blockchain data structure that we have already seen here in previous slides. Like Merkle tree comes in the middle of the blockchain data structure, block structure, which contains hash of all the blocks transaction identifier listed in the last section of the block structure. How it is calculated? Now, Merkle tree, also known as binary hash tree, and a data structure used for summarizing and verifying the integrity of large sets of data. It contains cryptographic hashes displayed upside down with the root at the top and the leaf at the bottom. From the figure you can see all these points listed here can be compared with the present diagram. A block of one or more new record is collected and such records are then hashed and the hashes are then paired again and hashed again until a single hash remains. So what your Merkle tree does and how the values are calculated. If you see the diagram, you could see these are L1, L2, L3 and L4. These all are transaction data blocks. So while calculating the Merkle tree top hash, you pick transaction in pair and then calculate the hash of each transaction, each data block's ID, and which gives you these intermediate blocks. Once these hashes are calculated, they are hashed again and one single hash value is populated against these two items. Iteratively, these two blocks of hashes hashed again to form a root of Merkle tree. So this is how the hash value of Merkle tree calculated. L1, L2 transaction, then L3, L4 used in pair to calculate hash of L1, hash of L2, then hash of L1 and L2 are combined and hashed again to produce a combined value and root of the Merkle tree. So the single hash at the top of the root is called Merkle root of a Merkle tree. What are the advantages of Merkle tree? Why these are integrated part of any blockchain data structure? Merkle tree proofs and management requires only a very small and terse amount of information to be transmitted across a network. They do not create any overhead, but they in return help keeping your blocks data secure and labeled hashes help to avoid any alteration to a database by or during any time of transition. A tree constructed by hashing pair data, the leaves, then pairing and hashing the result until a single hash remains the Merkle root. In Bitcoin, the leaves are almost always transaction from a single block. Merkle tree requires little memory and disk space and proof of are computationally easy and fast. This is how your Merkle tree advantage or helps you keeping your blocks secure and easily validated. So this slide depicts the calculation of Merkle tree root from transactions. Suppose we have even number of transactions 0 to 7 and now you are trying to add next block 7. So we need to see how the structure of this block chain and Merkle tree value will be calculated. The Merkle tree consists of even number of transactions 1 A, B, C, D 4 transactions. Then from these transactions you get transaction value of A, B, C and D. These transaction values are hashed, combined, and hashed for both AB and CD in pairs. Then we get two values that are hashed again and combined with the hash of block 6, that is the previous block, and value of ABCD hash, the timestamp of creation plus nonce. And this way the structure of block 7, the header of block 7 is created. This clarifies how your blockchain header is calculated for new blocks. What if we have odd number of transactions? Let's suppose there are odd number of transactions in a block. In this case, the last transaction is hashed with itself. What does this mean? It means if we depict the diagram here, we have odd number of transactions and the transactions number 6 do not have any pair to create hash for. In this case, this number is hashed with himself and the result generates the number itself, the block hash itself. This way, if you have odd number of transactions, the Merkle tree is calculated. So this diagram actually depicts the transaction root or Merkle root inside a existing blockchain. So this can now be easily understood that data 1, data 2, data 3 and data 4 are calculated, hashed and then hashed again to retrieve a value of Merkle root. Blockchain ecosystem. What this term stands for. That means let's have a look with what are the components required to implement a blockchain. To implement a blockchain, you need distributed ledgers, node application, consensus algorithm. So these three are the main components of blockchain, and in order to build any blockchain ecosystem, you require these three components. Cryptographic and consensus algorithms. We know that cryptography and consensus algorithm are key constituents of any blockchain. So we learn to see what methods we can use to write our or can use with our cryptographic algorithms. There are three algorithms available majorly used with blockchain. Triple disk uses three individual keys with 56 bits each. In this way, the total key length adds up to 168 bits. Second, RSA is public key encryption algorithm and the standard for encrypting the data sent over the internet. RSA is again most popular cryptographic algorithm that is used to perform the cryptographic functions. Third one is Blowfish. Known for its speed and effectiveness, symmetric cipher splits and messages into blocks of 64 bits and encrypts them individually. So, Blowfish again uses symmetric cipher suits and it is more in speed in order to encrypt and decrypt the messages and into blocks of 64 bits and then encrypt them individually. RSA algorithm, because this is widely used encryption algorithm in a blockchain technology, so we will be depicting its functionality from the given diagram. How it works. When a sender wants to initiate a transaction, he uses RSS in cipher and its private encryption key to produce a enciphered data, or you can say encrypted data that is sent over communication channel as ciphertext. Once received at the target receiver end, this RSA cipher is used to decipher the information from the ciphertext and to get the plain text out of it. This is whole being done using the decryption key or private key of the recipient. How RSA works? So we now have a public key and private key and a method of for encrypting and decrypting using those keys. Let's see example to clear details. There are different approaches used in attacking the RSA algorithm. Brute force, it involves all possible secret keys in order to decrypt the information encrypted by RSA. Mathematical attacks are also possible ways. In mathematical attack, we are using different techniques which is similar in effort to the factor the product of two primes. So these are the two kind of ways approaches used for attacking the RSA algorithm in order to decrypt the information. Consensus algorithms. What consensus algorithms are used and typically used? The consensus provides the technical infrastructure layer for blockchain. This makes it one of the most critical components when assessing real-world use cases. Consensus are programmable, so you can write them according to your business need and your use case scenarios. Consensus is key because without a central authority, the participants have to agree on the rules and have to and know how to apply them. Consensus does two below things. It ensures that the next block in a blockchain is the one and only version of the truth. There is no faulty data or block available and should be present in the block. That is ensured by this consensus algorithm. Second, it keeps powerful advisories from derailing the system. Means there is no central authority controlling the system of blockchain. That is again ensured by consensus algorithms. So in this way, we can understand that consensus is the heart of the blockchain. So from the picture, you can see and understand that multi-parties transaction, any party can initiate the transaction. The transaction are recorded in order to network block and presented. Then the block is broadcast to the network and validated via the consensus mechanism. The network of nodes validates, verifies via consensus and confirm. The consensus is recorded and then provides the basis of the trust mechanism. Once verified, published, the transaction becomes a part of the new block for the ledger, and the new block is then added to the existing blockchain and transaction is complete this way. So this is whole cycle of doing consensus and writing a new block to the system. What is needed for the consensus? The basic concept acceptance of laws, rules and norms to decide a transaction on which all nodes should agree and follow the rules. The common acceptance of industry and institution that applies these laws and rules. This is very important. When you are writing a consensus, you have to abide by the rules of that institution for which you are adding the consensus and building the blockchain. If it is not done so, though, then the consensus will not produce a result that is expected by the organization it is implemented for. So we got in the previous sessions, we got brief basic idea of what consensus is. Now we had already discussed like what is needed for consensus. So The basic acceptance of laws, rules, and norms to decide a transaction should be part of your consensus mechanism. And similarly, the common acceptance of industry and institution that applies these laws and rules should also be considered while designing and developing the rules and algorithms for writing consensus mechanisms. So, in short, in layman term, if I explain, so consensus should include your all business logics, conditions, and all scenarios during any financial transaction or any business that your organization is doing and for which you are developing the blockchain consensus mechanism. So while designing consensus mechanism, what should be basic parameters and how these should be handled, that we will be learning in this slide. First parameter should be your decentralized mechanism. So as we know, while working on consensus, we are dealing with decentralized ledger, say blockchain. So a single central authority must not provide any decision finality. It should be designed and should be decided from consensus itself. Second parameter should be your quorum architecture. Nodes exchange messages in predefined mechanism, which may include stages or tiers. So that what does this mean? This means every node that is transacting in the blockchain should follow certain predefined steps, and any node deviating from this should be considered as a bad node and removed from the transaction. Third, validation. It provides means to verify the participating identities, including your validators as well. So suppose your transaction is started from a peer node A and he is trying to send some bitcoins to recipient or peer node B. So the consensus mechanism should be written in a way that it is able to identify the identity of participants participating in sender and receiver mechanism of Bitcoin and should validate having the information from the transaction itself. Without validation, none of the node or transaction will be recorded in the blockchain. Fourth parameter that should be considered by developing your consensus mechanism is integrity. So as you all know, it enforces the authentication of the transaction, integrity, and validation. So any transaction should be authenticated from the consensus nodes or validator nodes, and then only they should be recorded in the blockchain. Now, fifth parameter would be non-cancellation. This provides means to verify that the supposed sender really sent the message. And this we already learned. This could be done using the private public key pair. The validator node use public key of the sender in order to validate the identity by decrypting the message and using hash mechanisms. Sixth parameter is confidentiality. So your consensus mechanism should provide means to verify that the supposed sender really sent the message and whatever he sent is not changed and not visible to anyone. So the information shared inside the packet or transaction should be kept confidential and should not be visible to any other member inside the network. Your consensus mechanism should also take care of fault endurance. So the network operator should operate the network efficiently and quickly even some node fails or are slow. So what this means is even if your part of network of blockchain is faulty or slow, then the network operation should complete in quick and timely manner. There should not be any delay or loss of transactions. And the last parameter that should be considered while designing your consensus mechanism is fulfillment. That means it considers throughput, liveness, and latency. All should be. That means your consensus mechanism should not be complicated enough or should not be designed in a manner that create unnecessary slowness, complexity, and latency while performing the validations inside the blockchain network. Before moving further, we should understand how consensus mechanism came into picture. What was the history behind it? So this all the logic came from Byzantine general problem, where Byzantine army has completely encircled the city. The army has many divisions, and each division has a general. This story we have already heard. Some of you have already heard many times while learning some mathematical problems or while learning your algorithms. The same idea has been derived from again Byzantine general problem here in order to write your consensus mechanisms. So the actual story was like the army has many divisions and each division has a general when they encircled the Byzantine city, and the generals were dependent on communicating between each other, between their lieutenants within their division by exchanging the messages. So they were not able to communicate directly. The lieutenants were helping within their division to pass the messages to their generals, and this is how they were communicating. All the generals or commanders have to agree upon one of the two plans of action. That means exact time to attack all at once, or if faced by fierce resistance, then the time to retreat all at once. So the army cannot hold on forever. If the attack or retreat is without full strength, then it means only one thing: unacceptable, brutal defeat. So everyone had to be trustful and work in coordinated manner. When it was time to attack, they should be attacking with the with their full force and full strength without deviating from the rule decided. And if there was time to hold back, then they also should be doing it full strength. So complete agreement was required and complete action was required from whole force. So results: if no, in order to succeed, two-thirds of the generals needed to be loyal to the army. If the amount goes less, that means if more than one-third generals are in disagreement, then there were likely chances to get defeated or failed during the war. So, what was the solution to this problem? How they had to decide that their generals are trustful and trustworthy. They are not going to be deviate from the rules decided in order to get succeeded during the war. The practical Byzantine fault tolerance algorithm (PBFT), which is used to establish consensus in blockchain systems, is only one of those potential solutions that were expected to help the generals and the army to get in more than two-thirds of consensus during any attack and get success during the any kind of attack they were moving upon. What was PBFT? So, the solution came in 1999 when Miguel Castro and Barbara Liskov introduced a PBFT algorithm. PBFT can process an enormous number of direct peer-to-peer messages with minimal latency. How it works? Asynchronous distributed system where nodes are connected by a network. Byzantine failure model was faulty nodes behave arbitrarily. Independent node failures may happen in that case. So, cryptographic techniques to prevent spoofing and replace and to detect corrupted messages were also enforced in this algorithm, and there was a plan to have a very strong advisory in order to get two-thirds or more than two-thirds of consensus and avoiding fault and misbehavior of nodes, or you can say generals, during the message communication. This method of establishing consensus required less effort than other methods. What was actually happening? Each node, the whole piece of army, was arranged in form of a connected network. The peers nodes were connected in a manner like they were not connected to only one of the node. Nodes were interconnected with each other. So if some nodes start misbehaving or arbitrarily, then other nodes were able to pass the message to the connected nodes. So in this way, the generals were sure that the information they are getting is authentic and all the nodes are in sync. So this way of transmission was really fast, reliable, and was helping to attain a significant amount of consensus in less amount of time. So the propagation was happening through connected nodes. Now, the other consensus mechanism that we can use inside blockchain is proof of stake. Proof of stake, like proof of work, is a category of consensus algorithm for public blockchains that depend on a validator's economic stake in the network. Newer kind of a consensus algorithm, it was introduced considering the drawbacks of proof of work where energy consumption and time consumption was very high. And in order to succeed and become a winning block, the participating validators has to invest huge amount of energy as part of solving complicated problems. It was pioneered by Peercoin in 2011. Now, due to this, many versions exist for this proof of stake consensus mechanism, out of which some are NXT, Tendermint, Flying Fox, etc. Your chance of being picked to create the next block depends on the fraction of coins in the system you own. As the name suggests, the more coin you have, more chance of getting a chance to create a new block will be given to you. So this mechanism helps deciding the winner node on the base of a stake he already has. And in this way, the nodes do not need to solve complex problem in order to win the situation and create the new blocks. And this really helps saving the energy and resources during any new block creation, which is a frequent mechanism, a frequent step taken in any blockchain. A participant with nothing to lose has no reason not to behave badly. This is called nothing at stake problem. That means since it is really transparent that the node with required amount of stack or higher amount of stack will be selected. So in this way, since none of the nodes required to solve complex problems and get rewarded, so they cannot cheat the system by misbehaving and try creating the false results or false solutions to the given problems. The validators or winners are clearly picked from the available stake, and in this way they can help to creating the new blocks. So as of now, since we already know what is proof of work and proof of stake, so let's have a glimpse like how they differs in terms of each other. In proof of work, the probability of mining a block depends on the amount of work a miner does. That means he needs to find a solution for the given problem, and all the competing nodes are working to solve the same problem and find a particular number x or any number that is the end result of the solution. Since this requires solving more complex problems, it requires more energy than proof of stake. And one example is mining, which uses computer cycle time to validate new transactions. So mining of new blocks, as we already discussed, is using computer cycle time to validate new transactions, and every transaction new mining is generated. Sorry, every block through new mining is generated every 10 minutes in Bitcoin. That we already seen. So stakeholders in proof of stake validate new blocks by utilizing their share of coins on the network. So the validators nodes actually work on the share of the coins they have in the network, and that is called stake in proof of stake consensus mechanism. The first example of proof of stake was peer coin. A user would need to own a majority of all coins in order to attack the network. What this means is this mechanism helps any node behaving badly and retrieving them, and because they need to have majority of coins available in the Bitcoin or blockchain network in order to attack the network. Since at a single point of time, none of the node can have the majority of coins to alone attack the network and create their own nodes. They will not be able to cheat the system or hack the system at any moment of time. So this way we can see the proof of stake, again a very good algorithm or consensus mechanism that can utilize less amount of energy than your proof of work and still able to make system cheat proof and avoid hacking of the system from the bad nodes inside the system. So this was all about this fourth session of delving into blockchain, where we discussed consensus mechanism, how it works, what are the basic parameters, and what is proof of stake and how it differs from proof of work. There is another kind of consensus algorithm was introduced by Intel based on an analysis on the existing block proof of work and other mechanisms that were really time consuming and resource consuming and resulting loss of energy as part of new coins generated inside the bitcoins. So what proof of elapsed time does, how it is having advantages over existing consensus mechanisms. So proof of elapsed time was introduced by Intel and developed its own alternative consensus protocol called proof of elapsed time, which was based on waiting time or idle time of validator nodes. Proof of elapsed time, a Nakamoto-style consensus algorithm that is designed to be production-grade protocol capable of supporting large network populations. It means this was able to give fair chance to all validator nodes in order to create new blocks inside the blockchain in large network populations. POET relies on secure instruction execution to achieve the scaling benefits of a Nakamoto-style consensus algorithm without the power consumption drawbacks of the proof of work algorithm. As we all know that proof of work algorithm requires to solve huge complex problems in order to become winner. That was requiring good hardware configuration and huge amount of energy to be spent in order to find solution of the given problem. Basis on this, Intel analyzed that this consensus algorithm is having its own drawbacks and requires a lot of energy to be wasted. So they thought of giving time to all the nodes. For that time, they can sit idle and wait for their term in order to get the chance to create new blocks inside the blockchain network. So that's why it is called proof of elapsed time algorithm, because every node after creation of new block was given an idle time for which they can stay in sleep mode, and then when their time expires, their elapsed time expires, they are given a chance to create new blocks and fair chances given to every block inside every validator node inside the blockchain. POET example is used by Hyperledger Sawtooth, which is again Intel blockchain network. POET simulator, which provides POET style consensus on any type of hardware including a virtualized cloud environment. So this consensus algorithm can be used in any including virtualized cloud environment as well. So what are the advantages? Why we should be using PoET over proof of work and other existing PBFT or other consensus mechanisms. For the purpose of achieving distributed consensus efficiently, a good lottery function PoET has several characteristics. Fairness. It gives the function should distribute leader election across the broadest possible population of participants. Means all participants, validated nodes participating inside the validation and creation of new block should be given fair chance and equal chance in order to create a new block inside the blockchain, and that is being achieved by proof of elapsed time algorithm. Second was investment. The cost of controlling the leader election process should be proportional to the value gained from it. That means any validator node should not be investing too much resources, too much cost in order to gain a little reward from the system against new block generation. Verification. It should be relatively simple for all the participants to verify that the leader was legitimately selected. Every node should be given a fair chance, and that is what this PoET algorithm ensures and helps giving every node a fair chance in order to create new block inside the blockchain network. So this was all about consensus algorithms that we discussed. There are many more existing inside the current blockchain world, and every consensus algorithm is picked depending on the requirement and amount of resources available for creation of blockchain. Definitely, the low cost and efficient algorithm will be picked and used against other available algorithms while selecting any consensus mechanism. Moving to types of blockchain. So based on the scenarios and based on the categorization, blockchains are divided into multiple categories and differentiation is based on the current scenarios that are being used. Blockchains can be categorized into permissionless or permission blockchains. Simultaneously, they can also be categorized as public and private blockchain. Let's see how this is being done. Blockchain types. Public blockchain. A blockchain that is public is a decentralized, distributed and public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the collision of the network. Example, Bitcoin, Ethereum, Dash, Factom. Just to explain, blockchain, the public blockchain are accessible to everyone. Anyone from public can come, join the network and start doing the transactions. They do not have restrictions in order to create new blocks and in order to participate in the blockchain network. Obviously, the consensus mechanism will be there in order to validate the newly created blocks, and before committing them, they should be validated. Second type is private blockchain. As the name suggests, these are private blockchain network that requires an invitation and must be validated by either the network starter or by a set of rules put in the place by the network starter. So they have well organized algorithms written that whenever a new joiners come to the blockchain network, they are validated, they give certain access that is again restricted, and they need to perform their transaction accordingly. Examples, multi-chain and block stack. These are certain examples of private blockchain networks. The third type also exists that has more restrictions than these two, that is called consortium. Controlled by a consortium of members, only predefined set of nodes have access to write and read the data of block. Example, Ripple, R3 and Hyperledger 1.0. So these are really well suited for organizations that want to control their blockchain network and perform transactions in their own way. Second type of categorization of blockchain is permission and permissionless blockchains. Properly permissioned blockchain network differs from unpermissioned blockchain network solely based on the access control layer built into blockchain nodes. So, as the name suggests, permissioned blockchains are secure and give limited permissions to the miners and the joining peers inside the nodes. Every peer participating inside the blockchain network in permission blockchain is given certain amount of permissions only in order to perform certain actions. While in unpermissioned blockchains, peer nodes are free to do any kind of transactions without having any restriction and generate new blocks. Mind it that the consensus mechanism will always be there inside blockchain for validation and creation of new blocks, that is mining. So in permissionless, since the network is open, anyone can participate and contribute in the consensus, hence it is called permissionless blockchain. Versus the permission blockchain where that restricts the actor who can contribute to the consensus of the system state, hence this is called permission. You have any actor need to behave within the permission assigned to it, and he can result in actions according to that only. So based on these public and private blockchains, can be differentiated and categorized or bifurcated into as per the below chart and against below properties. Like if we talk about access, then public blockchains are always available publicly and anyone from public peer can read and write the data inside the distributed ledgers. In private, only nodes having access can write or read to the ledgers, distributed ledgers. Speed. Since in public networks, multiple nodes can join at any time and the number of nodes inside the public blockchain network are always high because of its openness, so transaction amount is also again high, and in turn this lowers the performance and efficiency of the blockchain, the overall blockchain network. Against to this, private blockchain networks are faster and because they have low number of nodes and peers participating inside the blockchain networks. Security. If we talk about security, private blockchains, security is provided by proof of work and proof of stake that we have already discussed, while in private, it is provided by the pre-approved participants. Next comes identity. So in public blockchain, rather using direct identity, anonymous or pseudonymous identities are used. We have already discussed what anonymous and pseudonymous identities are. Anonymous identities are where you will never be identifying who is the sender, who is the participant participating in the transactions. While in pseudonymous, pseudo identities are used, rather using direct identities like your employee ID is your pseudo identity or your candidate ID, voter ID, these are all pseudo identities using which someone identifies you in public blockchain networks. Despite of this, in private blockchains, pre-approved identities are used. Any participant that is participating or created inside private blockchain is given an unique identity and that is already approved and used in all transactions initiated by him and to validate him by the validators. Assets. Native assets are used in public blocks and in private blockchains, any asset can be used as native asset in order to store the transactions. So this was all comparison about between public and private blockchains. So based on the four criteria, we divided the blockchains into public, private, and permissionless blockchains. These can be again summed up in order to create four categories of blockchains, that is permissionless public, permissionless private, and permission private. Out of which permissionless public blockchain is very much open and most accessible to the any member or any outsiders that can participate inside the blockchain and do start transactions. Anyone can download the protocol and validate the transaction and create new blocks. Example of this kind of blockchains are Bitcoin, Ethereum, and Zcash. While in permission blockchain, permissions are included for the peers that are participating in the network, and it works on the proof of stake consensus algorithm. Ethereum after Casper is an example of permission blockchain, and anyone who meets the certain predefined criteria can only download the protocol and validate transactions. That means you have to give explicit permission to the members that are contesting or participating in blockchain creation. Then comes permissionless private. That has certain restrictions, but there is no specific permission granted. All the nodes are given public access and that are private to the organization itself. So in short, we can say all nodes that are part of the blockchain are interacting inside the private blockchain and all have all the permissions required to initiate and transact inside the blockchain. Then comes most secure blockchain, that is permission private blockchain. This is private to an organization, consortium, and has different permissions according to which all actors interact within the blockchain network. PBA and IPDB are example of permissionless blockchain private blockchain network, and PBFT and multi-signature are example of permission private blockchain network. So if we see in this diagram, so the public to private and the entities decrease from top to bottom, and if we talk about permission, then it goes again from validators to from permission to permissionless blockchains. Sidechains. So let's discuss about sidechains. In next session, till now we have covered all kind of types of blockchain. There exists another term inside blockchain platforms that is called sidechains. What are these sidechains? Sidechains are separate blockchains which is connected to other blockchains through the use of two-way peg, which allow transfer of digital coins or assets between blockchains at a fixed or otherwise deterministic exchange rate. If you can see from the figure, various sidechains are existing along main blockchain and giving two-directional arrow that allows transfer of bitcoins or digital coins or tokens between these sidechains and within main blockchain. These blockchains or sidechains, you can say, serve various purposes. Like this one sidechain can be used for beta releases, before making it main branch of existing blockchain, beta releases can be used to test the release before making it part of main release of blockchain. Similarly, there could exist sidechains of sidechains even, and these can serve different purposes. Even this can be used as microservices like micropayments. This can be used for R&D purposes, research purposes, and serving various other needs that an organization need. Sidechain extensions can be done in following manners. They can be used as native asset issuance. They can be used as smart contracts. They can be used as real-world property registries, and they can be used to secure handles. Sidechains can have other sidechains for things like micropayments. They allow for experimentation, pre-release versions of future sidechains, or even a beta version of Bitcoin itself. So, what all the advantages are that sidechain offers? Sidechains enhances blockchain performance and privacy protections. How they do this? When you have a different requirement, you want to test any new blockchain release. If you have any other service integration with, you can do it using sidechain without interrupting the existing main blockchain network. So your existing blockchain can keep serving the request the way it is doing as of now, and your new sidechains can be used to serve your special needs and special requirements that may not be needed as part of the main blockchain. Second, what they offer is sidechaining is any mechanism that allows tokens from one blockchain to be securely used within a complete separate blockchain, but still moved back to the original chain if necessary. Your sidechains are part of your main blockchain. They allow a point where bitcoins or other tokens can flow from main blockchain to sidechains and from sidechains to blockchain, vice versa. So, existing blockchain tokens can be used and utilized whenever required in the new transaction in sidechain as well. Sidechains can have other sidechains for also as micropayment as we have seen in the above diagram. So these are the benefits of sidechains that offer with the when existing with the main blockchain. Transfer of assets inside block sidechains. How it happens? Let's take an example of root role stock in order to transfer assets from one chain to another. So how it happens? The step one, a user on the parent first has to send their coin to a special output address that is of root stock address, and then coin will consequently become locked and unspendable. So the moment main blockchain start sharing his blockchain, that amount of asset is locked inside the main blockchain and becomes unusable for that amount of time inside the network. So it will not be shown in the main balance of the wallet of that node. Then the next step becomes after the transaction completes, the SPV then confirms it across the chains. So what does happen? When the transaction is completed, the blockchain node is freed up that amount of transaction and start reflecting in the network as its main available balance. So this is all happening by using the transaction and the coins available in the main blockchain, and that was used for transacting inside the other sidechain network. After waiting out a contest period, which is just a secondary method to help preventing double spending, the equivalent amount will be credited and spendable on the sidechain and vice versa once the transaction is completed. So when SPV confirms, where SPV stands for simple payment verification across the chains, then transaction is considered complete and the amount is again returned back to the and start showing in the node's wallet. Sidechains have their own miners to help protect them from nefarious actors and attack against the network. So in short, we can say that sidechains also are small blockchains that have their own miners and ensure the integrity and validity and authenticity of any transaction coming across in the network. So what are the platforms for implementing blockchain? Nowadays, since blockchain has evolved a lot in last 1 decade, there are many developers, organizations, investors, and ideas generators have evolved with various kind of blockchain platforms. So nowadays there exist multiple blockchain with multiple facilities, multiple advantages, and multiple features, out of which we will be discussing about few that constitute important area inside blockchain terminology. The first one is Ethereum. We all might have heard about term Ethereum. It is a public permissionless blockchain, a blockchain platform that lets anyone build and use decentralized applications that run on a blockchain technology. Like Bitcoin, no one controls or owns Ethereum. It is a public permissionless blockchain network where everyone can participate and transact and earn token or currency. Then comes multi-chain. This is again a blockchain platform for the creation and deployment of private blockchains, permissioned blockchains. So it can be used either within or between organizations as well. So this is permission. So this is permission and it requires permission in order to transact and participate in the existing blockchain multi-chain network. Hydra chain. A joint developed effort of Brainbot Technologies and the Ethereum project, it supports the creation of scalable blockchain-based applications. Then comes Hyperledger. This is again becoming very much famous in blockchain technologies. It is an open source collaborative effort created to advance cross-industry blockchain technologies. It is supported by Intel and open source Linux Foundation. Then OpenChain. OpenChain is again a blockchain platform that is well suited for organizations wishing to issue and manage digital assets. It takes a different approach than the standard Bitcoin approach on implementing blockchain. Then IBM Bluemix. Being a giant player, IBM also allows and have their own blockchain network and platform that is on IBM Bluemix, built on top of Hyperledger project, and it offers additional security and infrastructure facilities for enterprises. So IBM are preparing blockchain in such a manner that they are enterprise ready and can be directly used by enterprises and financial or other organization to start and migrate their existing applications to blockchain network in order to facilitate and utilize the features and benefits provided by blockchain. There is another kind of blockchain network exists that is called chain, yet another and well suited for financial applications based on chain core, which is an enterprise software product. Then IOTA is another blockchain that is a revolutionary new blockless distributed ledger which is scalable, lightweight, and for the first time ever makes it possible to transfer values without any fees. If we see, the above blockchain platforms take some amount of fees in one form or other, while IOTA helps, that is again a blockless distributed ledger and do not take any fees for doing transaction over blockchain network. There are various more. BigchainDB, an open source system that starts with a big data distributed database and then adds blockchain characteristics, decentralized control, immutability, and the transfer of digital assets. Then comes Corda. It is again a digital ledger platform which pluggable consensus. So multiple consensus can be used here, plugged with the blockchain and utilized and simply forms a different kind of blockchain with flexibility of adding pluggable consensus. You can anytime change the consensus algorithm from proof of work to proof of stake, from PBFT, from POET. So it provides various options of using multiple consensus algorithms. Quorum, an open source digital ledger and smart contract platform based on Ethereum, that is customized Ethereum platform using distributed ledger and smart contract. Stellar, an open source distributed payment infrastructure that provides RESTful HTTP API servers which connect to Stellar core, the backbone of the Stellar network, and help you giving a blockchain network where you can utilize and do your transactions related to your business need. So at the end of this session, you should be able to identify Bitcoin at its era, understand where and how to get the Bitcoins, identify Bitcoin wallets, identify Jaxx Wallet, define selling Bitcoins, compare Bitcoin blockchain, transaction and transaction script, describe various transaction forms in Bitcoin, define scripts in Bitcoin, list nodes in Bitcoin network. So let's see what Bitcoin is and what was its era. Even this era time also can be considered as Bitcoin era only because it is again still booming in form of a cryptocurrency and stands very strong against all existing currencies like dollar, pounds and any other. So let's learn about the history of Bitcoin and its detail of Bitcoin. In 2008, Bitcoin.org was registered by Satoshi Nakamoto. Bitcoin, a peer-to-peer electronic cash system, white paper posted in October 2008, and that was the first time when world came to know about blockchain or Bitcoin. In 2008, Bitcoin kept growing and Satoshi mined the first Genesis block of 50 Bitcoin in January. The first block in the Bitcoin blockchain, as we all know, is called Genesis block. So the first blockchain Bitcoin's length was 50 Bitcoin containing Genesis block. Bitcoin 0.1 released on cryptography at netsdao.com and Usenet. Then coming to 2010, first offline transaction of 10k Bitcoin for 2 pizzas was done successfully. And first specialized GPU hash miners and pooled miners operation was also successfully done. In 2011, continuing the journey of Bitcoin, it took parity with US dollars first time ever. It came into existence as a global currency. $31 top of first bubble followed by the first price drop. 2012 December $13 slowly rising for a year as it was really fluctuating. So during the history of Bitcoin, it kept fluctuating yet kept creating history in the financial market. and showing people the strength of blockchain. In 2013, November, Bitcoin broke $1,000 in second bubble. It was a peak for Bitcoin currency, but sadly, in December 2013, prices crashed again to $600. In 2014, prices fell again following the shutdown of Mt. Gox, impacting the Bitcoin market. Bitcoin continued to fall due to a false report regarding Bitcoin ban in China. There were various fake news around Bitcoin. People were not secure. Few news were false news were generated by the financial markets. It is online money. It's not secure. Hackers are driving it. Blah blah blah. In April, it started stabilizing at $450 after a long time. After a long fall, it stabilized at $450 value. In 2015, prices fell again through to early 2015. Large spike in value from 225 to 250 at the start of October to 2015 was recorded, and the record high was $504 in 2015. Price again stabilized to low $600 range in 2016 as the Chinese renminbi depreciated against the US dollar. Bitcoin rose to the upper $700 during this period, and renminbi depreciated against the US dollar. Bitcoin rose to upper $700 again. In 2017, prices fell 30% in a week, reaching a multi-month low of $750 again, and prices broke above the November 2013 high of $1242 and then traded above 1290 again. That was again a good first highest of Bitcoin. Price reached its maximum in the history of Bitcoin, reached all-time high of ever $12,500 in 2017. So that was all about history of Bitcoin, how it started moving in the market, how it captured the market, how it became popular, how it fell and rise in the market, and were the values it attained during its whole history. Even in these days, Bitcoin stands strong against dollar. And if we talk about the current value of Bitcoin in dollar, so in today's date as well, it stands strong against dollar and has value of 3,857 US dollar. So really stands strong in nowadays as well and still growing. And one Bitcoin is equivalent to 3,857 US dollar. So you might have heard the people invested that time initially in the blockchain and the Bitcoin are really went into very good amount of profit, and it was having a boom at that particular time. Along with Bitcoin, there were multiple other cryptocurrencies that evolved and attained a very good value, and even sometimes they even defeated the value of Bitcoin in the market. So if we talk about Bitcoin, the first blockchain focused decentralized digital currency was Bitcoin. Uses consensus to control its creation and management rather than relying on a central authorities, that is role of mediator, held electronically in a P2P open ledger called the blockchain. That was the first ever blockchain developed. The first ever idea of blockchain. They are not printed. They are produced by people using software that solves mathematical problems. And those mathematical problems are called consensus. Those puzzles are used in order to create new blocks inside the network and as part of the award against the creation of new block. Why to use Bitcoins? It is super fast. As we all know, there is no mediator. Transactions are instantaneous if they are zero confirmation transactions, or they can take around 10 minutes in a merchant requires confirmation. They are really cheap. Bitcoin transaction fees are minimal, and in some cases they are free too. It's absolutely decentralized. Because the currency is decentralized, you own it. No central authority has control over Bitcoins. They are autonomous and free inside the network. Never worry about chargebacks. Once Bitcoin has been sent, they are gone. A person who has sent the Bitcoin cannot try to retrieve them without the recipient's consent under any circumstances. That means if you have spent your Bitcoin and transferred it to some other person, you cannot retrieve it back. You cannot claim it back because there is no central authority. You have to request the recipient of the money or Bitcoin in order to send it back to you. Otherwise, there is no option. If your Bitcoin is gone, then it is gone. It also acts as the best payment security. Transactions don't require you to give up any secret information. They use two key, public and private keys that are given at the creation of your node and your wallet. It is not inflationary. Bitcoin has been assigned a hardwired value of $21 million in its protocol itself. So any time in its lifetime, it can achieve maximum value of 21 million that can be created until it is itself changed in the protocol from from 21 million to some other value. But till date, it can grow to 21 million only. It's really private. It is like having a it's plastic wallet with no visible owner. Everyone can look inside it, but no one knows who owns it. make your own money. You can certainly buy bitcoins in the open market, but you can also mine your own if you have computing power. You can participate as a validator node and solve the problem. Proof of work can be used to solve the problem, and if you are a winner, you will be rewarded with the bitcoin by solving the problem. Now, where and how to get the bitcoins? In order to sell or buy a bitcoin, customer has to join the Bitcoin blockchain network. You can buy the Bitcoin using your wallet, your credit card, or online also. To start with, a user must install a virtual wallet onto a PC or mobile device. The wallet keeps track of your Bitcoin balance and all transactions. Bitcoin can be bought either through online payment or through any company. Once the funds are available, a buyer can place an order for a Bitcoin similar to trading stocks through various online exchanges, and then it can start participating in the blockchain network. Bitcoin can also be purchased from third parties, which sends the coin directly into your virtual wallet. Every time you transact, you will be using your wallet address in order to buy or sell Bitcoins. Bitcoin and its client. To join a Bitcoin ecosystem and start using a cryptocurrency, all the users are required to do is download an application or use a web-based application that is client. There are three kinds of clients available in order to transact with the Bitcoin: full client, web client, and lightweight client. Full client stores the complete history of Bitcoin transactions and manages the user's wallet and capable of initiating transaction directly on the Bitcoin network. That means it has full access and full role inside Bitcoin network and can manage the transaction and keep record of them. Web client. Web clients are accessed through a browser and stores the user's wallet on a server owned by a third party. They are used by exchanges primarily. So you can open a web client, do your transactions on a Bitcoin using third party user's wallet. Then comes lightweight client. This type of client stores the user's wallet but relies on third party owned servers for access to the Bitcoin transactions and network. So there are three kinds of Bitcoin: full client, web client, and lightweight client available with the help of third parties or maybe Bitcoin network to allowing you transaction over Bitcoin network. Bitcoin wallets. So as we discussed about Bitcoin wallets and Bitcoin currencies, we should know how these wallets are created and how they are stored against and for each pair. There are various Bitcoin wallets or clients available in the market. Web wallets. Web wallets are website or even online exchanges that allow storage. Example, blockchain.info, Coinbase. So these web wallets you can use online and store your Bitcoin currencies. Mobile wallets. A smartphone wallet makes it really easy to scan QR code to make quick payments via phone only. No need to go to the browser for same. Example stands Bread Wallet, Mycelium, Airbids, Greenbits, etc. Since now we are very friendly to our mobile phones, gadgets, so mobile wallets are introduced, and like Paytm and other apps, you can use QR codes of your Bitcoin and do purchase and sell over the Bitcoin network. Then comes desktop wallets. Similar to mobile wallets, they use apps installed on a personal computer like desktop or laptop, and they act as a wallet to transact on Bitcoin network. Example, Electrum, Multibit, Armory. Hardware wallets. A piece of hardware is used to store the private keys to your Bitcoins. Example, Ledger Nano and Trezor. So you are storing your private keys in a hardware wallet, and that can be used for further transactions. Then comes paper wallets. It is the most secure cold storage solution that is used for storing your private keys and can be used as a wallet for Bitcoin transactions. Example, Coindesk Bitaddress. Then multi-signature wallets. These wallets require multiple private key signatures to make a transaction. That means you need to have multiple private key signature before you initiate and sign your transactions over the Bitcoin network. Example are Carbon Wallet, Coinbase, Blocktrail, Electron, and CoinKite. More details about these wallets can be found on web. Those who are interested in reading the details of these kind of wallets, how these are developed, designed, and used for storing the Bitcoins. So this slide shows comparison between different kind of wallets. If you see here, we have web interface, mobile app, desktop client, independent wallet, privacy, security, newbie friendly. All these criteria and features can be compared again each kind of wallet available. We can have hot wallet, we can have hardware wallet, we can have again multiple type of hot wallets to store our Bitcoin or payments. So in your hot wallet, web interface are available. In some of them it is available and some it is not. Mobile app, for some of hot wallets are available. For some, it is web client, that's desktop client available. Then in all kind of wallets, you could see privacy and security is same and good because they are operating on blockchain networks. So these are example of different kinds of wallet that you can see what features they provide and what features they do not provide. So if we talk about the features and comparison of these wallets, you could see and follow the below table. Web wallet is unsafe, easy for beginners, very convenient and free of cost. While mobile wallets are unsafe, again easy, very convenient and free of cost. So using web and mobile wallets is not suggestible. Desktop wallets are safe, bit complicated for beginners, average in convenience and again free of cost. Hardware wallets are very safe. They are little complicated, and if we talk about convenience, they are not convenient and they require certain amount of cost to be spent in order to use hardware wallet, maybe 90 to 400 US dollars. Paper wallet. These are considered again very safe and really difficult for use for beginners, non-convenient and usually free. Then multi-signature are again safe, difficult to use for beginners. Convenience varies as per the uses of multi-signature wallets and is again free. So this was all about wallets. Now we will be discussing about different kind of wallets that exist in the market and provide convenience for Bitcoin transactions in our next session. Let's see what all wallets exist following these types of wallets. Jaxx Wallet. Now that we have discussed and compared various Bitcoin wallets, let's see a wallet in working called Jaxx Wallet. Jaxx Wallet is used for Bitcoins, and when you log in to use it, this is how its home screen looks like. You can create new wallet or you can restore your existing wallet using the UI. Once you press on continue, you get a next screen where you can receive bitcoins from senders, or you can also become sender and send bitcoins. And there is also a QR scanner code available that can be used for easy transactions using this wallet. In turn, this wallet will show your balance also in terms of Bitcoin and in terms of US dollar. The second section of this Jaxx wallet shows your transaction history, the number of transactions that you have done, you own the Bitcoin, and along with the details. So when you start sending your Bitcoins from Jaxx wallet and you click on the send, you have to enter the recipient address, the amount of Bitcoins you want to transfer, and then you have to click send in order to send the Bitcoin. So procedure for sending the Bitcoin, as is summarized in the last picture, using the Jaxx wallet, you have to click on the send button. In the address section, that you have to paste the Bitcoin address of the person you are willing to send the Bitcoin and the amount you want to send, and then click the blue icon for send and sending the Bitcoins. Even if you want to generate or receive Bitcoins through Jaxx wallet, you have to click on receive. You have to click on the amount that you want to generate and receive from the address. So step 4, you request your payment using your QR code, or you can give your address for the transaction, requesting the Bitcoin for that particular amount. Okay. So this is how you can send and receive Bitcoins using your Jaxx wallet. There are other similar wallets exist in the market which have similar functionality as of Jaxx wallet with some different GUI. Now the second important point comes to secure your wallet. How you are going to secure your Bitcoin wallets. There are multiple ways to secure and make your Bitcoin wallet more secure. You can encrypt the wallet in order to protect your wallet from prying eyes is to encrypt it. This makes it difficult to access your wallet but not impossible. You have to use public and private key pair in order to encrypt the wallet, and while using you have to use the decrypted version of it. You can use multisig that allows multiple parties to partially seed an address with a public key. The required number of signatures is agreed at the start when people create the address, and that is more secure as compared to normal encryption of the wallet, where you are using multiple signature that is used by multiple seeds and peoples in order to create a signed address. Third option is you take a backup of it. Backing up your wallets makes a copy of your private keys, but it's important to back up your whole wallet. You can also take it offline. Cold storage wallets store private Bitcoin offline, and they are not accessible over internet, and this also makes it secure, that is available to you only. How to buy your first Bitcoins? It is still quite difficult to acquire Bitcoins in most countries. Cryptocurrency exchanges are the easiest way to buy Bitcoins. So you can do them. You can buy your first Bitcoin using Bitstamp, a European currency market that supports several currencies including euros and US dollars via wire transfer. You can use Coinbase. a US-based Bitcoin wallet and platform where merchants and consumers can transact into Bitcoin. ZipPay. ZipPay is the fastest and easiest way to buy and sell Bitcoins in India. So if you want to purchase and sell your Bitcoins in India, you can use ZipPay. CoinSecure. CoinSecure is the most secure Bitcoin exchange to buy, sell, and accept Bitcoins over internet. So these were some sort of mechanism, some sort of options using which you can buy your first Bitcoin over internet. And all our options available are using cryptocurrency in order to exchange your Bitcoins in easiest manner. Now, how to do sell your Bitcoins? You have option of selling the Bitcoin in two manners, selling Bitcoins online or selling Bitcoins in person. How to sell Bitcoins online? There are three ways to do so. Direct trade involves a trade with another person directly over internet. Exchange trades involves an online exchange where you can trade with the exchange rather than another individual or any unknown person. So you are doing Bitcoin exchange or selling in form of exchange, trading over the internet. Peer-to-peer node or peer-to-peer trade allow Bitcoin owners to obtain discounted goods with their Bitcoin via others that want to obtain the cryptocurrency with. So they are trading in Bitcoin. You have option to trade in Bitcoin. You can buy discounted goods with your Bitcoin over internet via others that want to obtain cryptocurrency in return. These are few examples of selling Bitcoins. Online with exchanges, websites that offer this type of selling model include Coinbase and local Bitcoins in the US and BitBargain UK and Bitlicious in the UK and many other exchanges across the globe. You have option to transfer or sell Bitcoins peer-to-peer. Again, the marketplace acts as an intermediary, offering users the platform, Bitcoin wallet, and escrow for transactions. So these are some examples of selling Bitcoins online or offline. But beware of using website for transacting into Bitcoin. There are various fraudulent websites available in the market online that may cheat you and exploit your internet in order to hack your system and spoil the Bitcoin amount available in your wallet. So you need to be very careful while sending your information and transacting with online parties that simply anonymous to you. Always buy and sell Bitcoin from authorized vendors. So this screen shows various places to spend Bitcoins. One example is Bitcoin Store, where you can buy multiple items in exchange of Bitcoin, and that acts as a online marketplace that sells a variety of electronic gadgets. Then you have BitPremier, luxury Bitcoin online only marketplace where you can find anything from high performance sports cars to work of art and even real estate also. Then you got gifts, that is used to buy, receive, redeem, and send digital gift card for over 200 retailers including Amazon and Sears, Target, and GameStop. So gift is used to buy coupons or digital cards, gift cards. Now they accept Bitcoin also over other payment options. Other option available is CoinGig. That again allows you doing transaction in form of Bitcoins. That conducts it transactions solely in Bitcoins only. You can find everything from books to t-shirt to gift vouchers on CoinGig. Then you got Virgin Galactic, cheapair.com. These are other options where you can utilize your Bitcoins in order to purchase items from marketplace. You got Bitcoin commodities, travel. Bitcoin commodities helps you sell gold and silver coins, bars and sheets. As the name suggests it accepts Bitcoin payments. While travelforcoins.com acts as a middleman between you and travel sites such as Expedia. You pay in Bitcoins to Travel for Coins, who will pay for your flights using standard currency. That was all about the places where you can spend, sell, and purchase your Bitcoin. Bitcoin blockchain, transaction, and transaction script. So, before spending the Bitcoins, we should be securing them inside our Bitcoin wallet that we already learned. Now, what is Bitcoin blockchain? Transaction and transaction script that we'll be learning here in coming slides. Now that we have seen how a Bitcoin is used and spent, let's see what exactly happens when a transaction occurs. There are various Bitcoin protocols that can be used while doing transactions. Mining, research and support, payments, retail, buying, selling and storing, financial services. So these are the areas where Bitcoin's ecosystem can be used. Your mining, hardware manufacturing, mining platforms. You can use it for foundation, for profits, venture capital, security. You can use it Bitcoin protocol for payment processes, escrow services. Then you can use for retail services like merchants, directories of stores that accept Bitcoins. You can use Bitcoin's protocol for exchanges, software wallets, market makers, ATM providers, and then you can use them for financial services as well, like institutions, lenders, insurers, hedge funds, and then for products, derivatives, and investments. So these are examples of using Bitcoin protocol for various kind of applications and services. The structure of Bitcoin transaction. A transaction contains a number of fields. As you can see here in the tabular format, like it contains every Bitcoin transaction contains a version which is size of 4-bit bytes, and that specifies the rules this transaction follows. Then you got input counter in the Bitcoin transaction field that is of 1 to 9 bytes variable integer, and it includes how many inputs are included in the transaction. Then outputs. You get variables to store outputs for one or more transactions. Then you get 1 to 9 bytes variable integer type of output counter that is used to count how many outputs are included. Variable outputs is used to store one or more transaction outputs, and then log time is a Unix timestamp or block number that is used to save the timestamp of the transaction in 4 bytes. Unspent transaction output. How an unspent transaction looks. UTXO or unspent transaction output is a fundamental building block of a Bitcoin. An unspent transaction output that can be spent as an input in a new transaction. The network keeps track of all available UTXOs, currently numbering in the millions. So these are the stored coins or Bitcoins that are available in your Bitcoin network that are unspent and stored as a form of unspent transaction output. The first block contained 50 mined BTC in address A is equal to 50. The second block contained 50 mined Bitcoin in address A, a transaction sending 20 Bitcoin to address B and putting the change in address C. So in that way A was 50, your B becomes 20, and C has a value of 30 Bitcoins. The third block contained 50 mined Bitcoin in address A. A transaction sending the 20 Bitcoin from address B to address D are available. So after 3 blocks, you could see there are 4 unspent outputs. A has 2 unspent output worth rupees 50 Bitcoin each. C has a single unspent output worth rupees 30 Bitcoin, and D has a single unspent output worth rupees 20 Bitcoin. And there are 2 spent outputs also. The 50 Bitcoin generated in the first block is spent in the second block. The 20 Bitcoin output created in the second block and spent in the third block. So what do you see here? Let's review the example again to explain into more detail. The first block was A and was having 50 mined Bitcoins. The second block was containing 50 mined Bitcoin in address A, a transaction sending 20 Bitcoin to B. So this 20 amount got deducted from A50 and putting the change in address of it. So it becomes A has 50, then B got 20 Bitcoins, and the C becomes 30 in reduction of 20 Bitcoins. The third block contained 50 mined Bitcoin in address A. A transaction sending the 20 Bitcoin from address B to D is used now. So your A got 50 plus 50 Bitcoins, and now C was 30 again, and D got 20 Bitcoin transferred from B. So these are the values in this third block. Note that unspent outputs don't merge together. The two unspent 50 Bitcoin outputs at address A are separate and will remain separate at least until they are spent in a transaction. So each unspent transactions are stored separately and should not be merged together during the transaction. Bitcoin transactions input and outputs. Firstly, 4 axiomatic truth about transactions. Any Bitcoin amount that we send is always sent to an address. You need to have recipient address in order to send any Bitcoin. Any Bitcoin amount we received is logged to the receiving address and should not be used, which is usually associated with our wallet. So the amount of Bitcoin we are sending to other party will be logged from our wallet until it is successfully sent to the recipient. Anytime we spend Bitcoin, the amount we spend will always come from the funds previously received and currently present in our wallet. Address receive Bitcoin, but they do not send Bitcoin. Bitcoin is sent from a wallet. So that are 4 thumb rules or truths about transactions occurring for Bitcoin transactions. So this block of code shows Bitcoin transaction example. In the block, you got 3 blocks. The first block has hash of the transaction, then version of it and other details. You got in block section and out block section also into the transaction example. Transaction format version is currently at version 1. If you could see from the figure, in counter is the number of input counts that are available to this transaction, and output counter is out counter, that is number of output amounts. You could see here the output amount and input amount are defined as discussed. Transaction log time should be 0 or in the past for the transaction to be valid and included in a block. Then size of the transaction in bytes. So these are the information that are present as in the header of the blockchain transaction example. Bitcoin transaction input and outputs. So the amount that goes into our wallet are not jumbled like the coins in a physical wallet. These amounts received don't mix but remain separate and distinct as the exact amounts received by the wallet. Here's an illustration. Just see an example. You create a brand new wallet and in time it receives three amount of 0.01, 0.2 and 3 bitcoins as follow. You will send 3 bitcoin to an address associated with the wallet and two payments are made to another address by Alice. If you see in the figure, two people send amount to addresses held by a Bitcoin wallet. And the wallet balance for this wallet was initially 3.21 Bitcoin, adding 0.01, 0.2 and 3 Bitcoin in your wallet. Now, these all amounts came from three different resources from Alice, then Alice and you. Now, the wallet reports a balance of 3.21 by summing up the amount. Yet, if you were to virtually speak inside the wallet, you would see not 321 million Satoshi, but three distinct amount grouped together by their originating transactions. So by this, we can conclude that each amount added to the wallet are kept separately. The received amount, bitcoins, don't mix but remain separated as the exact amount sent to the wallet. The three amount in the example above are called the outputs of their originated transactions, and Bitcoin wallet always keep outputs separate and distinct. This should be clear by now. We should not be summing up the amount of currency or Bitcoin received, and we'll be continuing from this point here now. Bitcoin ecosystem that we already discussed contains various areas and applications that you can utilize your Bitcoin or blockchain. We discuss about Bitcoin transaction header, what values and what fields it has. Then we saw what unspent transaction output is. We discussed it is unspent transaction output. It's a fundamental building block of a Bitcoin. Any Bitcoin when created, it is stored as a UTXO and it is called unspent transaction output. So any money, any Bitcoin in your wallet, it is called UTXO. Then we discussed about Bitcoin transaction inputs and outputs, how a transaction block looks, and how money or Bitcoins are summed up or stored inside the Bitcoin wallet. These are never summed up. The whole money is kept individually and can be utilized depending on the requirement. The whole value is summed and displayed in your Bitcoin wallet, but these are stored separately always. Transaction inputs. Transaction inputs are pointers to UTXO. They point to UTXO by reference to the transaction hash and sequence number. Until now, we understand what are hash. I will try to elaborate it more using a demo and example. So, hashes are, as discussed, are the mechanism using which you can create your strings encrypted format, and that are, when hashed, create a unique value that changes when your input string changes. So hash of any given string is always unique and can never be generated using any difference inside the string. I will show you how you can test and generate hash. You can go to any online website and start. I will just take an example of this example website where you can go and generate hashes and play with it according to your learning and as per your interest in this topic. You can give any data in this comment box or text box. Say hello. So if you see here, even if it was empty, it was having a hash value. So empty string also has a hash value and is always of a fixed length. Here in this demo, we are using SHA-256 hash. So SHA-256 is always considered a very strong hashing mechanism that is almost impossible to hack and translate. So if you see, hello generates a unique hash string. And if we try to change it by a dot even, the whole hash changes. So this way, hashes always remain unique and you can always use them to preserve the validity or authenticity and integrity of your data blocks. So this was an example of hash. Let's move to the parent topic again. So your transaction inputs are pointers to UTXO. UTXO we know, unspent transaction outputs. They point to UXO by reference to the transaction hash and sequence number. To sell or spend UTXO, our transaction input also includes unlocking scripts that satisfy the spending conditions set by the UTXO. Every transaction input has the following field. It has transaction hash pointed to the transaction containing the UTXO to be spent. Then it could be of 32 byte size. Then output index, the index number of the UTXO to be spent. First one is always 0. and its size is 4 bytes. Then unlocking script size. Unlocking script size length is in bytes to follow. It can vary from 1 to 9 bytes. Then unlocking script. A script that fulfills the condition of the UTXO locking script and it is of again variable size. Then sequence number. Currently disabled transaction replacement feature set to hexadecimal value 0xFFFFFFF. And this is again of size 4 bytes. So these all fields constitutes your transaction input block. What does a transaction look like? A transaction has three pieces of information. In this example, you can see it has in signed public key, out, and the amount of the Bitcoin that is being transferred. So the input is a record of which Bitcoin address was used to send the Bitcoins to the customer in the first place. Then amount is the amount of Bitcoin that A is sending to the vendor. Output is the Bitcoin's address of recipient Bob. So these three transaction fields constitute your transaction block. Each input and output field is using the address of the sender and receiver node, or you can say peers. Any transaction is signed using sender's private key and it uses the address of the receiver in order to transfer the amount to the recipient. So this whole figure depicts the same that we discussed. 2 Bitcoin is sent to the address of the customer and at in node it is signed with the key. Then output is sent to the address of the vendor, the amount 2 Bitcoin and 3 Bitcoin is again sent to the address of the customer change. Now example to show the transfer of Bitcoin. Let's say Andy has 3.21 Bitcoin in his wallet sent to him at different addresses. So these amounts were sent from Alice, me, you or Alice again. So these all have different addresses and they send the balance to Andy and constitute 3.21 Bitcoin in his wallet. The received amount remains separated as exact amount sent to the wallet, if you can see here in the figure, and that is called transaction output. Spending consumes UTXOs and creates new ones. You could see from the figure before balance of node 1 or you can say the sender was 3.21 Bitcoin. So when he tried to sending 0.15 Bitcoin to Bob, it destroys output of amount 0.02 Bitcoin from the transaction or you can say UTXO available in his wallet and creates a new output of amount 0.05 Bitcoin inside the wallet of the sender node. So whenever a transaction is initiated, it looks the nearest value available in the wallet and it deducts the money from that portion only, from that address only for spending. The above scenario explains the 0.2 value was nearer to the 0.15 Bitcoin required to send to the Bob and this amount was deducted from this particular address only and leaves 0.05 balance after the spend. So 0.15 Bitcoin will be sent to Bob's address and will reside in his wallet as an output waiting eventually to be spent. The 0.05 Bitcoin is called change and will be sent back to your wallet. So you see the whole block, the whole address amount was translated and transferred to the Bob and this amount, the change, the remaining portion was returned back to the wallet as new address. Transaction as double entry bookkeeping. With the previous example, it is clear that the transaction in Bitcoin is a double entry bookkeeping. How? Let's see in the given diagram. This is a specimen of a double entry bookkeeping. You got inputs, you got outputs. So you have entry for both in form of bookkeeping. You got 4 inputs, input 1, 2, 3, 4, and each has different value of 0.10 Bitcoin, 0.20 Bitcoin, 1.10 Bitcoin, and 0.15 Bitcoin respectively. Then your output entries are 3, output 1, 2, and 3, and these have again different values of 0.10 Bitcoin, 0.20, 0.20 Bitcoin again. So when we sum up the total inputs and outputs, we come across total inputs of 0.55 Bitcoins and total outputs of 0.50 Bitcoins. So when we calculate the difference, it is 0.05 Bitcoin and this is implied as transaction fees. So if you see, the amount of transaction input can never be equal to the transaction output because our difference is applied, that is called transaction fees for completing the transaction. That is why it is called double entry bookkeeping because it stores both the entries of input and output blocks and do all the calculations for transaction fees. Bitcoin transaction lifecycle. How Bitcoin transaction lifecycle starts and flows till the end, that can be depicted from the given figure. We start here. Rob opens his Bitcoin wallet, scans copy Laura's address in order to send the money. What Bob is doing, Bob's quest to send 0.3 Bitcoin to his friend Laura is an example of this whole Bitcoin lifecycle. He's trying to transfer 0.3 Bitcoin to his friend. He opens his wallet, scans the address of Laura in order to send the 0.3 Bitcoin, fills the amount and the fees of transaction, and then sends over the network. Then it passes through user or machines, and the wallet signs a transaction using Rob's private key. This transaction before sending over the network is signed using Rob's private key, and it is all time spent 10 seconds around until now. The transaction is propagated and validated by the network nodes. Miners or validators include the transaction in the next block to be mined. So this transaction is now part of group of transactions of a new block that is being mined by the validator nodes. We all know that mining is the computational process of calculation of certain hashes and take time. So when mining is done, the miners who solve the proof of work propagates a new block to the network and new bitcoins are created in result. The nodes then verify the result and propagate the block and add to the blockchain. When the final confirmation is done and blockchain got the new block added, Laura can see the first confirmation on his wallet and his device that the amount has been transferred successfully and received by her. New confirmations appear with each new block that is created. So every node inside the blockchain network is made aware of the new block creation, and this constitutes the whole life cycle of a transaction inside a Bitcoin transaction lifecycle. Now we'll be discussing about various transaction forms in Bitcoin. Let's see what are the various type of forms used in Bitcoin transactions. The figure depicts a common transaction form. The most common form of transaction is a simple payment from one address to another, which includes some change returned to the original owner. So this is a very basic example of transferring Bitcoin from one address to other, where input 0 from Alice signed by Alice is sent to output 0 to Bob, and then output 1 comes as change returned to the Alice. Then comes aggregating transactions. These are another common form of transaction where transaction is one that aggregates several inputs into a single output. So what happens? Multiple inputs are aggregated and formed in a form of transaction and sent to output 0 to the output peer or output node. These type of transactions are sometimes generated by wallet applications to clear up smaller amounts that were received as change for payments. Then comes distributing transaction. Transactions that distributes one input to multiple outputs represents multiple recipients. So here the sender address or sender peer can try to send amount or Bitcoin to multiple addresses in one transaction itself. So you can generate one input with multiple items to multiple recipient addresses, and this will be further distributed in multiple outputs depending on the number of different addresses available. So this type of transaction is sometimes used by commercial entities to distribute funds, such as when processing payroll payments to multiple employees. So this is a quite good example where this can be used by an organization to send salary of multiple employees inside their organization, which will have all employees have different addresses in the network. What are scripts in Bitcoin? Now that we know that transaction in Bitcoin consists of input and output, these inputs and outputs offer nothing but the scripts. Bitcoin scripting language script. All Bitcoin transactions have scripts coded into its inputs and output mechanism. Design goals are forth-like programming language, old stack-based simple programming language used, reverse polish notification. Data is pushed onto the stack and operation is performed. Composed of OP codes. Operation in Bitcoin is composed of OP codes or operation codes that help deciding the results. Example of Bitcoin scripts you can see on the screen. The script shown alongside will execute the values in the stack and will return to value to true if the equation is valid. So it has multiple steps to execute it inside the script. The scripts are written in the old stack-based programming language that is called Forth or other similar programming languages. They have syntax, they have execution pointers, execution starts from the left, that constant value 2 is pushed to the top of the stack. In the third step, this execution continues moving to the right. With each step, constant value 3 is pushed to the top of the stack. You can clearly see the data structure stack is used here in order to propagate the script execution. Then the add option specifies adding the values. Operation add pops the top two items out of the stacks are added them together, and then operator adds pushes the result 5 into the top of the stack. This is syntax of this programming language that is used to calculate the value and propagate the transactions. When the script shown alongside is executed, the result is op-true code, making the equation valid. That means the constant value 5 is pushed again to the top of the stack that was received as a result of adding 2 and 3. The operation equal pops the top two items out of the stack and compares the value 5 and 5, and if they are equal, the equal pushes true, or if they are not, it will be 0. Most common script types. Pay to public key hash, P2PKH. One of the most commonly used transaction output script. It is used to pay to a Bitcoin address. Second is pay to public key. This is the simplified form of that P2PKH. This is not commonly used in new transactions anymore because P2PKH are more secure. Pay to multisign, P2MS. Multisign outputs allow to share control of Bitcoin between several keys, and that makes them more secure, that we have already seen in previous sessions. Pay to script hash. Scripts that contain the hash of the another script called redeem script. And it is another way of common script types using transactions. Script mechanism. Transaction validation engine relies on two types of scripts to validate the transaction: lock and unlock. Unlocking script sig that signs using public key, and while plus locking script is script public key that uses duplicate hash 160 public key hash equal verify and check the signature. That is the function written and for locking and unlocking script. Unlock script sig is provided by the user to solve the encumbrance, while in locking script, lock is found in a transaction output and is the embrace that must be fulfilled to spend the output. Combining the output and input scripts. The two scripts together would form the following combination validation script: cafe signature, cafe public key output dup op hash 160, and cafe public key hash op equal op check sig. The script combined, when executed, will evaluate to true if and only if the unlocking script matches the conditions set by the locking script. So this is just an example of writing codes in your input and output scripts. When you have your own requirement, you can simply code, and obviously you should be having the knowledge to write in the code, and then you can evaluate and get the value accordingly true and false by meeting the certain condition allowed by the locking script to the unlocking script. The result will be true if the unlocking script has a valid signature from the cafe's private key that corresponds to the public key hash set as encumbrance. Now, here comes the evaluation of the script. So on this screen, you could see how steps provided in the scripts are executed and evaluated. Pointer is at the initial state saying. So signature sign off happens using the public key. Evaluation starts. Value sig is pushed to the top of the stack. Then public key is pushed and execution continues moving to the right with each step. Value public key is pushed to the top of the stack on top of the signature. And this algorithm is repeated continuously till the end of the steps. A step-by-step execution of the combined script which will prove this is a valid transaction. In the next step, dup operator duplicates the top item in the stack. The resulting value is pushed to the top of the stack again. So for the audiences, those who are not into development, this could be a bit tricky. They should know how push and pop happens from the stack and how operations are performed over the stack data structures. So the scripts are simply following the data structure instructions. They are pushing the items into the stack, doing pop and push items in order to execute the instructions written. The next item, hash 160 operator, is picked and it hashes the top item in the stack with the repmd 160 SHA-256 public key. The resulting value pub-k hash is pushed to the top of the stack now. That is received by hashing. Now the value pub-k hash from the script is pushed on top of the value pub-k hash calculated previously from the hash 160 of the pub-k. The equal verify operator compares the pub-k hash encumbering the transaction with the pub-k hash calculated from the user pub-k, that is public key, and if they match, both are removed and execution continues. The check sig operator checks that the signature matches the public key and pushes true to the top of the stack if true. So since the script alongside returns true, this transaction is valid. Otherwise, it stands invalid. So this is how any Bitcoin script works and calculates the transaction values. Nodes in Bitcoin network. So since we have discussed more about transaction inputs and output, and the scripts, we will see now what are the various nodes in Bitcoin network. In the Bitcoin network, full nodes are the enforcers of consensus rules, but not all full nodes are created equal. There are several different kinds of Bitcoin full nodes which exist in the ecosystem. Pruned selfish full nodes. A pruned node is a full node that prunes raw block and undo data by deleting it from the disk. This can be achieved to save the disk space. A selfish Bitcoin node is a node that does not upload new blocks or transactions to the other Bitcoin peers in the network. Archival selfish full nodes. An archival node is a full node that stores a complete copy of the Bitcoin blockchain data on the disk. Within this data, the archival node operator can make queries against the blockchain to find information pertaining to the particular transaction or addresses. Common Bitcoin nodes in the Bitcoin network. Network result routing node, full blockchain. If you see here, you could see reference client that contains Bitcoin core. Then you got full blockchain node. You can have a solo miner. You can have lightweight simple payment validators wallet. Then you can have pool protocol servers, mining nodes, lightweight SPV, Stratum wallets. So the network routing node contains a full blockchain database and network routing node on the Bitcoin P2P network. This reference client contains a wallet, miner, full blockchain database, and network routing code node on the Bitcoin P2P network. Solo miners. Solo miners contains a mining function with a full copy of the blockchain and the Bitcoin P2P network routing node. Lightweight SPP wallets are contains as a wallet and a network node on the Bitcoin P2P protocol without a blockchain. Then comes your pool protocol servers. Gateway routers connecting the Bitcoin P2P network to nodes running other protocols such as pool mining or Stratum nodes. Example, pool server, Stratum server. Then mining nodes containing a mining function without a blockchain with the Stratum protocol node S or the other pool P mining protocol node. So one other type of common Bitcoin nodes is lightweight SPV Stratum wallet. Again, contains a wallet and a network node on the Stratum protocol without a blockchain. So here you do not need to worry. These are just example of common Bitcoin nodes that are used in Bitcoin network, and there are many. If you're interested, you can really go through the web and read about the definition and example of these kind of nodes that are used in Bitcoin network. So let's discuss about economics of Bitcoin. Below pointers constitutes about economics of Bitcoin and tells more in detail. That is, Bitcoins are stamped after creation of the each block at a settled and reducing rate. That means every Bitcoin creation of new block is stamped, settled, and every time they are created, they are in reducing rate as compared to the previous one. For each 2.1 lakh blocks, or roughly every 4 years, the money issuance rate is diminished by half in the Bitcoin system. It means every year Bitcoin generation is decreasing, and the next year it becomes every next year it becomes half of the rate of the block generation in Bitcoin network. So we could say that if 2.1 lakh blocks are generated or 4 years are spent, the rate of issuance of money inside Bitcoin will be diminished to half. For the first 4 years of Bitcoin operation of the system, each block contains 50 new Bitcoins. So that was the initial phase of Bitcoin. When it started flowing officially from year 2009, the first chain of blocks was containing 50 Bitcoins. And during the next 4 years also, starting 4 years of Bitcoin operations, each blockchain consisting only 50 new Bitcoins. The rate of new coins diminishes exponentially, more than 64, halving until block 13 lakh 13,230,000 mined roughly in year 2140 when it achieves the base cash unit of 1 Satoshi. Finally, after near around 13.44 million blocks in approximately 2140 years, almost Satoshis or almost 21 million Bitcoins will be issued. What this line means? This line means that the 21 million Bitcoins are already hardwired inside the Bitcoin protocol, and Bitcoin generation could only happen till this amount only. When Bitcoin generation has reached 21 million Bitcoins, the block generation will automatically stop until someone expands the limit in the protocol itself. Therefore, blocks will contain no new Bitcoins and miners will be rewarded solely through the transaction fees once blockchain generation is completed and reached 21 million Bitcoins. Bitcoin economy, supply of Bitcoin. How supply of Bitcoin happens inside the Bitcoin economy. The limited and decreasing supply and issuing rate makes a settled financial supply that opposes expansion. This is really needed. When you are designing a financial network or cryptocurrency network, you need to keep in mind that it should not cause inflation. That's why Bitcoin makers also kept in mind and put a limit, and they kept the rate of Bitcoin generation in control by limiting it and decreasing supply and ensuring rate of financial supply opposed to the expansion. Different to a fiat money which can be imprinted in unending numbers by a national bank, Bitcoin can never be swelled by printing. Blocks need to be generated by miners against the effort they are putting solving puzzles inside the network in order to create new blocks. So every time the effort invested will be limited and the restrictions put inside the Bitcoin network will keep the blocks in control and they'll never cause inflation inside the network and cannot fill the network again like fiat money or cash. The adjacent graph depicts the supply of Bitcoin currency over time based on a geometrically decreasing issuance rate. You can see here over coming years, like starting from 1st Jan 2010 till 1st Jan 2030, Bitcoin generation remains constant. Starting for 20 lakhs of Bitcoins created, it is slowly going towards 2 crore Bitcoins in the network. And that remains the highest limit of Bitcoin generation inside the blockchain Bitcoin network. Now let's discuss about Bitcoin mining. How Bitcoin mining can happen and what are the factors involved mining new blocks inside the Bitcoin. So how do we create new Bitcoins inside Bitcoin network? Bitcoin mining is a process of adding transaction records to Bitcoin's public ledger of past transactions or blockchain. This ledger of past transaction is called the blockchains. It is chains of blocks, the blockchain server to confirm transaction to the rest of the network as having taken place. This means whenever a new block is created as part of the mining process, where there are certain validators or miners participating in the network in order to solve problem and group transaction into new blocks. In order to submit their block successfully inside the existing blockchain network, they have to solve a problem called proof of work provided through proof of work they need to solve, they need to win, and winner node will be getting a chance to create new block inside the blockchain system. Once the new block is created, it is published to all other nodes in order to let everyone know that a new block has been ingested inside the blockchain network so that everyone need to update their ledgers maintaining locally. Types of Bitcoin mining. There are various ways in which you can mine your Bitcoins. They can be divided majorly into solo mining and pooled mining. In solo mining, miners endeavors to produce new blocks all alone, with the returns from the reward and transaction expenses going altogether to himself, enabling miners to receive extensive payment with a high variance, longer time between payments. This ensures. This means every miner works alone in order to produce new blocks, and in return, they are getting hugely rewarded. The transaction expenses going altogether to himself, he manages, and the reward in return he receives, he owned by himself only. So, enabling miners to receive extensive payments with a higher variance is again giving longer time between payments in order to achieve and collect Bitcoin from the network. Against to this, polo mining, miners pools against assets with different mine workers to discover block all the more regularly with the return being shared among the pool miners in rough correlation to the measure of hashing power they each contributed. That means, apart from working alone, the pooled miner system gives a group of miners that work in a pool of assets and they work toward creation of new blocks and awarded equally as per their effort by in solving the new problems towards creation of new blocks. And that correlation of paying them can be measured in the terms of hashing power they each contributed towards new block creation. Pooled mining also enables the miners to receive little payment with a lower change. That means, and this duration of payment is comparatively shorter than the solo mining system. So this is more beneficial system where pooled miners work together along creation of new blocks and in turn they get rewarded on frequent basis than solo mining process. Let's first understand the working of solo miners. Mining and consensus. Bitcoin consensus algorithm allows for the creation of new bitcoins by the process of mining, and this process involves majorly four steps to complete the block creation. Step number 1, autonomous check of every transaction. Every transaction submitted by the nodes is autonomously checked and verified against the standards provided in the algorithm. Then, second, proof of work algorithm is used in order to validate the and transactions and then compete against each other in order to become winner and submit their transaction of blocks. Then third step is confirmation. Once once the node is winner, they give confirmation about the new block creation against the all network nodes available, and they publish it. And fourth is independent aggregation of nodes and publish along whole network in order to update the ledgers and increasing the blockchain network. Step number 1. How autonomous verification of transaction happens. Autonomous check of every transaction by each full node in light of an extensive rundown of criteria. Independent aggregation of those transactions into new blocks by mining nodes combined with exhibited calculation through a proof of work algorithm happens, and then independent confirmation of new blocks by each node and get together into a chain. Fourth step includes independent selection by every node of the chain with the most cumulative computation demonstrated through proof of work. And how this independent verification of transaction happens. Let's say Andy initiates a transaction of 5 Bitcoin to Bob in a Bitcoin network. So every node inside the network passes this transaction to each other. Each node has their peer nodes connected, and when any node start sending the transaction to other node, they start propagating the information inside the network. And each node is responsible for independent verification of these transactions and validating the integrity of these by using the public key of the sender node. Independent verification of transactions. Let's discuss more detail. Before sending transaction to its neighbor, each Bitcoin node that gets the transaction will at first confirm the transaction. This ensures that only valid transactions are proliferated across the system, while invalid transactions are rejected off at the first node which receives them. Since each independent nodes are responsible for validation of transaction and they are validating very efficiently so that none of the bad transaction or invalid transaction should propagate inside the network. So any invalid transaction will itself get cancelled and rejected at the first node itself. So there will be no chance of propagating wrong information or invalid transaction inside the network. Checklist of transactions. Every node confirms each transaction against a long agenda of criteria. So while the validators or nodes perform the validation of independent transactions, they follow a checklist or set of rules in order to validate the transactions. Transactions punctuation and information stack has to be in sync with the Bitcoin protocol. That means all the instruction and transaction information should be in sync inside the transaction block. Neither list of inputs or outputs are empty. Inputs and outputs we have already discussed in last session. These are transaction inputs and outputs which provides the available amount of Bitcoin inside the personal wallet and amount of Bitcoins transferred to the other nodes as part of the transaction. So both the list or none of the list should not be empty. The transaction sizes in bytes is less than max block size. That means the transaction size which is calculated in bytes should always be less than the maximum block size of the Bitcoin network. It should not increase at any point in time the size of maximum block size. When we talk about maximum block size, is the size of the maximum the block available inside the Bitcoin network that has the more number of transactions. Each output value and also the aggregate must be inside the permitted scope of qualities, that is under 20 million coins more than 0. That means any output value and the aggregate of it that is generating new bitcoins should be limited under should not go beyond 21 million coin and should be obviously more than 0 or the available bitcoins inside the existing Bitcoin network. A matching transaction in the pool or in a block in the main branch must exist. For each input, if the referenced output exists in any other transaction in the pool, the transaction must be rejected. That means if any input, for each input, if the output is already existing, that means the transaction has been already validated and done. Then the similar transaction should always be rejected. For each input, the referenced output must exist and cannot already be spent. This means the referenced output against any input that is supplied must be existing and should not be spent already. That means it is similar to the above point, the transaction should not be done already. Reject if the sum of the input values is less than the sum of output values. As we discussed already in last session, there is always a transaction fees involved for each transaction. That means your input value should always be lesser than the output value, allowing some space for transaction fees during the validation of transaction and committing to them in the new block. Combination of verified transactions. Autonomous check of every transaction by each full node in light of an extensive rundown of criteria. Independent aggregation of those transactions into new blocks by mining nodes combined with exhibited calculation through a proof of work algorithm. Independent confirmation of the new blocks by each node and get together into a chain, and then independent selection by each node of the chain with the most cumulative computation demonstrated through proof of network. So now, during these 4 steps, we already discussed the validation part. Now, how the combination of verified transaction happens after validation. Combining transaction into blocks. We have already discussed and understood that during the mining process, not a single transaction is used to create the new blocks. Validators or miners look for the available transaction in the network and they group the available transaction to form a new block. So by doing it, they follow certain rules and process in order to write the new blocks by grouping the available transactions in a group. And now we are discussing about Bitcoin mining. So this is second session in this Bitcoin mining series. Till now, in our last session, we already discussed about mining process and how during the mining process, individual blocks of transactions are validated by each node and propagated towards the network. Before propagating to the network, the validator nodes group the transactions into the blocks, and how these validated transactions group together, we will be learning and discussing in this session. Combining transaction into blocks. Let's see how it happens. By autonomously confirming each transaction as it is received and before transmitting it, each node maintains a pool of valid, however unconfirmed transactions known as transaction pool, memory pool, or mempool. Why we call them unconfirmed transaction? Because these transactions are still not confirmed. They are just validated against the sender and receiver's addresses by using their public keys and other mechanisms. So when a validator or miner comes to form a new block, they start looking for pending transactions. They group together, they create a new block that will be possible candidate block inside the network, and this is called transaction pool, from where they pick all the pending transactions. Transactions reaches mining nodes, it has collected, validates, and relays new transaction just like the other nodes. So that means that any transaction that reaches the miners that has collected it and it validates, and then after validation it relays the new transaction just like the other nodes are doing. That means it starts propagating it to other nodes inside the network. Unlike other nodes, the miner node will then aggregate these transactions into a candidate block. And this way, a new block formation will start inside the Bitcoin network. Similar way, there will be other miners as well that will be competing for creation of a new block by grouping the pending transactions. For an example, you can see from the diagram that in the network shown above, the miner nodes in orange color aggregate the transaction in a candidate blocks. They are responsible for grouping the pending transactions and formation of new blocks. Here we will try to understand through an example. Let's say Andy is a miner. A mining code maintains a local copy of blockchain, the list of all blocks created. This will not happen with all the nodes in the network. Only miner nodes, or you can say validator nodes, will keep a whole local copy of blockchain that contains all the blocks in the network. That means when we say whole copy, they will be having the Bitcoin blockchain system starting from 2009, starting from first node. Okay. So Andy's node is listening for transaction, trying to mine a new block, and also listening for blocks discovered by other nodes. So any miner block or node, sorry, will keep listening to the all the incoming transaction, and they will also keep listening and monitoring the other blocks or other nodes that are trying to listen and form new blocks. As Andy's node is minor, it receives block say 273816 through the Bitcoin network. The arrival of the block signifies the end of the competition for the block and the beginning of the competition to create the next block. Which means when the arrival of block comes to the miner Andy, it has to now participate in the competition in order to create next block with other nodes, which are also contending in order to create a new block. And during the previous 10 minutes, while Andy's node was searching solution to block 273816, it was also collecting transaction in preparation for the next block. Which means miners work parallelly. While they are working to form a new block and register it inside the blockchain by competing with other nodes, they also do preparation for the new block for registering into the system. So by now, it has collected a few hundred transactions in the memory pool and will try to register them. Upon receiving 273816, a new block, and validating Andy's node will also check all the transactions in the memory pool and remove any that were included in the block 273816. So by this step, it allows or it ensures that none of the transaction is repeated in the next block that is already covered inside the existing block, that is, it is forming. Whatever transaction remain in the memory pool are unconfirmed and are waiting to be recorded in a new block. So once Andy's node has already collected the transactions inside a group to form a new block, these all are unconfirmed yet, and these will be registered into the new block once confirmed from proof of work or other consensus mechanism. Andy's node immediately construct a new empty block, a candidate block 273817, and this block is called a candidate block because it is not at a valid block. It is just trying to pull its block inside the blockchain network. It has to participate in consensus mechanism by doing proof of work, and once it is winner, he will be eligible for creating and registering his block, publishing it inside the whole network. After the block becomes valid only if the miner succeeds in finding a solution to the proof of work algorithm. So this way, whole mining process occurs and new block formation happens inside the network. Other nodes that were competing inside the blockchain network in order to create new block will start over again and try forming the new block by winning the competition using proof of work solution. Fabrication of a block header. Since Andy has won the competition, he needs to construct the block header after collecting all the transactions in a block. Sorry, this will happen before winning the competition because he is forming a candidate block. How fabrication of a block header happens? These are the listed fields in the table shown that will be required in order to construct a new block header. These are total 6 fields that any mining node requires in order to construct a new block's header. The first field will require a version of the block. In order to construct the new block header, the mining node need to fill in 6 fields as listed. First is version, second is previous block's hash, a reference to the hash of the previous parent block in the chain, then Merkle root. We have already discussed how Merkle roots are calculated by repeatedly hashing the available transactions. A hash of the root of the Merkle tree of this block's transaction. Then timestamp, the approximate creation of block's time, seconds from Unix epoch. It will be in seconds. Fifth will be difficulty target, the proof of work algorithm difficulty target for this block in order to participate in the consensus mechanism. Then last will be nonce, a counter used for proof of algorithm in order to win the consensus mechanism and competition. Mining. So when Andy has already decided the block's structure and formed a candidate block, he will start mining process. Since Andy started mining in the block, once his node has all the fields filled in the block header in the blockchain, he will follow the below process. With all the other fields filled, the block header is now finalized and the process of mining can begin. The ultimate goal of Andy is now to find a none value which results in a block header and hash that is less than the difficulty target of the block. So how this works and how proof of work algorithm happens, we have already discussed in our previous session. If you find it interesting and want to learn, please refer to our first topic videos, that is cryptocurrency and Bitcoin. Now, once the mining hub should test billions or trillions of nonce streams before a nonce is found that fulfills the prerequisites. Miners are participating, like Andy's node will participate in proof of work competition, and they will need to find a solution for the given problem, and the resulting nonce will be used to fulfill the prerequisite condition. Since an approved piece has been developed by Andy's hub, it is ideal opportunity for Andy's equipment mining apparatus to mine the square to discover an answer for the verification of working calculation that makes the square legitimate. So, presently to approve the piece as per the confirmation of work calculation, Andy's mining hub needs to achieve the trouble target. How about we perceive how the trouble is spoken to? Let's see. Portrayal of difficulty. The block contains the trouble focus in a documentation called difficulty bits or just bits. Let's say a block has 0x1903A30C as the difficulty bits. The notation expresses the difficulty target as a coefficient exponent format with the first two hexadecimal digits for the exponent and the next 6 hex digit as coefficient. In turn, this becomes, using formula as below, the difficulty target from the illustration is target is equal to coefficient of 2 to the power 8 and exponent minus 3. So this whole formula can be written in the shown format. Successful mining. So we have seen that Andy's mining node has worked hard to reach the difficulty target using all previous mechanisms. So let's see, once it is a winner, what happens next. Successfully mining the blocks. As we saw earlier, Andy's node has created a candidate block and prepared it for mining. Andy has several hardware mining devices with SIC where the hundreds of thousands of integrated circuits run the SHA-256 encryption algorithm in parallel at unbelievable speeds in order to win the proof of work. The mining code running on Andy's desktop transmits the block header to his mining hardware, which starts testing trillions of nonces per second. Almost 11 minutes after starting to mine block, one of the hardware mining machine finds a solution and sends it back to the mining node. That means the solution of the problem assigned to the miners. Immediately, Andy's mining code transmits the block to all its peers, and this is part of the publishing of the new successful added block inside the whole network. In this way, all peers inside the networks are aware of the new block and they start registering the new information and new block inside the blockchain and inside their ledgers. They receive, validate, and then propagate the new block as per the block ripples out across the whole network. And this way, a new created block successfully mined and introduced inside the Bitcoin network. In short, you can say a new Bitcoin is generated. Now, let's see how third step happens. Independent confirmation of each block. Validation of new block or confirmation of new block. In Bitcoin consensus process, every new block is validated by every node of the network. That means every node has the responsibility for validating the new node just created. This makes sure that only valid blocks are propagated to the network and not the bad blocks. Node validates the block by verifying it against a long list of criteria that must all be met. The list may include the block structure is syntactically valid, the block header hash is less than the target difficulty, that means the solution provided by the miner node is really correct, and enforces this way the proof of work was genuinely solved by the winner block. The block timestamp is less than 2 hours in the future, allowing for time errors. The block size is within acceptable limits, that it is not crossing for Bitcoin 21 million blocks or Bitcoins. The first transaction, and only the first, is a coin-based generation transaction, and all the transactions within the blocks are valid using the transaction list discussed in independent verification of transactions that we already discussed in previous slide. Just to show you a glimpse, this was the list of followed by the nodes during the independent validation of transactions. Now the fourth step comes during the mining process. Independent aggregation of the block in chain. The main chain. The chain of blocks with the most cumulative difficulty associated with it. Under most conditions, this is likewise the chain with the most blocks in it unless there are two equivalent length chains and one has more confirmation of work. When a new block is received, a node will try to slot it into the existing blockchain. The node will also look at the block's previous block hash field, which is in reference to the new block's parent. That means this is an important feature of any new block or any blockchain in order to maintain the integrity of the blockchain. Every newly block added should be having the correct hash of its previous or parent block to which it is getting added. So this will be the main part of validation while adding any new block to the existing blockchain or during aggregation process. Then the node will attempt to find that parent in the existing blockchain and which will be identified by the hash of the previous block ID. Most of the time, the parent will be the tip of the main chain, meaning this new block extends the main chain. Why they are saying this? Because there could be side chains also available, which a new block may refer to. Orphan blocks. If a valid block is received and no parent found in the existing chain, that block is considered as orphan. Orphan blocks are saved in the orphan block pool where they will stay until their parent is received. This can also happen. Sometimes a previous block marked in the newly created block may be still in confirmation process and yet to be received. So in this scenario, the child or block or candidate block has already arrived for the confirmation to the existing blockchain, and during this it will not find its parent block because it is already in process of creation. Considering this, the valid blocks will be parked in orphan block pool. And when any new block arrives, the hash ID of that block is validated, and if found as previous block ID of the orphan blocks, then they will be added along with their parent blocks chain. Once the parent is received and linked into the existing chain, the orphan can be pulled out of the orphan pool and linked to the parent, making it part of the chain. Orphan blocks usually occur when two blocks that were mined within a short time of each other are received in reverse order, that is child received before the parent, and that we have already explained. So it is very simple to understand how orphan blocks are created and how they are again put into the mainstream when their parent block arrived. Now, how bitcoins are assembled in the longest chain. By choosing the greatest difficulty chain, all nodes in the long run accomplish organized wide consensus. Brief errors between chains are settled in the long run as more proof of work is included, broadening one of the conceivable chains. Mining nodes vote with their mining power by picking which chain to extend out by mining the next block. So it's up to miners to decide which chain they need to follow. When they mine another block and expand the chain, the new block itself speaks to their vote. So till now, we have discussed about whole mining process and how the blocks are selected and added to the existing blockchain. So let's see what are the difficulties in solo mining. So we have seen how solo mining of Bitcoin works in our last session videos. So however, solo mining is becoming difficult. Let's find out why. Mining and the hashing race. Bitcoin mining is also a great degree aggressive industry. The hashing power has expanded exponentially each year of Bitcoin's presence. The computing power has already increased at very high level and our computers, next gen computers are already capable of doing huge amount of transactions as compared to the previous generations. The competition between miners and the growth of Bitcoin has resulted in an exponential increase in the hashing power, total hashes per second across the network. The acquaintance of SIC mining lead with the another Goliath jump in mining power. By setting the SHA-256 work straightforwardly on silicon chips, particular with the end of goal of mining. So in overall, we see that our computer has become strong as per the requirement needed by the blockchain network mining and use even by setting SHA-256 work straightforwardly on silicon chips and they help in mining of the new blocks easily as compared to the previous generations. If we refer to the picture in the slide, then it shows the hash rate. The estimated number of hashes per second that can be depicted from the graph. Trillions of hashes per second are happening per second, and the Bitcoin network is performing it very efficiently. If you can see, it was like 1 lakh in the starting and then it has reached 6 lakh hashes per second in last few years, increasing the computing power or hashing power very efficiently or you can say exponentially. Difficulty rises with the hashing power of the miners. As the amount of hashing power applied to mining Bitcoin has exploded, the difficulty has risen to match. Total hashing power in giga hashes per second over 2 years graph you could see on the slide against the estimated number of tera hashes per second, trillions of hashes per second. You can see the blockchain network is performing. You can already see our blockchain is already performing trillions of hashes per second. And that has really exploded the block mining inside the blockchain network. As compared to previous, many blocks means more number of blocks are generated and exploding the whole blockchain network. And with this, we expect the block Bitcoin network to be exhausted soon. Mining by pool of miners. That means we'll be discussing about the second type of mining that was pooled mining, where pool of assets were performing the mining of new blocks. How it happens? Since solo mining has become impossible with the increasing difficulty in the Bitcoin network, so there came a concept of pool mining in order to increase the computing power of the mining nodes. So miners have started mining in the pools in order to increase the efficiency and reduce the computation time in order to participate in the consensus process. This slide depicts the process of mining by pool members. Mining pools coordinate many hundred or thousand of miners over specialized pool mining protocols. The pool server will periodically make payments to the miners' Bitcoin addresses once their share of the reward has reached a certain threshold. That means miners in the pool are not awarded for each block creation. Once a certain amount is aggregated, then they are paid in one go. Successful blocks pay the rewards to a pool Bitcoin address rather than individual miners, which means rather than paying individually to all the miners, Bitcoin miners pool is paid against the awarded blocks. The individual miners configure their mining equipment to connect to a pool server after creating the account for pool, and this way they become the member of that particular pool. Their mining hardware remains connected to the pool server while mining and synchronizing their effort with the other miners. So here we can clearly see many members or many miners are collectively working in a pool in order to find a solution to the given proof of work problem. The pool miners share the effort to mine a block and then share in the rewards. Whatever rewards are provided, it is fairly shared with among the miners contributing to the pool. Pooled mining. Difficulty of target. The mining pool sets a lower difficulty target for earning a share, typically more than 1000 times easier than the Bitcoin's network difficulty, so as all the solo miners are able to mine and earn Bitcoins. When someone in the pool successfully mines a block, the reward is earned by the pool and then shared with the miners in proportion to the number of shares they contributed to the effort, which is quite fair. The miners that are working good and generating the results will get paid more. Now, how does a mining pool measure the individual contribution so as to fairly distribute the rewards? What is the process and what algorithm or logic used behind this? So that none of the underworking nodes should cheat the system or can cheat the system. The answer is to use Bitcoin's proof of algorithm to measure each pool miner's contribution. Here again used same consensus mechanism in order to ensure the efficiency and calculate the contribution of any miner in the pool, but set as lower difficulty so that even the smallest pool miners win a share frequently enough to make it worthwhile to contribute in the pool. If some nodes are not awarded against their efforts, there are chances of losing them from the miners pool. Therefore, complexity of the problems are kept comparatively simple as compared to the solo mining process, so that every contributor in a block in a pool should be awarded and get fair chance of winning. Pool mining types. There are several types of mining pool payment payout system. The different payout systems are summarized below. Pay per share. The pay per share approach is to offer an instant flat payout for each share that is sold. The payout is offered from pool's existing balance and can therefore be withdrawn immediately without waiting for a block to be solved or confirmed. The possibility of cheating the miners by the pool operator and by timing attack is thus completely eliminated. The method results in the least possible variance for miners while transferring all risk to the pool operators. That means losing will not affect the contributors. The resulting possibility of for the server is offset by setting a payout lower than the full expected value. So this is how pay per share mechanism works for payout in the pool systems. There are several types of payouts, out of which one is the second is pay per last n shares (PPLNS). The first one we discussed was pay per share, and this is enhanced version of the pay per share mechanism. PPLNS has a higher payout. This is for people trying to mine as fast as possible. That means the nodes that recorded maximum number of blocks or more number of blocks in last n shares will be rewarded more as compared to the less contributing nodes. PPLNS will give you wide fluctuations in your 24-hour payout, but for hardcore miners, the law of large numbers state you will earn more this way. So this was all about mining inside Bitcoins, where we learned about during the whole session about mining process, their factors, their contributors, what are the factors impacting the mining, how integration, verification, validation of initial transactions, individual transaction by individual nodes happens, what is the type of mining, and what topics or how candidate blocks and confirmed blocks are created, what orphan blocks are, and how they are again collaborated into the Bitcoin network. So this was whole Bitcoin mining process that we discussed theoretically here. So now we will be seeing how practically Bitcoins can be generated, can be used to create it from online websites available, and how can we become a miner of Bitcoins through using these sites. So if you see my screen, there's an assignment that will ask you to set up Bitcoin miner on your personal computer if you're using Windows from nicehash.com. And the second, you can, if you have other OS including Windows as well, you can use bitminer.com that can help you to download the Bitminer client and create Bitcoins on your computer and start Bitcoin mining. So let's see how Bitcoin mining can start by registering and downloading the software from nicehash.com. I will copy the URL nicehash.com and will try to open it on my Explorer. So first of all, I need to register on the nicehash.com in order to become miner of Bitcoin. I need to create an account. I will be using one of my account in order to become Bitcoin miner. I need to give password here. Obviously, I have to use it, so I have to agree with the terms. Let's wait until it registers this. So I have to find my verification code in order to proceed further. Okay, I have received my verification code on my email. So it is a bit long. I need to copy it again from 222. I need to open my email. If you see, I have received an email from NiceCash as part of the registration process that I will be entering here in order to complete the verification and registration process. Okay. Now I am registered successfully. I need to enter my email ID and the password I used during the registration process. Okay, so once you log in on Nice Cash, you will see your dashboard. It shows your current Bitcoin wallet balance as well. I have no active workers and I have nothing as of now. So I have to become a miner. For there are options like for buyers, for sellers, you see your dashboard, you see your workers, statistics, you can see your wallet, withdraw, deposit, both can perform if you have balance in your wallet. You can see your Bitcoin address as well here. You can see pending bit deposits, pending withdrawals. You can again go to transactions to see more about your transactions history. You can go to settings and you can enable notification. You can do setting about your buying, buy hash power, sessions, withdrawal address, and you can use APIs using API key and other options. You can go to support. So before proceeding further, I need to enable buying. Now since I have registered successfully on NiceHash, I will now download the NiceHash client for mining process. So let's go to the URL again and we'll try to open our dashboard. So login. So now here you can just see from cell portion you can download the NiceHash client on your system and become a miner. So if you have NVIDIA processor, you can download NVIDIA graphics, and if you have AMD, you can download AMD. So I will install for NVIDIA and run it. Still downloading. Okay, let's wait for until it downloads. So once you are able to download the client successfully, you need to install on Windows 10. Keep in mind that your version should be as per your graphics card, NVIDIA or AMD. So the GPU version available in your computer should be checked first before downloading the client software. Now here on my system, running security scan is taking some time, so we need to be patient and see how it goes. Few important things about if you are downloading it for NVIDIA, you have to select NVIDIA version download, and before installing the installer, you will also need to have prerequisites like Microsoft Visual C++ 2017 in order to load your main screen. So that should be available as part of your prerequisites. So luckily I have downloaded and I am able to pass through security scan. I need to install the setup now. This I will be installing for my account and only. Press install, next. It is installing NiceHash and soon I will become a Bitcoin miner on my system. So I was telling you about minimum requirements that will be needed for NiceHash miner to run on your system. First of all, it should be Windows 7 or newer 64-bit OS only. It will not run on 32-bit OS. Then if CPU mining, modern CPU with SSE2 support is required. If you are using NVIDIA GPU mining, then GPU will with compute capability is required. And if it is AMD GPU mining, then GPU with OpenCL support is required. If CPU mining is used, most up-to-date chipset driver need to be used, and you will requiring Microsoft .NET framework. You can see on the screen, it is using your Microsoft Visual C++ 2017 for 64-bit version for starting your Bitcoin miner NiceHash. If it is asked you for permission on the screen, then you have to click on yes, do not say no. It will block the activation of the product. Along with the prerequisites, I told you need a very good internet connection in order to perform the mining work. So while it is installing, let's see how we can work further with the NiceHash. So once you have downloaded, you have to configure your Bitcoin NiceHash tool or client, you can say, in order to start with the Bitcoin mining process. There are two options are available for setting your Bitcoin address. They recommend creating a NiceHash account which links your pre-assigned Bitcoin addresses and has lower fees. Okay, so I have completed installing the NiceHash on my system. I will just run NiceHash miner version 2. I do not need the video. Closed. Let's wait for the launch of the NiceHash miner. It's taking a bit time, so we will wait for it to launch. It's taking some time, so please be patient because Bitcoin miner is again a bit bulky software that require time to launch. So license agreement, you do not have any other option. You have to click on accept. Anyways, so this will not allow a robo. You have to prove yourself that you are a human. Just enter the code here 32668972. I'm entering and confirming the token. Oh, so again waiting time. Wait until the beta version of NiceHash miner loads. So if you can see on the screen while loading, it will check all your minimum requirements that I told you just in order to run NiceHash miner on your laptop or on your desktop or any server. So it will also, while setting up, it will install the required softwares and libraries inside your computer system. So you need to maintain sufficient resources in order to run Bitcoin miner on your system. So if you can see, the NiceHash miner has already been installed and is running on my laptop. You could see there's no balance, no data available. I have on hardware details, it will be showing I have one CPU. There's no GPU installed, and I can add wallet here. I can add worker. I can start mining process. I can also configure my miner tool. I can set up language. I can set up currency in which I want to exchange and save the system and compare and use my bitcoins. It will be using my location as well. Then a mining setting I can do, start mining when idle, auto start mining, GPU fan control. I can set up device name and device type here. Logging also can be done. I can exclude logging as well by unchecking the log to file. Advanced, I can use advanced options to open config file, open log files, and I can enable notifications and disable them as well. About version, this is 2.0.2.8 using. So let's back to the home screen. Okay, so in order to start with the mining, I have to first set up the wallet. I have a username, so better I give my mail ID here in order to register my wallet. Okay, in this way I have created a wallet here. Now I have to benchmark my devices and start mining. I can benchmark all. You can see when shown here, just click, and I have to do standard mining. You could see current it is evaluating my processor and it will optimizing it according to the resources available. Don't forget to check the start mining when finished option. That will start mining automatically when benchmark optimization is finished. Simultaneously, you could see your dashboard. It should be having a wallet that is already created inside the. Oh, so I need to log in. If you see here on console, cryptocurrency is running. It has created already a new block. The mining has already started as part of the mining process. You see, this mining process is happening and the icon has changed to orange. If you see here, a new block has been mined. You can this all logs will be recorded in the logs that we are logging on. If you could see mining coin, this Kryptonite V8 is starting 1x thread, no affinities, then no affinities, switch to assembler version of this. All details are logged here on your console while new mining process is running inside your laptop or computer. This way, a new block is generated and detected inside the network. Mining process is still not complete, it is running. During the whole process, you always have an option to stop the mining process. Okay, so in order to view status online, I have to click here. If you see here, I got daily estimate earning of 0.87 something 87 bitcoins. This is not nowhere exist as compared to the US dollar. Data is coming, data is populating. You could see here I was not having any data. Now it is having some bitcoins available, earning available as part of this demo. And I should be able to log in also in order to maintain these things. Let's stop the mining process now. Okay, so let's see status online. What is the status? Since I have already logged in, it should be taking to my dashboard automatically. See, earlier I was not having any address or any worker, but now I have one worker associated. I have this much unpaid balance. I have profitability tabled here. I have got all mining status updated here as form of the mining process. So this is how I have shown you in form of demo how Bitcoin mining can be started using NiceCash.
Now in this session, we will be learning how to use bitminer.com in order to become a miner from your personal computer. From the screen, you could see already have a URL available. I will be just closing the windows from previous sessions and will directly open bitminer.com. So this is one of the option available in order to become a bit miner. In order to become bit miner, you have to log in here first. So since I have not yet registered, I should be creating an account before logging into the bitminer.com. If I try to log in here, okay, so go to the home page, click on sign up. There you need to give an ID. You can use your email ID in order to register here. Somehow this is not allowing me. Apart from OpenID, you can use other option also to log into the bitminer.com. I will be using my Google account in order to register here. I can choose a Bitcoin username and do sign up here as a new member. Okay, so it is not taking dot as part of the username. So I have created an account named Vista, and here it's showing on the dashboard, it is showing my Bitcoin balance, my Bitcoin cash, NMC name coin, all stand 0 since I have just newly created this Bitminer account. We have no unconfirmed coin or transactions. Now my email address also not confirmed. So before proceeding further, I need to confirm my Bitminer account. So in my email, activation email, I received this URL. I will be entering here in order to confirm my account. Okay, so I have confirmed here and my email address is confirmed. Now I will proceed with the account for using Bitminer in order to create and start mining the blocks. Since I have used my Google account, I will use Google ID to log in. It has allowed me successfully log into the server. So in order to run your Bitminer miner software on your laptop, you need to have at least one decent ASIC miner like the Antminer's S9 and relevant ASIC USB drivers, and you need to have latest version of Java. Make sure the reboot once installed happens, and you need to have a Bitcoin wallet as well. So before moving this, I need to check all the requirements on my system. Then since I have already created an account, I have to install the tool Bitminer client from the latest auto update option. So I will just install it here, download it here, and while it is downloading, it will run on Java. As we said, you need to have Java on your system. It is an installed Java file, and from this file I suppose it will be installing the required Bitminer software. Before that, it is asking to update my Java. So if you see, I have successfully updated my Java. Now I can proceed further. In order to install Bitminer and become miner, need to see downloads. I need to again run the downloaded Java file in order to install Bitminer. So it has started executing and it will install the required things inside the system. Wait until it installs. So my application blocked by Java security. Okay, how I need to allow now? Need to see configure Java. If you will also be facing this situation whenever you are trying to install this program, your Java may still block your installation. So you need to allow your Java, so this mining software inside your Java program by using configure Java option. So I need to go to the security tab and I need to edit the site list in order to allow the Bitminer app. Just copy the URL and enter in the exception list by clicking on add. Okay, so now our bitminer.com is allowed in the exception list of Java. So I guess I need to install again. Let's install the file again and see if it happens to be my installation file has been blocked and deleted from the system. I need to download again. I will try to install again now and hope we'll be successful this time. Okay. Yes, this time it is allowed and I am able to install the software. So let's wait until the installation completes and we are able to become miner using Bitminer. Yeah, so we have now successfully installed Bitminer client and you can see it is started running. I may need, you can see here when I start the engine, it will start by taking my credentials that I used while creation of my Bitminer account. I can give worker name, say worker1 and put proceed. So it will now check my user to log into Bitminer account. You can see the logs working here. Bitminer worker difficulty is now 4096 connected to bitminer.com and Bitminer network difficulty is now this one. So now engine has started working and I have become a miner now. The meter is on. So this way you can start creating your Bitminer coins, and if I refresh this page I should be able to see changes here as well. The above top this digit, the THPS, this shows your computational power as miner. Do not see anything happening here. Let's see. I have to start the engine. Okay. So as of now it is working, but since we do not have sufficient balance, our Bitcoin generation is 0. Okay. We can go to the website. Once we have coins, we can use send Bitcoin options. We can send to Bitcoin address. We can enter the amount similar to our nice hash, and we can again try to send the Bitcoins to any other peer. Same way, we can again receive Bitcoins. We can send BCH Bitcoin Cash also here using send Bitcoin. We can give our address to any Bitcoin peer in order to send Bitcoin or receive Bitcoin to our account. We can also see transaction history by going here. So this shows I have no transaction history in the account, and this is all how you can use and utilize your bitminer.com to become a Bitcoin miner. So this was all about 2 exercises that we discussed and become a Bitcoin miner using NiceCash and bitminer.com. So let's see what Ethereum is and how it is derived. If we talk about history, Ethereum was conceptualized by Vitalik Buterin in November 2013. So from this we could see Ethereum is not much old. It came around after 4 years of the discovery of blockchain in form of Bitcoin, and then when it became into existence it became very strong and very popular among the existing blockchain technologies. Ethereum is a distributed open blockchain network and uses distributed ledgers in order to store the data in distributed manner. The key idea proposed was the development of a Turing-complete language that allows the development of smart contracts for blockchain and decentralized application. Bringing Ethereum into the scene was also required in order to make blockchain public and accessible among the broad range of audiences that were listening around blockchain and very keen to utilize in their business needs. But since of complex network of and complex design of blockchain network, they were not able to do so. So in this way, Ethereum aimed to enable innovations in 4 key areas: currency issuance, smart contracts, decentralized autonomous organizations, and smart property. So by introduction of Ethereum, the developers tried to make the process of currency issuance, smart contracts, DAO, and smart property easier in terms of implementation in blockchain. How? We will be learning it in coming slides during the whole session. So first of all, if you try to see how Bitcoin and Ethereum differs, both supports cryptocurrency And apart from cryptocurrency, Ethereum supports other applications as well. So let's see how much they differ among each other. So the idea came for Bitcoin was from digital money, and for Ethereum it came from word computer and word computer application needs to utilize blockchain for their functionalities. The founder of Bitcoin were Satoshi Nakamoto, and founder of Ethereum is well known, which was Vitalik Buterin and his team. Scripting language used for Bitcoin was Turing incomplete, while used for Ethereum was Turing complete, which was again an advantage over Bitcoin for Ethereum. Release date was January 2009 for Bitcoin, while for Ethereum it was July 2015. However, it was discovered in 2013, but it was officially released to public in July 2015. Coin release technique. Coin release technique for Bitcoin are early mining, and in Ethereum it is done through ICO. Average block time generation is 10 minutes approx in Bitcoin, while it is very much faster as compared to Bitcoin, that is 12 to 15 seconds only in Ethereum. Smart contracts. So while we start utilizing smart contracts in Ethereum, we should know what these are and what this term stands actually in terms of blockchain. The basic building blocks of programs written for Ethereum platform are called smart contracts. Let's understand what are smart contracts. A smart contract is a computerized transaction protocol that executes the terms of a contract, and when running on the blockchain, a smart contract becomes like a self-operating computer program that automatically executes when specific conditions are met. In short, if I explain in layman terms, a smart contract is nothing. It is all the business logics and conditions and situations that your organizations want to execute as in the blockchain as part of the blockchain transactions. In order to remove third-party network, single authority, central authority, and make blockchain to run as autonomous body in order to approve all the transaction as per the industry or organization standard criteria. So whatever the logic being utilized and what are the rules are being emphasized in your organization or in order to complete a specific transaction, that can be written in programming language in a smart contract, and that can be run easily on your blockchain network for creation of new transaction as well as new blocks. So an option contract between parties is written as a code into the blockchain. The individual involved are anonymous, but the contract is written in the public ledger so that everyone can access it and use this for validation of the transaction. A trigger event like an expiration date and strike price is hit and contract executes itself according to the coded terms. So that makes smart contract automatically executable as part of the transaction initiation and validation. Regulators can use the blockchain to understand the activity in the market while maintaining the privacy of individual actor positions. There will be regulator nodes available in the blockchain that will also understand the activity in the market, and they will help maintaining the privacy of individual actor positions and participant inside the blockchain. Now let's see how smart contracts work in a permission blockchain. If you have not attended previous videos, so I will just summarize here what permission blockchain is. There are two kinds of blockchains, permission and public. In permission blockchains, every participant that is participating in the blockchain network as a node need to be aligned with some permissions, and he can act and transact within the network as per the permission granted to him only. While as compared to this, in public blockchain, all peer nodes or participating nodes are allowed to do any transaction without giving any specific permission, and they are open to do any action inside the blockchain network. Cryptocurrency used in Ethereum. Ethereum is incomplete without cryptocurrency. It was also generated as an idea in order to generate cryptocurrency along with serving other computer applications. Let's have a look at the cryptocurrency used in Ethereum. Ether. As in Bitcoin, the Bitcoin is the currency of Bitcoin network. Similarly, in Ethereum, Ether is considered as a currency for Ethereum blockchain. The Steem token of the Ethereum blockchain is called Ether in turn. It is recorded under the code ETH and exchanged on digital currency trades. It is also used to pay for transaction fees and computational services on the Ethereum network. Every time a contract is executed, Ethereum consumes token which is termed as gas to run the computations. So now in this slide, we could see there are two new terms are used. One is Ether and one is gas. So the cryptocurrency or Steem token generated in Ethereum blockchain as cryptocurrency are called Ether. The code used for them is ETH, which is used for currency exchanges and digital currency trade. So whatever the fees is included for the validators and miners inside this blockchain network is paid by using Ether in the Ethereum network. Also, whatever the amount, whenever a contract is executed, whatever the Ethereum consumes token, which is termed a gas. So, tokens that are paid and consumed as part of the Ethereum transactions, whenever the contract is executed, are called gas in order to run the computations inside the blockchain network. So this slide depicts the denomination table of Ether in comparison of other currencies. Wei, the unit Wei, is 1 Wei is equivalent to 1. The Quay baggage 1 E3 is 1000 Wei equivalent to, while M Wei is Lovelace and is equivalent to 1 e to the power 6 Wei, that is 10 lakh. Similarly, it can grow higher and can be termed as G Wei, Shannon, and Microether, Szabo, which is 1 to the power 12, and milliether, which is called Finney, that equivalent to 1 to the power 15 Wei, and at the last ether, that is equivalent to 1 to the power 18 A Wei. This way, you can calculate your ether value in terms of Wei. Ether is used to purchase gas, a crypto fuel for Ethereum. So since we already discussed, gas is used as a transaction fees for computations, and ether is used to produce and purchase this gas in order to run the transactions inside the blockchain network. So now let's understand what gas is in the Ethereum system and why it is necessary. Gas, or you can also say fuel for Ethereum computations. Gas is required to be paid for each activity performed on the Ethereum blockchain. A transaction fee is charged as some amount of Ether and is taken from the account balance of the transaction originator. That means the sender node. A fee is paid for transaction to be included by miners. If you relate it to the Bitcoin, the process of mining the blocks and paying the fees and starting the transaction is almost similar to the Bitcoin blockchain. But the tokens and the currencies used for payment fees and awards will be different here as compared to the Bitcoin. The more the fee, the higher are the chances that the transaction will be picked up by the miners for inclusion in the block. So here this line depicts the difference between the transaction generation and their picking by the miner nodes. The more amount of gas is transmitted with the transaction created will increase the chances of picking that transaction by the miners for inclusion of the block. So the more gas or fuel you transmit with the transition of new transaction, there will be more chances of them being picked for block creation. Providing too little gas will result in failed transaction. The more the gas you provide with the transaction, the more the chances will be there for a transaction to succeed and create a new block. From the figure you can see, Ether buys gas to fuel up the EVM. EVM stands for Ethereum Virtual Machine. Assessing transaction cost. Transaction cost can be estimated using the following formula for any transaction inside the Ethereum blockchain network. Total cost equal to gas used into gas price. Gas used in turn exists and called for is the total gas that is supposed to be used by a transaction during the execution of any contract. Gas price can be specified by the transaction originator as an incentive to the miners. So total cost originated will be distributed into two parts, gas used and gas prices, and the multiplication of it will be total cost of the running contract onto the blockchain network. If you could see from this slide, the gas price is equivalent to the incentive paid to the miners for completing successful transactions. What are the transactions in Ethereum? Let's see. The most notable difference between the Bitcoin and Ethereum blockchain is that Ethereum blocks contain both a transaction list and most recent state of the ledger of these transactions, while in Bitcoin it was only the transaction list that was maintained by the miners. Let's have a look at the transaction and accounts in the Ethereum blockchain. Transactions. The term transaction is used in Ethereum to refer to the signed data package that contains the message to be sent from an externally owned account to another account on the blockchain. Ethereum blocks contain both a transaction list and the most recent state of the ledger of these transactions as projected in the previous slide as well. So whenever you are forming a new block, accounts are one of the main building blocks of the Ethereum blockchain. You could see this block, the first block has previous state and the next block has the previous state of this block as well and so the transaction transmitted to will be having to address and from address and the value that is being transmitted at part of the transaction. So Any transaction, any Ethereum block in this way will contain both a transaction list and most recent state of the ledger during the transactions. So if you depict from the diagram present here, you could see the previous state, the A3, the first block, the first node was having 920 ether, the second node was having 30 ether. Now when 10 ether is transmitted to A3 from BD, then it has increased A3 node's balance from 920 to 930 ether and BD node's balance from 30 to 20. So the amount of 10 ether has been transmitted from the BD block to the BD node to the A3 node, and this stores the state of and list of transaction both. Types of accounts. Accounts play a central role in Ethereum. There are two types of accounts: externally owned accounts that are called EOAs and contract accounts. Externally owned accounts, EOAs, are defined as the basic form of account. EOAs interact with and generates update on the Ethereum blockchain, while contracts are programmatically executive. The contracts are the accounts that are programmatically execute when they receive instruction in the form of a transaction from an EOA, that is externally owned accounts. Contract can push or pull funds and request these actions from other contracts, in turn calling on the code to perform dynamic actions. So if we restrict the Ethereum to only externally owned account and allow only transaction between them, we allow at an altcoin system that is less powerful than Bitcoin itself and can only be used to transfer Ether. The state of all accounts in the state of Ethereum network, which is updated with every block and which the network really needs to reach a consensus about. So the state of the accounts in the state of Ethereum network should always be updated with every block and which the network really will need in order to reach a consensus about all transactions and before confirming and completing a new block creation. So in this slide, we learned about type of account, which could be externally owned accounts and contracts. And contracts are again programmable that can execute as part of receiving instructions from the externally owned accounts. Contracts are able to push or pull funds and receive these actions from other contracts, calling the other code to perform dynamic actions. So these collaboratively work. Sometimes contracts are working together with externally owned accounts in order to fulfill the transactions, or sometimes externally owned accounts are running alone in order to generate altcoin-like system, which is less powerful than the Bitcoin. Now let's see how approval occurs in Ethereum blockchain, and our new block is created here. Validators or miners in Ethereum. We have already learned about validators or miners in Bitcoin, how they are participating in new block creation, how they are grouping the transactions, and how their new blocks are registered or became orphaned as part of the validation process. Just like in Bitcoin, transactions are approved by the miners. Anyone can take on the role of a miner and approve the block of transactions. It takes around 12 to 15 seconds approximately for a miner to approve a miner block, which is very much as compared to the time taken in Bitcoin, that was 10 minutes approx. At a theoretical level, a miner performs the following actions: listen for the transaction broadcasted on the Ethereum network and determines the transaction to be processed, similar to Bitcoin. Determine stale blocks called uncles or omners and include them in the block again. Update the account balance with the reward earned from successfully mining the block. And finally, a valid state is computed and block is finalized, which defines the result of all state transitions. Mining reward. Similar to Bitcoin, here also the validators or miners receive reward in turn for successful block creation. In order to incentivize miners for supporting the Ethereum network, a blockchain reward is granted to the lucky miners who generate the correct block in form of Ether. Currently, the block reward is set at 5 Ether for every successful block that is mined in Ethereum network. This will contribute to the inflation in the number of Ether available, and hence the value of each Ether will be updated. So this way we learn about mining reward and the format of reward provided in the Ethereum network after successfully mining of a new block. So let's learn about consensus mechanism in Ethereum. So what consensus mechanism was? If you remember about Bitcoin discussion, consensus mechanism was utilized in order to finalize the winner node inside the blockchain network while creation of a new block. So the same way here in Ethereum as well, for any distributed computing system to properly function, there needs to be a mechanism by which the entire network can come to an agreement on its state or how its token supply is divided among registered addresses on the network. So let's have a look on the consensus mechanism used in Ethereum. We'll see what consensus algorithm is used in Ethereum kind of network. At the time of writing, Ethereum uses a similar proof of work protocol known as Ethash. Similar to Bitcoin, the core idea behind mining is to find a nonce that once hashed, the result is a predetermined difficulty level. Means here also each miner node is given a same problem of solving a puzzle where they need to find a nonce that is satisfying the given criteria of the puzzle in order to find the solution. It again uses different cryptographic primitive for its hashing function, known as SHA-3, while Bitcoin was using SHA-256 algorithm. Ethash is designed to make Ethereum both resistant to the high-powered mining chips that currently dominate the Bitcoin industry and more accessible to light client implementation that allow users to use Ethereum without needing to first download the Ethereum blockchain to their device. However, light clients download headers of the blocks for reference. So if you remember about Bitcoin discussions that happened in our previous sessions, all the validator or miners nodes were downloading the whole Bitcoin network inside their computer or computing node in order to form a new block inside the blockchain network. And they were including the previous block information inside their candidate blocks in order to generate the new blocks and participate in the competition for new block generation. And for that, if the node, the participating node was having high amount of computing power, then there were more chances of it to become a winner, and the blocks and the nodes with the less computing power were always striving to survive and compete in the competitive network that was having high amount of computing resources available to generate bitcoins. This problem Ethereum tries to solve at some extent by providing different kind of cryptographic algorithm, consensus algorithm using Ethash. So what this term says is, and how it is designed, it is again resistant to the high powered mining chips. It won't allow computation when you are having high powered mining chipsets that currently dominate the Bitcoin industry, and it is also easily accessible, more accessible to the light client implementation which has low resources, and in this they allow fairly all the participating nodes to participate and create new blocks without getting dominated by any other nodes on the basis of their computing power. But in order to generate new blocks and get the reference of previous blocks, the light clients can download headers only of the blocks for references that are existing already in the blockchains, because each new block will contain the reference of the previous block that will become the parent block of the same in future. Ethereum does far more processing than processing transactions. Means rather than apart from processing transaction, Ethereum does many other work as well. The Ethereum blockchain is intended to do far more than processing just shared transaction. It is designed to execute complex code called smart contracts, where the functionality is only restricted by the imagination of its developer and accessible resources. The complex codes are executed in Ethereum Virtual Machine or EVM. So by writing smart contracts and logic, you can run your complex code on Ethereum Virtual Machine that can form logic and standard by collaborating your business rules in order to serve as a real virtual entity in order to process and approve and validate your transaction inside Ethereum blockchains. Ethereum releases. There are few that are discussed here like Metropolis, Serenity, and this can be defined as, for suppose for Metropolis, it is the next major Ethereum upgrade, and Metropolis was introduced on GitHub for testing, and it's just a matter of time before it goes live, not only introducing further protocol upgrades and opening the door for Casper, but also new interfaces for non-technical users as well. This will help gain further adaptation, and also it will help developers create easy to use apps. So Metropolis in short is a step again towards making Ethereum more simple to their developers and more user app friendly. That are made available on the GitHub environment for beta testing and before releasing to the actual official Ethereum network as a new upgraded version. Serenity. Serenity is the last phase in Ethereum network. Release was planned for the start of 2018, but we might have some delays as usually. Serenity goal is to switch from proof of work to proof of stake algorithm, considering the drawbacks of proof of work which exhaust much resources and energy as compared to proof of stake. And how it will do? It will be utilizing proof of stake by using a method called Casper by changing its blockchain, upgrading it to the new version. So this was all about our Ethereum topics and till now, and there are few left that we'll be discussing in coming sessions. So for now, we need to remember what we have discussed here. We discussed about mining in Ethereum, about the Ether currency, which is pet currency of Ethereum, and smart contracts in Ethereum. That is a new concept introduced in order to make your consensus mechanism programmable. We discussed about the gas, which is fuel or transaction fees in your blockchain, Ethereum blockchain, and how awards are mined, given to the miners, which SHA algorithm is used for providing consensus, and what are the releases of Ethereum network. From this session, we'll be discussing about Ethereum development technologies. So let's see. Development technologies that seek to help network. In addition to the main Ethereum blockchain protocol, there are also supporting technologies in development that seek to help the network and components built on the network run more efficiently. That means there are development technologies that are being used in order to build Ethereum blockchain network and protocol in order to run the applications and the components inside the network that are built on the network and help the applications that are using your Ethereum network to run more efficiently. So this depicts actually what are the supporting technologies that are supporting development inside Ethereum blockchain. We have MIST application or browser also we can say that helps you developing and testing your Ethereum codes. Then we have decentralized applications that can be running on in form of Ethereum network. Then we have Swarm that is used for storage. Whisper is being used for messaging, and EVM, that is Ethereum virtual machine, is used for consensus mechanisms. Hardware clients. Then we have hardware clients from where a node or a miner can become a validator or miner of that Ethereum network, and they can use it for accessing the Ethereum network and transacting inside it. Then internet. Again, it's an important component which allows you to connect various distributed blocks inside the Ethereum blockchain network. Without internet, you know that we will not be able to access Ethereum blocks. So these all components in cumulative basis form and help driving Ethereum blockchain network. Then Web3.js. What is it? The key connection between the Ethereum network and your DApp application. What DApp stands for actually? DApp is your distributed application. The short form, the acronym is used for distributed applications, and in short it is called DApp. Web3.js provides a key connection between the Ethereum network and your DApp. Web3 allows you to compile, deploy, and interact with your smart contracts. If you go into developing Ethereum blockchain smart contracts, you will require Web3.js or another similar component in order to run your developed network smart contracts and test them before releasing them onto the in form of distributed applications. So what Web3.js provides, it provides a platform to your distributed application in order to compile them and test them about the behavior of the code you have developed. So if you could see from the diagram, the compiling, deploying, and interacting with Solidity contracts is part of your distributed apps. Now what happens when your code is developed, it will be sent in step 1, it will be sent for compiling, and when they say compile Solidity code, so I must tell you Solidity is a major part of your Ethereum development, and it is the language that is being used in order to write your smart contracts. Okay, so it is a new language you can say, which is similar to JavaScript with some more modifications in according to support your Ethereum blockchain network. Then if a code is submitted, Solidity code is submitted for compile, it will be done through compile using standalone sols, that is Solidity compiler, or it will be compiled using Web3. Once it is compiled, your Solidity compiler will produce npm package, and if it is that will be used to compile the whole developed package, and in compile using Web3 compiler will be used to compile the Solidity code. And once it is ran on local Ethereum nodes sols, then it will returning your bytecode in result to produce the package. And if it is done through a standalone Solidity compiler, it will be returning Solidity bytecode directly to the distributed app. So this is very clear from the figure. You can see and depict the behavior of the compiling of your smart contract inside Ethereum blockchain network. Then once the code is compiled and bytecode are returned to the distributed app, the second step will be to generate ABI deployment contract from the bytecode and execute contract functions. So again, Web3 platform will be used in order to generate the ABI and deploy your contract from bytecode. Bytecodes are if we talk about layman terms, they are generated executable that is returned from compilation of Solidity code or package. Okay, so once these are run on Web3 platform, they will be able to make RPC request. Okay, RPC stands for remote procedure calls, and this will help to interact with your local Ethereum node, example Geth. Okay, so Geth is again local Ethereum platform that you can have for your development purposes or for POCs or learning purpose. In turn, it will interact, communicate with the Ethereum network to deploy and interact the contracts over main Ethereum blockchain network. Okay, so this is how your web3.js, it will help you compiling your developed code and returning the executable packages that is called bytecode in return, and then these are used in order to generate packages and interact with the and submit the transactions or in order to deploy on the Ethereum blockchain network. Okay, so hope this is clear to you. One thing I forgot to tell you here is ABI. Your ABI stands for Application Binary Interface, and that is generated from compiled Ethereum code, Ethereum Distributed Applications bytecode. Now, the second important component in your Ethereum testing or development part is MIST application. Styled as a decentralized application discovery tool, MIST is meant to serve as a wallet for smart contracts that features a graphical user interface. A desktop application is used to communicate with your node, allows users to dynamically set transaction fees and manage custom tokens. So, what is MIST application supporting? MIST application in short is supporting your wallet creation for smart contract storage, and it provides you graphical user interface in order to interact and do your job on the MIST application. You can use GUI to create your wallets for storing smart contracts, and when you have set up all this, you are using your desktop application in order to communicate with your Ethereum node. You have to log in and attach this to your Ethereum blockchain network. Okay, there in MIST application wallet, you can also set transaction fees, and you can also manage your custom tokens that are generated as part of Ethereum blockchain transactions. MIST browser versus Ethereum wallet. So MIST browser is also called MIST distributed app browser. MIST is a browser for decentralized web apps. MIST is still heavy development. It's not recommended to visit untrusted distributed apps until the full security audit is done. The current release allows you to open any Ethereum distributed app with the MIST browser. So, MIST browser is nothing, it is providing you a complete platform in order to create your wallet and run your Ethereum codes. It works as a browser where you can go and test your distributed applications, deploy and test your distributed applications, and check their behavior. Again, since it is a heavy development and all distributed apps are residing or connected on this network. So while you are deploying any new app or public app, you need to be careful before deploying it to the MIST browser. You have to be sure that whatever you are deploying on the MIST browser is really authentic and will not harm any existing nodes. Ethereum Wallet Distributed App. The Ethereum Wallet, also known as the Meteor Distributed App Wallet. These releases are therefore called Ethereum Wallet as it only offers a bundle of the MIST browser with a single distributed app, the wallet. The future with Metropolis release will provide a full MIST browser able to open any distributed app available out there. This means this is again kind of wallet that is provided inside Ethereum distributed blockchain, and this is also known as Meteor DApp wallet. So it helps you to offer a bundle of MIST browser with a single distributed app. You can run multiple MIST browsers in form of bundle inside a single distributed app that is called wallet. Okay, Ethereum clients. So what Ethereum clients are? Ethereum clients to interact with contracts. So these are the platforms provided by Ethereum or third-party developers in order to interact with your contract inside Ethereum blockchain. Developers write up the contracts, which are then converted into the EVM bytecode via a EVM compiler and uploaded onto the blockchain using an Ethereum client. So every developer that is developing inside or for Ethereum blockchain network will be writing their own code on their local laptop or desktop or any device. When they want to test it, they will be compiling this EVM bytecode via EVM compiler that is available maybe Web3.js or any other, and the compiled bytecode need to be uploaded on the blockchain using a Ethereum client. So in order to interact with the Ethereum blockchain, you need to have an Ethereum client that will help you to upload your code and test there on blockchain network. There are various clients supporting the Ethereum network. Let's see what these clients are and what purpose they serve. Clients of Ethereum. Since the start of the Ethereum project, there have been multiple client implementations across a range of different operating systems and programming languages. So this client diversity is essential for the long-term health of the Ethereum. That means very simple. Every vendor, every third party has become a player in order to develop different clients that can interact, that have capability to interact with your existing blockchain, Ethereum blockchain network. And if we all know that if there are more vendors, more suppliers, then it will be again a healthy competition and it will help surviving your Ethereum network for long term inside the market. Ethereum clients are software that allow users to approve transaction and blocks, create, manage accounts on Ethereum, send and receive transactions from to your Ethereum accounts, deploy smart contracts onto the blockchain, and mine Ether on Ethereum blockchain. If you could see and if you have attended or if you know about Bitcoin blockchain, so these are all the functions that a miner does. Has every client has the capability to become and provide you all required features that you want to do on Ethereum blockchain. You can approve transactions, you can approve blocks that are for new generation, you can create manage accounts on Ethereum, you can keep your wallets maintained, you can send receive transactions, you can create new transactions from your Ethereum accounts that are signed up inside your Ethereum client. You can deploy your smart contracts onto the blockchain and run them. And again, you can mine Ether on the Ethereum blockchain. That means you can become a validator or miner and participate in creation of new blocks. And return, you can get Ether as reward. And so if you have a client of Ethereum, you can perform all these functions. This slide depicts list of Ethereum clients that are available in the market. Client Go Ethereum is a client of Ethereum that used to interact with the Ethereum blockchain, and it is using language Go. That is very popular client among the blockchain market that is generally used with the Ethereum blockchain. It is developed by Ethereum Foundation. The second is Parity. Language used is Rust, and developers are Core. CPP Ethereum, that is based on C++ and is part of Ethereum Foundation. Then we have PyEth app, that means Python Ether app. It is again developed by Ethereum Foundation. Then we have Ethereum JS lib, that is based on JavaScript and uses this language to develop the smart contracts, and it is again a product of Ethereum Foundation. Ethereum J, that allows you to write your smart contracts in Java language and is developed and introduced from ether.camp developers. Then Ruby Ethereum. You can use, if you have good knowledge on Ruby, then you can use Ruby language and Ruby Ethereum client in order to develop your smart contract, and this was introduced by Zenji. Ethereum H, Haskell. If you are expert in a Haskell language, you can use it in order to develop Ethereum smart contracts, and it was introduced by Block Apps developers and organization. So if you could see from the table, now you understand if you are mastering any or if you have knowledge or idea about any of this language, Go, Rust, C++, Python, JavaScript, Java, Ruby or Haskell, you can pick your Ethereum client accordingly and start developing smart contracts and logic in your Ethereum blockchain. Just to tell you, Go is again a form of JavaScript only. If you know JavaScript, you can quickly learn Go and start creating your blockchain smart contracts in Ethereum. So Go Ethereum, in short, it is called GA. The Go Ethereum client is commonly referred to as Geth, which supports the running full Ethereum node implemented in the Go language. Current features of Go Ethereum: it can be integrated with Mist browser. It is light client, beta, Swarm and Whisper used for POC, and these are proof of, and they can be used as an important component inside blockchain smart contract development. If you remember the previous diagram, your Whisper was used for messaging inside your blockchain structure, and your Swarm was used for storage. This figure clarifies more on it. Okay, so friends, this was about this session where we covered our Ethereum clients. We discussed about different Ethereum clients available, and then we discuss about Mist browser, Web3.js as compiler, and as part of development technologies for Ethereum. Okay, so now in this session, we will be discussing about platform functions. What platform functions are? Platform functions in Ethereum, while the architecture of the network is certainly impressive, it's what's built on these intricate components that truly illustrates Ethereum potential. Let's have a look at the various platform functions in Ethereum available. DAO, called Decentralized Autonomous Organization. DAOs are organizations that exist entirely on a blockchain and are governed by its protocols, a unison of many long-term smart contracts between many people. DAOs are designed to hold onto assets and use a kind of voting system to manage their distribution. Two or more entities in DAO can interact with each other in a fully decentralized and automated fashion. DAOs also comprise a global network of nodes and members that all works together. So DAO is a global network of multiple nodes and members, and in order to work, they are working together to accomplish a design goal. In the DAO, each action or vote is represented by some form of transaction in blockchain. So, and as we know that every transaction in blockchain, Ethereum blockchain requires fees. So that means every action or vote will require a fees in form of gas or maybe some other mechanism. So we see that this how decentralized automation organization are taking part inside Ethereum blockchain and helping to action or vote inside or interact with the transaction inside Ethereum blockchain network. Okay. Working of DAO. How DAO or distributed autonomous organizations works inside Ethereum blockchain. A group of people writes a smart contract to govern the organization. That means, since we have already discussed in previous sessions, that any blockchain will try to not have any central authority or any mediator. And that is again a robust feature of any blockchain. So this comes a complicated situation. If there is no third party or any authority that is available in order to approve and validate a transaction, how it can happen? So like Bitcoin, we have smart contracts in Ethereum that are helping in order to govern the organization and validation of transactions. Smart contracts are nothing. We have already discussed these are the logics that can be derived from your business requirement as part of validation logic, as part of execution logic, transactions, or any other part of participation. So we have in DAO, we have a group of people that are writing smart contracts to govern the organization, and people that add funds to the DAO and are given tokens that represent ownership. So any participating people or node need to add the funds to the DAO, and in return they will get tokens, and that will be representing their ownership, that they are part of the blockchain network now. The DAO begins to operate by having members to propose how to spend the money. Since they have spent and they have become the part of the blockchain, now they can decide and they can start operating to and can start proposing how to spend the money inside that blockchain network. They will also participate in order to vote the members on these proposals. When the predetermined time has passed and the predetermined number of votes has accrued, the proposal passes or fails. So any proposal started within the by the DAOs and as part of the proposal to their members, they actually they vote to the proposals generated, and then after some time, that is decided time, the votes are counted, and if the votes or proposal has sufficient number of votes, it will be passed inside the network, otherwise it will be declared fail. Individual acts as contractors to service the DAO. Individual inside the in this kind of scenario act as contractors, and they are present to service the distributed autonomous organizations. Example of DAO. So by now, I think there must be some confusion in your mind about DAOs. This figure will try to explain what DAO are actually and how they are contributing inside the Ethereum network. Let's see an example like the step 1. A country holds an election and wants to prevent voter fraud. So what DAO can be used? A DAO should be created to safeguard transparency and eliminate vote rigging. Now it will be DAO's responsibility once created that there is transparency to the voting and there should not be any fraud happening or any gambling happening inside the voting system. The third step would be to ensure by embedding the predefined condition inside the code. So everything we know that is happening is using the smart contract, and this smart contract need to have a logic in order to define the condition into the code. Then once codes are written, voting tokens are issued to everybody eligible to vote. DAOs now, what all the eligible voters available inside the market will be getting the voting tokens, and they will be eligible to participate for the voting of DAOs. And then people start voting, or every vote is recorded and processed on the Ethereum blockchain which ensures transparency while allowing everything to run by itself and decentralized. Could see that every vote is recorded and is being processed on the blockchain network, and this way you will be having that transparency on the transactions and votes that are being generated inside the blockchain network, and which you can anytime audit or validate by going to the transaction list. So once sufficient votes are given and passed, and then a DAO will be elected inside the blockchain network. Now, since we understand now what are DAOs and how they are generated or created inside the Ethereum blockchain, we will be learning another important topic, DApps, that is decentralized app. Decentralized apps or DApps are computer applications that operate over a blockchain enabling direct interaction between the end users and providers. So, since we know blockchain is a huge network that is residing all over the internet and very much distributed. So we need to have some mechanism using which users can be able to interact with your blockchain network easily. And here your distributed application comes into picture, which helps you allowing interaction between your blockchain network and users. Okay. So DApps can be comprised of single DAO or even a series of DAOs that work together to create an application. A decentralized application has an unbound number of participants on all sides of the market. That means it can have any number of participants that can launch it and use it to interact with the blockchain network. Etheria is an example of distributed app. You can visit this etheria.world and use it as a Minecraft-like game. That is simply interacting with the Ethereum blockchain and helping you to understand the blockchain network and helping you to interact with the Ethereum blockchain. Let's go to this site. Okay, so you can simply search this on Google and you will be getting the blog about this Etheria blockchain network distributed app. If you could read it, Etheria is a virtual world in which players can own titles, farm them for blocks, and build things inside the Ethereum blockchain. The big difference is that the entire stage of the world and all popular actions are made through the decentralized, trustless Ethereum blockchain. So this you can use simply to play a game on available game on Etheria, where Ethereum blockchains are used. Okay, more details you can search and look on by going to the Etheria website. It's taking some time to open, so let's have some patience. I think the link is broken or down. Etheria.word is not working. Okay, let's see some other distributed app on Ethereum. Let's try searching some different strings. It's not generating any result. Etheria.word was working. I don't know why it is not working. Let's see this link. Okay, this page gives you few example of Ethereum distributed apps. One is your MetaMask. It is very popular and it is used to issue, even if you are a developer or tester of or doing a POC on Ethereum blockchain, you can use MetaMask in order to get some free tokens or free ethers on internet. Okay, so this we'll be using in our demo sessions. Then you have lot of names like Toshi, and you can have this Golem, Augur, Gnosis, Aragon, Tocket, Yuju Music. These are all example of Ethereum blockchain distributed applications, DApps, or you can say DApps. Let's see about this. Gitcoin is very popular. See, Gitcoin is again based on your Ethereum blockchain network, and you can start here as a developer and start building your coins or Gitcoins inside your Ethereum blockchain network. So this is using completely your Ethereum network in order to build cryptocurrency, that is Gitcoin. Okay, so these are few examples of dApps that we have just shown here. You can go into more detail about these examples and learn more about these Ethereum DApps. Okay, now we'll be discussing about types of distributed apps. Since we already discussed what distributed applications are the means in order to interact with your Ethereum blockchain network. They helps you participating inside the network and doing the transactions on and as part of the Ethereum blockchain network. Types of the apps. We also saw various various is the Ethereum blockchains available in the market that can be used to interact with the Ethereum blockchain network. So the first type of DApps is peer-to-peer transaction that uses a money app as Ethereum and uses the network has a lot of nodes connecting to this money app or Ethereum network, and then you have peers transacting with each other. So in this network, a user may need to exchange Ether as a way to settle a contract with another user. Since we have already discussed, Ether is a means of transaction, or you can say the currency of Ethereum blockchain network. So majorly it will be used in order to exchange the transaction or exchange the money in your distributed Ethereum blockchain network. So any contract or any transaction is settled using the Ether by transferring the Ether from one peer to another. And that is using the network's distributed computer nodes as a way to facilitate the distribution of this data. So in this first type of distributed app, peer-to-peer transaction is happening directly, and they are exchanging the Ether as part of or charge applicable for their blockchain transactions. Now comes the second type that has external authority on top of blockchain or Ethereum blockchain application. Example, oracles. The app mixes money with the information from outside the blockchain. For example, a crop insurance application that's dependent on an outside weather feed, say a farmer buys a derivative that automatically pays out if there's a drought that impacts his work. Okay, so if you could see, the second type of distributed app is having the basic blockchain application plus additional logic in order to meet the market demands. The current example gives you example of crop insurance application where the farmer buys a derivative that will be automatically paid if there is a drought impact on his farming, on his crop production. Third type is peer decision makers. Here, multiple peers are evolved for creation of DAOs or other objects inside the blockchain network. So third type is DAO. The goal is form a leaderless company where we'll not be having any leader or central authorities or board of members, you can say. And then program rules at the beginning about how members can vote and how to release company funds and then let it go. So using DAO, you are creating a leaderless network using the Ethereum blockchain, where these logics written in form of smart contracts will help solving all the actions that were being done by leaders inside the company, and this way automating the whole process of consensus or you can say validation using DAOs. Now, future of distributed apps. As Ethereum and other projects have made writing DApp protocols quicker and more accessible, a number of possibly disruptive dApps have appeared. There is one is KYC chain. KYC chain allows users to maintain private identity wallet, which can be used to authenticate their identification in finance, legal, or commerce settings. Then another kind of the apps is Wayfund. Wayfund uses smart contracts to enhance crowdfunding services, including GoFundMe and Kickstarter. So whenever you want to release your funds in form of batches, this Wayfund provides a good mean using smart contracts in order to do these kind of transactions. It stores.io. Stores provide censorship-free, secure, and zero downtime distributed cloud storage by sharing data and storing it among a decentralized network of computers. Okay, so stores.io is a form of cloud that is or just cloud-based storage for sharing your data and storing it on decentralized network of computers. So these computers are connected in form of Ethereum blockchain and they're helping to store data online. You might have heard this stores.io as part of the various applications for cloud storage. Then comes 4G Capital. 4G Capital provides microloans for small businesses in Africa by utilizing the smart contracts. Note, a curated collection of various dApps can be seen at this address, the state of the dapps.com. So we will try to visit here and see various kind of distributed apps available. Okay, so if you see here, this page give you all a glimpse of all available distributed apps that are using Ethereum blockchain network. You can use, you can purchase, you can acquire any kind of app as per your requirement from this list of available apps. These are categorized here well as by their ranking, by their platform. You could see storage available here. If I go here, I could see the details of storage. I can add it to Drive and use as the cloud storage. You can also visit website of this DApp stores.io here on this website. This page is giving a quick view of all these distributed apps available, and you can have more details on by going to the company website. You can join the waitlist, right? Decentralized cloud object storage that is affordable, easy to use, private and secure, and completely built on Ethereum blockchain. Then we can also have look on some more kind of, let's have a look on this gaming category app. See, we have a lot of games developed on top of blockchain, Ethereum blockchain. You have Stream Monsters, Lordless, US Knights. For more information and more knowledge or more experience on this blockchain, you can start playing this game and see how this works. The more you explore, the more you learn. See? Okay, get your time and try playing this game or other applications try to use. You will get a flavor of distributed or distributed ledger Ethereum blockchain. This will really help you understand the applications running on the Ethereum blockchain are similar to the applications that you are using in nowadays on centralized application network. But the backend platform is completely different that is using and built on blockchain network. Since we are going through this demo, we will see, we already discussed about web3.js. We will just see what it is and what it stands for. You can go to this page and learn more about web3.js uses. This is your Ethereum JavaScript API. If you read more about it, it is a collection of libraries which allows you to interact with a local or remote Ethereum node using HTTP or IPC connection. Okay, this can be set up on your laptop in order to run and compile your smart contracts for Ethereum blockchain network. Okay, you can download this npm package of web3 if you have npm installed on your system. This way also you can install web3 on your system. Npm install web3. Okay, we will see all this while we are doing demo about Ethereum blockchain. So till now, since we have already learned sufficient information about Ethereum blockchain, now before moving to Solidity, we will try to do some demonstration about how to set up Ethereum blockchain network on your system. In order to set up Ethereum blockchain, you need an Ubuntu flavor or some other Linux operating system. You can do it on your Windows and Mac OS system as well. So for the POC purpose and for this session, we will be using Ubuntu 16.04 machine. And for the sake of easiness, I'm using my Google Cloud machine, which is of same version of Ubuntu 16.04 LTS. I can show you. So if you could see here, it is a Ubuntu 16.04 LTS machine. So going back to the dock, see what are the minimum requirement. You need to have OS 16.04 Ubuntu and minimum 2 GB RAM. You need to set up a virtual machine in order to set up your Ethereum network. We have already discussed what Git is. Go Ethereum using Go language for developing smart contracts is used, and we will be setting up same here on our Ubuntu machine. Let's update our packages. Once updated, we will be installing our common software properties using the command sudo apt install software properties common. Since I am on already latest version, I just need to move to another step of installing our Ethereum. So this command sudo apt get repository will add your PPA package of Ethereum into the Ubuntu repository. So this package is successfully added. You can see the GPG key ring is already created and added inside our package file. Once the entry is added, we will again update our Ubuntu packages to grab and pick Ethereum installation. Once package is updated with the Ubuntu Ethereum links, we can now install our Ethereum packages on our Ubuntu machine. So when we try to see when get is installed, we can check its version using get version command. You can also try the availability or check the availability of get on your machine using get command itself. Get -l can be used in order to see the manual or help syntax of the get commands. Okay, so we need to be patient and need to wait until our Ethereum package get package is installed on my machine. It will require another 15-14 seconds to install the complete package. Okay, so it has fetched all the packages now installing on the machine. Just try to see what version of this machine it has installed. You could see Git 1.8.20 stable version installed in folder user lib go 1.10. So this way we can see Git is successfully installed on my machine. Now I will try to set up one project for my Ethereum blockchain. Let's go by the document only in order to avoid any command mismatch. Once project is created, once project folder is created, I will go inside it using cd, and now we'll create a node app in order to add script files containing git commands. Let's see. Let's create node underscore app inside my ETH folder project. Now, once my project folder is set up, I need to create a new account inside directory node app. So let's cd to our node app and try to create one account file using like account.sh. Okay, so I need to set up this command inside this file. So when I will be running or executing this file, this command like get -dir, the dir is the dir node directory inside our machine that will be storing all data related to this account new. So here from the syntax you can see get is the command that we are executing, and -data dir is the argument to it for data folder, and account used is new. Once created, I need to change the permission of it is u plus x in order to make it executable file. Okay, so once it is changed for permission, it is executable, I can try running this command and can create the new account. So while you are creating a new account, you will be asked to input and password. I can enter ether123 as passphrase, and my new account will be created here. You could see while creating your new account, it has already provided you an address in form of bytes. Okay, so now when you see here, you can follow the diagram and you can follow the steps in order to check your account file or account directory generated. Okay, you could see here one account, one folder ETH node in respect to your account creation has been generated. Okay, I can go inside it and I can see what are the directory structures here. Okay, tree is not installed. Let's install this first. Tree is not required for blockchain, but instead it is a Unix command that is used to show our directory structure in form of tree. That is more convenient to see and observe. That shows a pictorial representation that you can see for your in our account folder. We have key store created for my account ID address. If you see this string matching here, the key store content contains the UTC time creation of this account, followed by some digits and then the address of the new account generated. If I go here and run this tree command again, I could see similar hierarchy or similar structure as shown in this document. Now, since we have created one account to run our blockchain network for Ethereum, now we will be starting to create our blockchain by creating a new Genesis block. If you remember, we already discussed about Genesis block, which is the very first block inside of any blockchain network that remains at the position 0, and our blockchain starts from that block itself. And that's why, because it is responsible for generating the whole blockchain, it is called Genesis block. So let's create one JSON file in my project folder called genesis.json, and I will be putting this content inside the genesis.json file. Okay, so you could see here the whole JSON content is using certain syntaxes like config. It will be assigning a chain in config. It will be assigning a change ID, and then it will be creating this block with home state block ID 0, then EIP block 0, EIP 155 block, and EIP 158 block. Then Coinbase will be 0 in hexadecimal, difficulty will be 0 into 1, and this gas limit will be in hexadecimal, some value, nonce, and all other things that will be used during creation of Genesis block. Here, alloc properties will fill your accounts with Ether you need to fill account address with the previously created account. When you set up get on your computer, you need to use the same genesis.json file in order to make successful connections between node. That means this genesis.json file will be used again in order to perform future transactions. So in this file, I need to replace the account address, that is this part, with the address generated during account creation. So let's create a genesis.json file, and here I need to get my address copied inside the JSON file. This was my account address. I need to make a note of it. Let's place this in place of account address. Okay, so this way my genesis.json file is complete now. I can proceed further in order to create my Genesis block. Now I will be creating an init file in order to generate this Genesis block, and will be copying and pasting the content, this command, from the document. This is again a get command in order to create your Genesis block. What it is doing, the command uses get command, then it provides arguments data directory to be used as same as your Ether account, and then init command in order to create my blockchain using genesis.json file. Let's change the permission of this file to executable, and I can run it now. So if you see, using this JSON file, my first Genesis block has been generated with these properties. A database for this lies here in this folder: home, vista, sunil, eth code, get, chain data. Cache will be 16, handle 16, nodes are 1, size is this 152 bytes, time in microsecond it is 59.78 creation size, and there are other information when you are creating this Genesis block. This way we have created our first Genesis block for our first Ethereum blockchain. So now next step will be running get and interacting with JavaScript console. We will be creating a file called console.sh in order to run the console. Let's copy the command again. The whole line need to be part of this. It is again a get command which is taking input of data directory that you have created for your account, and the console argument will be provided as no discover. So this is done. Let's change the permission again and run this console file. Okay, so now my Ethereum blockchain console has opened, where I can run my multiple commands in order to check my transactions. So you could see here the blockchain has populated, and the self address and whatever it is providing here, you can read and understand. There are all the properties that are logged in the log file of the console. Now when console is open, I can test basic commands that are valid inside JavaScript console. I can check my Ether accounts using eth.accounts command. th dot. Okay, so this is not showing anything as of now since I have not added the account yet. I can also see the account balances, but get balance. Okay, so there is some issue. It is not listing my account. Okay, so it is not listing my account. I think there is some problem. Let's troubleshoot. Troubleshooting always gives us learning, right? So let's see what problem we have done here. There must be something. Okay. Oh, so problem lies here. The data directory of my account I have given is wrong. So let's change this. It was taking one level up. So once I have done it, I can try running again. And now let's see if it is populating the accounts. Okay, so now it is populating my address here. I can also check the balance. eth.balance, eth.account 0. Oh, sorry. Get balance, sorry. Just did a silly mistake. Okay, so get balance is the function to get the balance of any account. I have 0 balance in my account. Suppose you have multiple addresses. Now how you can list the accounts? In that case, these accounts are stored in form of array inside the get. So you can give index of the array in order to get the account. Now again I did a typo. It will be S, and you can see 0. If I had another account, I could have given 1 in order to find the second address. So if you see here, it is undefined. We have created only one account as of now. Okay, so since we are able to run my script commands inside get console, I am able to list my addresses and I am able to get the balance of account using this. Now we can see how transferring ether happens between the accounts. So our account by default remains in lock condition. So in order to use them, I need to unlock them before using. So what I can do, personal dot unlock account, it should be capital, then account address. I can also give directly the address of my account. That will also work. Okay, so my account was logged using the passphrase that I have given, and I had given ether123 as passphrase. I think I given wrong key. Let's try typing again. EHER123. This time, yes, got locked, unlocked now. Now I can use it to transfer ether from my balance to another account. The command used for sending transaction is, or initiating transaction is eth.send transaction from account 0 to from account 1. To utilize this, I need to create another account. Okay, so since I do not have balance, I will not be able to test this, but still I can try running this. I can create another account, create fetch. I think I have moved my account.sh. Suppose I name it 2. The name of the account I use as 2, and I create it again. Account. Sorry, I need to change the permission first. Plus x account dot sh, then account. Okay, let's do this. Let's provide a password again for this new account. Say ether123 again. ether123, and it has created this one more account that you can see inside your data folder. Okay, I need to list inside key store. Yes, so this has created another account with the address 5t44 and inside my wallet. If I try to run console again, not accounts, if we can I had not started the mining, I forgot to do this. Now when I start mining, our blockchain balance will start increasing it as it will start mining the new coins inside the block. So I had missed this step. So let's see how mining is happening and what it is doing. Okay, so if you can see, transaction is running and there is some percentage of transactions generating DAG is in progress, and this as this will process, it will be mining some new work. Okay, so let's click one more console. I will launch one more instance of my machine. Let's create another instance of my Ethereum machine where I will try to create another address, one more account. So until it is launching, let's see what is happening inside mining of new block. So my new machine is launched. The other instance is launched actually. So I will be going inside my project folder, ETH project, and I will try to run my account creation again. Okay, so if you see, I should be able to create another account, and when I run this, I should be able to see two accounts now. Let's see if it is populating inside the console. I need to kill this first. Launch the console again and try doing listing of accounts. It's not listing. Something I have missed here. Okay, so since I have run account.sh again by going inside the node app, for transferring the accounts, I need two accounts. So that's why we are creating second account in order to use my Bitcoin addresses in order to send coin from one node to other. Okay, so this script I have run twice and it has generated another address. So now let's go to the project folder again and run console.sh. Let's try populating the accounts again. You could see now two accounts are available here, and now we can use the scripts to transfer coin or money from this account to this account 0 to account 1. If you want to populate them, you can populate them based on their indexes 0 and then 1. This way I can traverse all my Bitcoin addresses of accounts. So what's next? We will be transferring coin balance from first node to second node. In order to transfer this, I have to unlock my account again because I have just created it. So run this command, unlock accounts th.account 0. Again I have missed. I'm missing us again. So I will try to not miss this time. Okay, so this account needs password in order to unlock. I given and it is unlocked now. Similarly, once account is unlocked, I can transfer fund from first block or first node using eth.send transaction. I need to give from and to in order to give the addresses of sender and recipients. th.accounts 0, then comma, then 2 will be, sorry, I forgot to mention from. Should mention from. So the whole data you are mentioning here should be in JSON format. Okay, spaces doesn't matter. You can keep them or do not keep them. They will not impact your execution. So this is your JSON formatted input to send transaction, and comma, you have to mention the value, also the amount of value or value of balance you want to transfer. Say some value. I will just use 10,000. You can say 10. Let's keep it smaller because we are having less balance in our wallet. Let's try running it. Exceeds block limit. That means I do not have sufficient balance. Okay. If I had balance, I would have successfully transferred the 10 ether from first account to second. Let's try to mine some blocks here. I may get some balance. Okay, so you could see here transaction pool price threshold updated to price. Okay, I will just try to kill this and I will check my balance. Still I have zero balance only. Need sufficient mining in order to generate the balance inside the wallet. So I will not go into more steps. Now you must be having a feel like how you can create your addresses and how you can transfer funds from one node to other. Okay, so now making sure go get node is mining by checking a boolean property. Let's see why we were not able to do mining. But maybe it is set to false. Yes, so I need to enable this value. Check balances again. Okay, so I need to set it is equal to false. Okay, this is set to true now. Let's start mining. Try to mining again. Start one. Okay, let's see. Th.get balance for the first account. It's not generating again. Okay, so if you see, we were not able to generate balance by mining the miners. Okay, so when I checked, I found problem with my Genesis block file. That means in my Genesis block.json file, I had given wrong address here. So because of which my account balance was not generating. When I did that, I updated the correct address there. I am able to generate my ether balance here. If you could see here, I got balance some here, and if I do start again the mining, miner dot start one stands for thread. In within bracket you give the thread for miners to start. This many threads can start and proceed with the mining. So if I can do it again, close it again, and check the balance, eth.getBalance, then get eth.count 0. Could see the balance has generated here. So in order to transfer the ether from one node to other, I will create one more account using my .account script. I will keep the same passphrase for this as well, ether123. Okay, and I need to capture this address. This is very important. Because of this, we had to face issue there. Okay, I have recorded the address, and now I will try to unlock my account from the console and do the transfer of money from the transfer of balance from node 1 to node 2. Okay, account 1 to account 2. Let's unlock this. Personal dot unlock ETH dot 0. Oh, spelling mistake again. Okay, so I need to give the passphrase here. When I give correct passphrase, it should be unlocked now. Now I can transfer the balance using this. First of all, let's check the balance of second node as well, second account as well. And when I check the balance using get balance, th dot 0, could see spelling mistake. Okay, so this is for 0 and for 1, could see 0 balance. Now when we try to transfer here this much of ether from one account to another, this does, oh, okay. So I have successfully transferred this amount, and this is the transaction ID for this transaction. Okay, now when we will try to see the balance again for this is for second account, see the balance has not updated yet. What could be the reason? Okay, so since we were able to transfer amount from one account to another, and the whole setup we did here was running as a single node with own Genesis block. And now we will be learning how to do get with multiple nodes. We will create a file inside my node app folder named static nodes.json. Okay, so before doing this, I need to in the console again and get this ID, the admin info of the nodes running. Admin.nodeinfo will give you the node information of current node. You see, this is the node information of current node that was created using this Genesis block file. If you remember, the same information we provided in the genesis.json file. You could see its listener address here, name and encode. So the property we are interested is encode that we'll need to put inside the static nodes.json file enode. Okay, so let's copy this information. So once our static nodes.json file is there, I can copy this folder to another computer. Since I have one computer here only, I will just telling you the steps here rather demonstrating the whole thing on my computer. You can follow these steps and run this whole setup on multiple nodes. Once this is available, you can copy these all scripts inside node app folder to another computer and try doing the same exercise. Once it is done, you can again start the get using .console.sh file, and you can do all your inquiries in the node script console again. So this command is not running here because we are running in a single node mode only. So this whole thing, the whole transaction can be repeated again on multi-node as well. So this was a small demo about setting up your Ethereum and checking the information on Ethereum console, get console, that is called Go Ethereum. Okay, apart from that, there are multiple other script commands that you can run and get the output. Okay, you can get like we got our node information using admin.getNodeInfo, and similarly you can use other command as well in order to get more information about transaction. Also, you can get the head information, you can get the number of blocks. If I run it here without giving indexes, I can get all accounts that are existing as of now. See, we are getting an array of string here. You can also calculate the hash rate, the rate at which hashing is being done using eth.hashrate command. Current hash rate set is 0. You can also, like you do miner dot start, you can also do miner dot stop in order to stop the mining. Okay, if I do here, it will stop the miner. So just to summarize here, we learned about few commands during the exercise, like we learned about how to get Ether accounts using eth.account. We learned about how to get balance. We did this using eth.getBalance by providing the name of the account here. Then we learned how to send transaction by using eth.send transaction by giving the from and to nodes and the balance amount to be transferred in JSON format, actually from to and the balance. Then we learned how to unlock any account before sending the transaction, utilizing the amount present in his wallet. Personal dot unlock account by giving the account name. Then we learned about getting the hash rate, eth dot hash rate. Then another common command is miner dot start by giving the number of threads you want to start the mining. Then we learned about miner dot stop in order to stop the mining. Then we learned about, we can use this admin.node.info in order to get the node information. Okay, and you can further use extensions in order to get particular and value of particular property inside this node.js node info JSON value, like we traverse through JSON formats, JSON values. Okay, we also learned about getting net peer count in multi-node Ethereum setup, Go Ethereum setup. So this was all to summarize about. There is much more. This was just a glimpse of setting small Go Ethereum network on your laptop or maybe on different computers or maybe on a virtual machine or a cloud. So just this was a start. There's a bit more. It's a sea ocean where you have a lot of things to learn. Blockchain is not a small thing. You have to practice hard, and there are various concepts and various kind of setups available because it is open source to market. Everyone is trying to build their own solutions, and if you see, there are a lot of platforms available for blockchain developments. So this was all about this demonstration. So in this session, we will be discussing about Solidity. As discussed earlier, Solidity is a programming language that is used in Ethereum in order to develop and design smart contracts. It is a flavor of JavaScript only, advanced version of JavaScript written and customized in order to write Ethereum blockchain smart contracts. So, what are smart contracts? As we already discussed, the Bitcoin blockchain stores data that's specific to keeping track of currency balance between parties. The Ethereum blockchain expands on Bitcoin in that it can store and do much more than the Bitcoin blockchain. Ethereum allows developers like yourself to build decentralized apps, and these decentralized apps are defined by the smart contracts. A smart contract allows individuals to exchange data in a trusted and conflict-free manner without relying on a third party like a bank, lawyer, or notary. So these are written in such a manner that they embed the business logic and the transaction logics that your organization is trying to implement through the blockchain decentralized app. Due to smart contracts only stored on the Ethereum blockchain, they need to be validated or mined like a regular transaction. So whenever you are writing smart contracts, you need a language to write your programs. There are various kind of programming languages available, out of which Go or Solidity is preferred very much and very popular among all the languages available. So what is Solidity? Ethereum would be incomplete if we do not give a native programming language, and that language is called Solidity. Solidity is a contract-oriented, high-level language whose syntax is similar to that of JavaScript. If you know JavaScript, then Solidity will not be very much new thing for you. You can simply go and write your smart contract in Solidity. It is designed to target the Ethereum virtual machine. What is Ethereum virtual machine that we have already discussed? These are virtual machines that are created for running the smart contracts in Ethereum blockchain. Solidity is statically typed, supports inheritance, libraries, and complex user-defined type among other features. When proceeding further in this course, we will see Solidity has its own set of variables, arrays, enums, and other data structures like any programming language. It also has classes and constructors that can be inherited in order to write and inherit or extend existing classes. In contrast to an object-oriented language like Solidity is contract-oriented, because of which it makes it very popular in order to write smart contracts. It compiles instructions into bytecode so that they can be read by the blockchain network. So in this course, we will see how to use Solidity to create our smart contracts and what are the various component, or you can say functions or design methods or data types that are available in Solidity that can be used in order to write smart contracts. Layout of a Solidity source file. Source files can contain an arbitrary number of contract definitions, including directives and pragma derivatives. Version pragma. Source files can and should be annotated with the so-called version pragma to reject being compiled with future compiler versions that might introduce incompatible change. So whenever you are writing a smart contract using Solidity, the first line it is recommended to be of including Solidity version that your compiler should be using in order to compile your source code. So the first line would be written in the form of syntax that is pragma Solidity and then the version that you want to use or suggest your compiler to use while compiling the source code. And the caret symbol starting of the versions denotes that the compiler or the code version should be always greater than equal to the present version in the pragma syntax. That means here it should be always 0.4.0 or equal to 0.4.0 or higher version. Such a source file will not compile with the compiler earlier than version 0.4.0 and it will also not work on a compiler starting from version 0.5.0. Okay, so this means any compiler between 0.4.0 to 0.4.9 can be used in order to compile the source code. Considering this line is written as pragma Solidity version. Comparison between memory and storage in Solidity. They are analogous to memory and hard drive storage in a computer. That means memory, the contract can use any amount of memory while executing its code. But when execution stops, the entire content of memory is wiped and the next execution will start fresh. This is very common and behavior of computer or computer programs run like this only. During the execution, the program's data is stored inside the variables in memory, and once these are used and processed, then memory is freed up for other processes and executions to use. The storage, on the other hand, is persistent in the blockchain. So the next time the contract executes some code, it has access to all data it previously stored into its storage. So these two terms are generic to our computer systems and computer world, programming world. So there's nothing more to discuss here. General value type or data types, you can say, that are used in Solidity language. There are various kind of, like other languages, it has various kind of data types, like booleans, integers. Boolean may contain true or false values, while integers may be integer, signed and unsigned integer of various sizes. Keywords unsigned int to unsigned int 256 is in steps of 8 unsigned of 8 up to 256 bits and integer 8 to 1 integer 256. Unsigned integer and integer are aliases of unsigned integer 256 and integer 256. So if you are using directly uint and int, it will symbolize your unsigned integer 256 and integer 256 sizes by default. And if you give the number exactly, it will be using that size integer only. There are other kind of variables also available, data types also available. Address. Address is a new data type you could see different from other languages and that is available in Solidity only to hold a 20-byte value for Ethereum addresses. So address types also have members and serve as a base for all contracts. So any account inside your Ethereum blockchain will have an address and it is always identified using this base address only. When we were discussing about type of blockchain and when we discuss about it, we discuss there are two kind of identities in your blockchains, anonymous and pseudonymous. So here address works as a pseudo identity for Ethereum blockchain accounts or nodes. Members of addresses. Balance and transfer. It is possible to query the balance of an address using the property balance. that we have already seen in our previous exercise about Ethereum setup. While we used the function of Solidity console or goeth console that was used like eth.getBalance in order to get the balance of particular account. And we also saw there how we use the address in order to transfer balance from one account to another account. So if we write the same query or same program here in Solidity, the syntax will look similar to below as you can see on the screen. There could be one address x is equal to hexadecimal 123, and then there could be another address of my account can be taken inside my address variable of address data type as equal to this. This again stands for the value of anything inside this object of particular class. So the meaning of this again is the same like Java or other JavaScript syntaxes. So while executing the transfer, the below logic can be implemented in Solidity programming or smart contract. If x.balance is less than 10 and my address.balance is greater than or equal to 10, then x.transfer 10. That means here this logic is trying to send some balance from my account or my address to x address. And in this account, it is checking the condition that whether the balance is again greater than 10 or not in my account balance. If it is there, it will transfer 10 to the X account. So this is simple. If you could see, this is the syntax of the last line is same as, or the whole code is same as, almost similar to your JavaScript code. There are other data types also available. You can use a string inside your programming. So string data types gives you value to use your certain strings as variable, and string literals are written and with either double or single quotes. These will be considered as string literals or simply strings. They do not imply trailing zeros as in C, or like foo represents 3 bytes, not 4. So like we when we were using in C or any other language, we were closing it with semicolon, and that was again counting 1 byte again to the size of particular variable. While in this it will not be needed, and the size of the variable will remain to the count of the characters inside that string literal. As with integer literals, their type can vary, but they are implicitly convertible to byte 1 to byte 32 if they fit 2 bytes and 2 string. String literals support escape character also, like other languages such as /n, /x, nn, or /u, nnn, where n stands for particular number, where x nn takes the hex value and insert the appropriate byte, while /u nn takes a Unicode code point and inserts a UTF-8 sequences. So these are various kind of character coding that can be used while writing your business logics in smart contracts. There's nothing complicated. They are very similar to other languages that we must be knowing as of now. Arrays, very old and very familiar data type that is used in Solidity as well. In the same manner, they are followed and used in other languages. Arrays could be of any kind of, like it could be integer array, it could be string array, or anything, or array of other complex data types. Arrays can have a compile time fixed size, or they can be dynamic like other languages. Like it can be, you can while declaring the array, you can define the size of the array and it can be of that size only and accommodate that number of variables. While in dynamic arrays, you can keep increasing the size and adding elements, and then it can be stored up to the defined size. For storage arrays, the element type can be arbitrary, and for memory arrays, it cannot be mapping. An array of fixed size k and element type t is written as tk. An array of dynamic size can be written as t with just square brackets without giving any size inside it. Variable of byte types and strings are special arrays, okay, that contains arrays of bytes or string literals. Arrays have a length member to hold their number of elements. Dynamic storage arrays and bytes have a member function called push, and that can be used to append an element at the end of the array. Apportioning memory arrays. Creating arrays with variable length in memory can be done using new keyword, and as opposed to storage arrays, it is not possible to resize memory arrays by assigning to the length member. How it can be done, you can see in the given snapshot. If you're writing a code, you can do it like you can call a function with unsigned integer length variable, and unsigned integer memory array is declared as of dynamic size and using a new keyword. New is again used to initiate a new object of that existing classes. That can be your customized classes or user-defined classes, or can be predefined classes in your Solidity language. Like unsigned int is a class of integer variable that is already predefined in your Solidity language. Then inside this function, you're also defining bytes memory variable b, and that you are assigning a new bytes object of given length using the new keyword. So if we compile it and we will get the values like a dot length is 7 and the b length is equal to length of a6, that is equal to 8. Okay, we'll be seeing these samples while we'll be demonstrating and doing practical labs for this Solidity language, and we'll see how data types and other values can be used and can be coded inside your smart contracts. So this way, this was an small example of apportioning your memory arrays. For this session, we will keep till here only.
Okay, guys, a quick info. If you're looking for an end to end blockchain training, we at Intellipaat provide that. And you can check those details in the description below.